Hello everyone, welcome to the comprehensive Angular 19 tutorial by FAD Learning. Whether you are new to Angular or looking to upgrade your skills, this video is designed to help you become proficient in building real-world Angular applications. The Angular team releases new versions every 6 months, each version packed with exciting features, improved stability, and enhanced performance. And since Angular 17, we have seen significant changes, including the introduction of standalone components. So in this video, we will focus on Angular 19 and explore how to work with standalone components. And if you learn anything from this video, kindly let me know by adding comments below. I really appreciate your feedback. It motivates me to do better. So what to expect from this tutorial? This tutorial is designed for both beginners as well as experienced developers. And by the end of this video, you will gain the skills and confidence to build Angular applications from scratch. So this is the agenda of our Angular 19 tutorial, where we will cover all these essential concepts along with both old and new functionalities. So you don't need to worry if you have worked with older versions of Angular. And to get the most out of this tutorial, I encourage you to watch this video until the end. However, if you are short on time, feel free to jump to a specific topics using the timestamps provided in the description. So before we start, take a moment to pause the video and review the topics we will be covering. And if you would like me to cover any additional topics, kindly share them in the comments. I will try to create a separate video on it. So let's start with the prerequisites for environment setup. To create a new Angular project with version 19, we need to consider these three prerequisites for installation. So first is Node.js environment. Node.js is a runtime environment that allows us to execute JavaScript code on the server side. And to get started, we need to download and install Node.js, ensuring that the version is greater than 18.19.1, as this is the minimum requirement for Angular 19. Second, we need text editor. You can choose any editor as per your wish, but I recommend Visual Studio Code Editor. Next, we need a TypeScript. TypeScript is a superset of JavaScript that adds static typing to the language, enabling it to catch errors and improve code quality during development. So we need to install the TypeScript version 5.6 or higher. So these three prerequisites are essential for setting up the environment for Angular 19 application. Additionally, if you are new to Angular, a basic understanding of HTML, CSS, JavaScript, and TypeScript is recommended for better visualization of Angular concepts. Okay, so next, let's understand project creation steps. So there are 7 steps we need to follow in order to create a successful Angular application. So with this step, we will set up our environment. So the first step is we need to download and install Node.js version greater than 18.19.1 on your system. So simply type Node.js download for Windows in the browser. Click on the first link and follow the prompts to download and install the correct version for your system configuration. Okay, so let's understand the second step. We need to install the latest version of TypeScript using the command npm install -g TypeScript. Also keep in mind that you don't need to install npm separately as it comes with Node.js. Since I have already installed Node.js and TypeScript on my system, to save time, I'll proceed directly to the third step. And the third step is to verify the versions of Node.js, npm, and TypeScript using the command node space -v, npm space -v, and tsc space -v. And here you can see that I have the required versions installed on my system. So let's move on to the next step. And fourth step is we need to install Angular using command npm install -g @angular/CLI, which will install the latest version of Angular, that is 19. And fifth step is we need to check the Angular version with command ng space v. And here you can see I have already installed the latest version of Angular, that is Angular 19. Now our environment setup is complete and we are ready to create a new Angular application. So let's proceed to the sixth step, creating a new Angular project. And to do this, we will use command ng space new space project name. So here cls ng space new space project name Angular 19 tutorial. And once you press enter, you will be prompted to select the CSS format. I'll choose SCSS, enter. Next, Angular team will ask if you want to enable server-side rendering. Since server-side rendering is now stable, you can choose to enable it by pressing Y for yes or N for no. So here I'll choose S because Angular 19 introduces a feature called incremental hydration, which requires server-side rendering. And enter. And again, Angular will ask, would you like to use the server routing and app engine API? I'll type Y for yes and enter. And now, after making this selection, the Angular project creation command will create a basic project and install the necessary node modules from npm packages. Here you can see the message installing packages. So just wait until completion. And once the project is created, we will open it in Visual Studio Code Editor. Now here you can see the message package installed successfully and successfully initialized Git. It means our project has been created successfully. Now let me open this project in Visual Studio Code. And to do this, we can either import the project folder directly into Visual Studio Code, like here, File, Open Folder, and select your folder from here. Click on Select Folder. So either you can open your Angular project from Visual Studio Code, or you can open the command prompt in the folder path. Like here, go inside your project, here, cmd, and use command code space dot, enter. Here you can see our project is opened in Visual Studio Code Editor. And finally, our seventh and last step is to run Angular project using command ngS, where S stands for serve. So here, let me open terminal with control plus backtick, and here I'll type command ngS to run this project. Okay. Now you can open a browser on localhost 4200. Here you can see the default UI for Angular 19 application. So till now, we have completed our environment setup. After that, we have created a new Angular project in version 19, and we successfully ran this project using command ngS. Now, let's take a closer look at the Angular 19 project structure. So this time, I am going to talk on main and important files and folders of the Angular 19 project structure. And for beginners, if you want to understand each file in detail, please check out my another video where I have provided a detailed explanation of each and every file and folder. So now let's focus on only important files of this project. The first and important folder of Angular project is Node Modules folder, which is essential for running your Angular application. So don't try to run your project before install Node Modules, as this folder contains all the dependencies required to run the Angular application. Like here you can see inside Angular folder, you can find all the dependencies related to CLI, common, compiler, compiler CLI, core, forms, etc. And we need all these dependencies in order to run Angular project. So without this node module folder, we cannot run any Angular project. Okay, and this is the default project structure generated by the command ng space new space project name. And to run this project, we need to compile several files starting with package.json file. And as you can see here, package.json file is a JSON file that contains script and dependencies. And this is the default script, but we can modify as needed. And under this package.json file, you will find two types of dependencies, dependencies and dev dependencies. So first we'll talk on dependencies. What are these dependencies? So these are the entries for dependencies used in your project, such as animation, common, compiler, core, etc. with version 19. And this also indicates that this project is running on version 19. Okay. Next, you can see here dev dependencies. These dependencies are used for local development only. For example, if you need Bootstrap or Angular material for development, then they would fall under dependencies. On the other hand, if you need Jasmine and Karma for testing, then they would be listed under dev dependencies. Okay, so inside this package.json file, we can find the version of Angular project and we can find the script and dependencies. So next, let's examine the angular.json file. So as you know, any project or application, there should be a configuration file. Similarly, this angular.json file serves as the configuration file for our Angular project. And this file contains all the project settings and linkages. And an Angular application is a single page application. Only one HTML file is rendered in the browser when the project is run. And this file is called as index.html file. In the angular.json file, you can see the linking of the index.html file here on line number 21. So let me go inside index.html file. You can find this file inside src folder. Here is index.html file. And inside this file, you can see the app root tag or selector, which calls the app component. Here you can see if you go inside app component.ts file, here you can see the selector of this app component is app root. And this selector is used inside index.html file. It means this app component represents our entire Angular project. Okay, so in the angular.json file, you can also see the main.ts file. And this file serves as the starting point of any Angular application. Whenever an Angular application starts, this is the first file that gets executed. And you can find this file under the src folder here, main.ts file. And inside main.ts file, you can see that it bootstraps to the app component. And app component is the root component of any Angular application. Whenever we create a new project, we get a default app component. And inside this src folder, you will find the app folder. So in future, if you create any component, then that component consists of 4 files: HTML, CSS, TypeScript, and spec.ts file for testing. But in this app folder, we are getting 4 more files. We will come to this file soon. Okay, so coming back to main.ts file, and you can see this file also bootstraps to app config, which serves the same purpose as app module in earlier Angular versions. If you remember, before Angular version 16, we use app module instead of this app config. The key difference is that app module is a module, whereas app config is a TypeScript file. Here you can see appconfig.ts file. We also have app.routes.ts file, which we can use for routing purpose. And before Angular 17, we used the approuting.module.ts file. But now we use the app.routes.ts file. So these are the important files inside the app folder. And outside the app folder, we have seen the purpose of index.html file, main.ts file, and next important file is style.css file. This file is used for global CSS styles, allowing us to write common CSS code for the entire project. Okay. So outside this src folder, we have seen the purpose of angular.json file as well as package.json file. And I think we have covered all the important files and folder which any Angular developer should know. Now, let's move on to our second topic, standalone component. Here, we will dive into the details of Angular components and explore everything you need to know. So first, let's understand why do we need components in Angular. The primary purpose of components is to break down our Angular application into smaller, manageable parts. And this allows us to structure our application into separate modular components such as headers, footers, left content, right content, and more. Depending on the requirement, we can further divide our application into smaller units. Additionally, all these components need to be imported inside the root component, means app component. Because in any Angular application, the app component serves as the root component. And in some cases, we need to import one component into another component. For example, suppose we have a student component and we want to include two separate components within student component, one for girls and another for boys. So in this scenario, we would import the girls and boys components into the student component. So this allows us to render the content of both components on the web. Okay. So now let's understand how to create a component in Angular. Let me open Visual Studio Code, and in Angular we can create a component using Angular CLI command such as ng, g for generate, c for component and component name. So here I am going to create user component. This command enables you to generate a new component in any Angular application. In addition, Angular has introduced a new concept related to components known as standalone components. So if we create a new Angular project in version greater than 16, we will get one standalone app component by default. Here, since we have created this project in version 19, here you can see we got one standalone component by default known as app component. And after this, we can create as many components as we want in this Angular application. But all the newly created components comes under the app component with the standalone feature. So we can say the app component is the parent component of all components. Now, when you create a component using the Angular CLI command, you will notice that it generates 4 files within that component here. So this structure of component typically consists of these 4 files: .html, .scss, .spec.ts and .ts file. And the purpose of .html file is, this is the template file for the user component where we will define the UI structure. And second file is user component.scss file. This is the style sheet file for the same component where we will add CSS styles. Next file is user component.spec.ts. This file is reserved for testing purpose only and is not used for development. And fourth one is user.component.ts file. This is the class file for the user component where we will write the logic and display it on the UI using the template file. So this is how we have created a component in Angular 19 application, and we have understood the purpose of all 4 files that components holding. And from Angular 17, any component is created as a standalone component. So now let's discuss about standalone component. What exactly are standalone components? So first, let me open a project with a version prior to 17. New window. Let me open this Angular services. Let me check the version of this project. Yeah, this project is in version 16. Okay. So here, normally when creating a new component, it must be declared in the module. Like inside app component, there is a file app.module.ts file. So in order to reuse any component, we need to declare that component inside this app.module.ts file under the declaration section. For example, this project has a user details component. And to reuse this user details component, I have imported it into the ng module under declarations. And then I can use this component throughout the application. Okay. But with Angular 14 and later, we can create standalone components that can be used independently without being part of any ng module. This means we don't need to import standalone components into the ng module. So this is the difference between a normal component and standalone component. So standalone components were first introduced in Angular 14 as a developer preview, and by Angular 15 they become stable. From Angular 15 and 16, you could create standalone components using command ngGenerate component name -- standalone. And starting with Angular 17, the command ngGenerate component name creates standalone components by default, adding the component property standalone true. And with Angular 19, all components are standalone by default eliminating the need to add standalone true to your code. Okay, so now let's discuss about the component decorator. In Angular, each component is defined using the component decorator. And this decorator can have multiple properties, including selector, template URL, style URLs, standalone, imports, etc. So as I mentioned earlier, starting with Angular 14, you can create standalone components, but in Angular version 15 and 16, the component typically specified only three properties by default. That is selector, template URL, and style URLs, as you can see here. No standalone and imports property available inside component decorator. And to make a component standalone, you could add a standalone true property and eliminate imports from the ng module. Like here, you can add standalone true. And in this case, you don't need to import the user details component inside this declarations section. But starting with Angular 17, the Angular team made standalone components the default by adding the standalone true property inside the component decorator. And as a result, in Angular version 17 and 18, the component decorator specifies five properties: selector, standalone, imports, template URL, and style URLs. Like this. And now in Angular 19, standalone components have become more stable, and the Angular team has declared that all components are now standalone by default, eliminating the need to add the standalone true property inside this component decorator. So as a result, in Angular 19 application, the component decorator specifies four properties: selector, imports, template URL, and style URL. No standalone true property available inside component decorator in Angular version 19. Okay, hope you understand this. Now, let's explore the purpose of each property in the component decorator. So first, let's talk on select. This is the name used to identify the component in the application. By default, every component selector starts with app due to the prefix setting in the angular.json file. So here you can see the prefix is set to app, but you can customize this prefix if needed. For example, you can change it to fed so that your selector starts with fed-component name. Okay, so this is about selector component. Next, let's talk on imports. This property lists all the required modules or dependencies for the component. Inside this array, you can import common module, forms module, or even you can import other components that you want to render within this component. Okay, so the next property is template URL. This property points to the HTML file for the component, which defines the user interface view. And fourth property is style URL. This property points to the CSS file for the component, which describes how HTML elements should be displayed on the UI, and you can use CSS to style the HTML web page. So these properties are typically utilized within the component decorator of each standalone component. Also, you can consider the default app component decorator generated when creating a new project. As you can see here, this component also consists of four default properties: selector, imports, template URL, and style URL. Okay. So far we have explored how to create a component, understood the structure of the component, and discussed the various properties that come under the component decorator. Now let me run this project using command ngS. Okay, let me delete this, and here Control C, ngS. And let's open the browser at localhost 4200. And here you can see the app component displayed. But if I want to render the user component in the browser, what step do I need to take? So now let's discuss how to use a standalone component throughout the application. Okay, so we can use standalone component throughout the application by importing it into the required component. And to do this, we need to follow two steps. And first step is add the selector of standalone component to the required component HTML template file. So here inside this app.component.html file, I'll add the selector of user component. I'll delete this default UI and here I'll add app user. So this is our first step. Now second step is we need to import the standalone component's name inside the imports array of the required component. And where we can find the imports array? We can find imports array inside this @component decorator. So here we need to add user component. That's it. The first step is we need to add the standalone component selector name inside the required component HTML file. And second step is we need to import the same standalone component inside imports array of required component. And once you have completed these two steps, you should be able to see the content of the standalone component rendered on the web page. So with standalone components, you don't need to import them in the ng module to reuse them. Now save the changes and go back to browser. Here we can see the expected output. The user component is now successfully rendered in the browser. Okay. So I hope you understand the concept of standalone component and a normal component. Standalone components are independent. We can use them anywhere in the application without injecting them into a model. Whereas normal components are dependent. Unless we add them to a module, we cannot use them anywhere in the application. So I hope you now understand about Angular components, which are the main building blocks of Angular. And now let's move forward with another building block called data bindings. So what is Angular data binding? Data binding is the process of connecting or linking data between two entities, the HTML template and the component logic means .ts file. So data binding is responsible for connecting the component's logic with its template, allowing data to be updated automatically. And there are mainly two ways to establish connections in Angular using one-way data binding and two-way data binding. And under one-way data binding, there are three types of data bindings: interpolation, property binding, and event binding. Additionally, there is a two-way data binding, also known as ng model. So Angular supports total four types of data binding: interpolation, property binding, event binding, and two-way data binding. So these types enable the creation of a dynamic and responsive user experience. So in this video, we will understand each of these types one by one with practical examples. So first, let's understand what is interpolation. This is an example of one-way data binding. And one-way data binding means data moves in one direction from the components to the HTML elements. And it uses double curly braces to bind component properties to template elements. So let's understand this with practical example. Let me open Visual Studio Code and create a component for data binding concept. Okay, so here let me open HTML file and TS file of data binding component. And one more thing, I need to add this selector inside app.component.html in order to render the content on web. Also, I need to import this component inside the imports array. Data binding. Okay, save the changes and let me close this app component files. And now we will focus on data binding component. Okay, let me split this Visual Studio Code. Now I'll create two properties inside .ts file called name and topic. And I assume that you guys are aware about concept of variable declaration. In the same way, here I'll create a property called name with data type string to understand the type of variable. And then I'll assign the value to that variable FAD learning. Same way, I'll create one more property, topic of type again string equals to, I'll assign value data binding. Okay, so this is how we can declare the variable in TypeScript. If you want to learn more about this variable declaration and master in TypeScript, then kindly check out my video. I'll provide the link in the description below. Now I want to display these two property values on the web because, as you know, the browser can only display .html files. So I need to bind the respective property names in the HTML file. And we can bind this property name with the interpolation symbol, which is open and close curly bracket. So here, instead of this paragraph tag, I'll take one div with align property center, and inside this div, I'll add one h4 tag and I'll add the heading one-way data binding. After that, I'll take one more div. Inside that tag, here I'll add first topic, that is interpolation. Okay. Now, under this interpolation, I am going to bind these two property names using interpolation. So, inside this double curly bracket, I'll write topic and name. Now, save both the files and open the browser. And here you can see we are getting output data binding FAD learning. So, inside this, we can add text if you want. So, here I will keep this topic inside bold tag. Okay, now you can see the output data binding from FAD learning. Okay, and what happen if you try to bind the variable inside double curly bracket, but that variable is not available in the TS file? For example, here if I try to bind topics instead of topic and save the changes, you can see that we are getting an error. Property topics does not exist on type data binding component. It means we cannot access this property because we do not have a property with the name topics in the respective TS file. So we can access any property with interpolation after declaring the same property in the TS file. Okay, so this is all about the first type of data binding, which is interpolation. And in interpolation, we bind .ts data in the HTML file, means data flows from .ts file to HTML file. Now let's move forward with the second binding types called property binding. This property binding also comes under one-way data binding, and we can bind component data with HTML file by using two ways. One way is interpolation, which we have just seen, and another way is using property binding. Okay. So property binding is a one-way data binding mechanism that allows you to set properties for HTML elements. And with this property binding, data flows from component to template. And it involves updating a property value in the component and binding the value to an HTML element in the same view. And property binding uses square brackets to bind component properties to template elements. For example, let me create one more property called image of type string equals to. I'll provide the link of my FED learning channel logo as a data to this image property. Here, copy image address, and here paste this address as a data to this image property. Now, if we talk about HTML, all HTML elements have some properties or attributes. For example, first I'll write down the second type of data binding, that is property binding. And here, let me take an input element. And in this input element, you can see type is a property of this input element. Similarly, we can have a name, ID, value, etc. So this type, name, ID, value, these are the properties of this input element. And to assign or bind the variable value to these properties, this is known as property binding. It means whatever variables we have created in this TS file, that variable value we can provide to this property. For that, what we need to do, we need to wrap this element property with square brackets, and then we can provide the variable name. For example, here I'll assign topic variable to this value property. Okay, so this is how we have provided the variable topic as a value to this property. Now, whenever this input box is rendered on web, it will render with the topic value. And what is the value of topic? Value of topic is data binding. Let's check the output on the browser. So here you can see the input text box with data binding topic. So similarly, let's try another example of property binding with image variable. We have already declared one image variable and we have assigned one image address to this image variable. Okay. Now here inside div, I'll add one image tag with src and alt properties. So what is the syntax of property binding? We need to wrap the src means source property within square brackets, and we need to provide the variable name as a value to this property. So our variable name is image. Let me copy this and paste it here. That's it. This is the syntax of property binding. Okay, additionally, I'll add some style for this image. Let me quickly add this. Okay, now save the changes and go back to browser. Now the output looks like this. Inside this square, we have rendered the image with the help of property binding. But here, if you want to store some another image into this image property, then you can paste the required image URL instead of the previous URL. Okay, so normally we use property binding for toggle functionality and sharing data between components. And note that we can create property binding with custom properties as well, which we will see while exploring the @input and output concept in Angular. Okay, now let's move on to the next type of binding, which is event binding. An event binding is the process of responding to user interactions on a website or application, such as clicking a button, selecting a URL, or choosing an option from a drop down menu. So when a user clicks on a specific HTML element, the application responds by providing new data, which is triggered by event binding. And the event could be mouse click or key press. And this type of binding also flows data in one way, which is why event binding comes under one-way data binding, flowing data from template to component. Note that interpolation and property binding flows data from component to template, but event binding is the exact opposite of property binding, where data flows from template to component. The view sends the data to update the component. And event binding uses parentheses to bind template events to component methods. Now let's see an example of how to create an event in Angular. So inside TS file, first I'll add the type name, that is event binding. And then here I am going to create a button with name save. And in this button element, we will use event binding. And we can use event binding with the click event and change event. So first we will use the click event with this button element. So how we can write click event? We need to write click inside parenthesis. And we need to assign a function to this click event. So I'll write the onSave function to this click event. And we can write the function with parenthesis. And now we need to declare this onSave function inside .ts file. Okay. Remember, in the TS file, we have declared variables. Similarly, we need to declare functions. So here I'll create a function called onSave inside this data binding component class. And this is a function, so we need to use parenthesis and then open and close curly brackets. And inside this function, you can call the API to save the data. As of now, I'll write one alert box with message data saved successfully, because we don't have any data to save. We are just understanding the concept of event binding. Let me format the document and save the changes. Open the browser. Let me click on this save button. And as you can see, once user clicks on the save button, the data saved successfully message is displaying through alert. One more time, if I click on this save button, you can see every time the user clicks on the save button, the message is displaying through an alert. And what is happening behind the scenes? Once we click on this save button, this click event will trigger. And once this event is triggered, we are executing this onSave function. That's it. So this is the example of click event. Now let's try the second example with another event called change event with a drop down. So let me create a simple drop down here. Select, and here we will have options. Let's say country. So I'll add country names here. Let me copy paste this: India, Germany, France and Spain. Okay, now we have a country drop down. Now save the changes and first check on the browser. Yeah, it's displaying perfectly. Now what I need to do? I need to call a function once I change the country from the drop down. So for that, inside this select tag, I'll add another event of type, that is change. And since it is an event, we need to wrap it inside parentheses. And we need to assign the function to this change event. So I'll assign on change function. Now let me declare this function inside TS file here. And inside this function, I'll again write an alert box with message country has changed. Now save both the files, and here let me change the country from the drop down. Here you can see once I change the country from this drop down, we are getting an alert with message country has changed. Okay, so now I'll choose Germany, and you can see if I change the value from top down, every time I'm getting this alert with message. Okay, so in Angular, there are many types of events like mouse event, key press event, double click event, change event, etc. But usually we use click and change events. So I hope you understood both events. And so far we have done one-way data binding, covering interpolation, property binding, and event binding. Now let's explore the last type of data binding, that is two-way data binding. So as the name suggests, two-way data binding is a mechanism where data flows bidirectionally between the component and the view. And this binding ensures that the component and view remain synchronized at all times. Any changes made to either the component or the view are automatically reflected in both. And the general syntax for two-way data binding combines square brackets and parentheses, which is also called as banana in a box. So let's understand this with an example. So for this, I'll create one more property called random with an empty string. Okay. Now in the HTML file, let me add this heading two-way data binding. After that, inside div, I'll create the input box where the user can type. Okay. Now here I want to use two-way data binding, and we can achieve two-way data binding by using the ngModule directive. And in order to work with ngModule, first we need to import the forms module. Since we are working with standalone component, we need to import the forms module in imports array of @component decorator. So here I'll add forms module, and it will get import from angular/forms. Okay, so this is the first step we need to do in order to work with ngModule directive. Now we have a random variable that I'll bind with the ngModule directive with this text box. So here I can write the ngModule with square and round brackets equals to, inside the double quotes, I need to pass the variable name random. Okay, so this is the syntax of two-way data binding. We need to write ngModule inside round and square brackets equals to, inside double quotes we need to provide the variable name. And additionally, I will use the same variable name inside interpolation. Right here, I'll write random. Okay, save the changes, save this .ts file as well, and go back to browser. So here, okay, this input type, I want text, not button. And here you can see under two-way data binding, we can see one input text box. Now, let me type something into this text box, and you can see whatever the user types in this box, it is displayed on the screen with the help of random property. Let me delete this, and I'll type something else like FED learning, and you can see this text is also updated with FED learning. Okay, or else here instead of random property, I'll bind some other property, like we have used topic property. So let's bind the same property with this ngModule topic, and here also I'll change with topic. Okay, now save the changes and go back to browser. Here you can see the text data binding on page load, because we have initialized the data binding value to this topic property. Here you can see. So because of this on load, we will see the data binding in the input box. So we have used this topic property here, here, and here. So in this input box, if I change it to Angular, then you can see it will get updated here, here, as well as here, because we have bound this topic variable 3 times in the HTML file. And if you bind this topic variable in 10 different places, and if you change the value, then it will be instantly reflected in all 10 locations. Okay, so this is the one of the key benefits of using ng model directives. So I hope you understand the concept of one-way data binding as well as two-way data binding. And to conclude, Angular data binding serves two primary purposes. It enables the binding of data from components to HTML templates and vice versa. And it ensures seamless synchronization of data between the component's code and its visual representation. Now, let's move on with the next fundamental building block of Angular called directives, which play an essential role in creating robust, scalable, and maintainable applications. So first, let's understand what are directives. Directives in Angular are reusable code blocks that extend the capabilities of standard HTML views. And directives are classes that add custom behavior to elements in Angular applications. So by using Angular's built-in directives, we can efficiently manage forms, lists, styles, and we can control the user interface. So how many types of directives are available in Angular? There are 3 types of directives available in Angular. First, component directive, second, structural directive, and third, attribute directive. Let's understand what component directive is. Component directive defines Angular components, which are the building blocks of an Angular application. And this is the most common type of directive in Angular. The primary purpose of a component is to break down an application into smaller parts. And in Angular, we can create components using the command ngGenerateComponent name. So here, inside Visual Studio Code, to save time, I have already created a component with name directives. And to render this component on the web, I have imported the directives component in the imports array of app component and added the selector of the directive component in the app component HTML file. Inside directives.component.ts file, above this directives component class, we can find the @component decorator, which is also known as component directive. And the object passed to that component directive is called the component's metadata, which include selector, imports, template URL, style URL, and more. Therefore, every component in Angular must have the TypeScript class with behaviors such as handling user input and fetching data from a server. Next, an HTML template that controls what renders into the DOM. And third, a CSS selector that defines how the component is used in HTML. And from Angular version 19, by default, Angular components are standalone, eliminating the need to add standalone property in the @component decorator, or we can say component directive. And to use standalone component directives or pipes, we must add it in the imports array in the component directive here. For example, if you want to use the structural ngIf directive, then you need to add it inside this imports directive. It is ngIf. Then only you can make use of ngIf directive in the directives.component.html file. Similarly, we have already created a data binding component while learning data binding concepts. So if you want to use the data binding component in this directive component, then you must import the data binding component in the imports array of this directive component, like this. Okay, so as Angular is a component based architecture, components play a vital role. Therefore, it is challenging to work in Angular without the component directive. So I hope you now understand the importance of component directive in Angular. Now, let's move on to the second type of directive, structural directive. These directives modify the structure of the DOM. DOM means Document Object Model, and this structural directive can alter the behavior of elements, components, and other directives. Examples of structural directives include star ngIf is used to display or remove an element based on a Boolean condition. Next example, star ngFor is used to iterate over a list and generate new DOM elements for each atom. Next example is star ngSwitch, used to add or remove DOM elements based on the value of a switch expression. And if you are dealing with multiple conditions, then ngSwitch is an alternative to using multiple nested ngIf statements. So basically, we can use ngIf to show and hide data, ngFor to iterate over data, and ngSwitch to add or remove DOM elements. And for better understanding, we will explore these directives with different scenarios through practical examples. First, I am covering the theory part so that you can easily answer questions about directives in an interview. Since directives are a fundamental concept, so around 90% of interviewers will ask about directives. Additionally, it's important to note that these three structural directives are mandatory in Angular projects version 16 and below. And this is because Angular 17 has introduced new built-in control flow statements that serve as alternatives to these three structural directives, which we will explore later. Therefore, as an Angular developer, it's important to be familiar with all directives, especially since many companies still maintain projects on version prior to 17. In such cases, structural directives are the only way to modify the DOM layout. Now, let's talk on third type of directive, attribute directive. And these type of directive alter the behavior of an element by adding, removing, or modifying its attributes. Unlike structural directives, they do not change the DOM layout by adding or removing elements. Just to recap, structural directives modify the structure of the DOM, while attribute directives modify its attributes. And as we learned earlier in property binding, an attribute refers to the properties of an HTML element such as ID, name, value, src, etc., which we wrap in square brackets. So we can modify these properties using attribute directives. And examples of attribute directives include ngClass. This directive is used to add or remove CSS classes from an element. And second example of attribute directive is ngStyle. This directive is used to add or remove inline styles from an element. And third example is ngModel. This directive is used to add two-way data binding to an HTML form element. And we have already covered this ngModel concept earlier while learning about two-way data binding. Okay, so far we have understood what directives are. I repeat, directives are used to add additional behavior to elements in your Angular applications. And there are three types of directives. First, component directive used to specify Angular components. Second, structural directive. They change the structure of a DOM. And third, attribute directive. They change behavior by modifying attributes. So we have covered the theoretical aspects of directives, and now we can explore the practical usage of each directive with examples. But before we do that, first we will install Bootstrap in our Angular 19 application. So quickly, we will install Bootstrap. So what is Bootstrap? Bootstrap is a free and open source front-end development framework for creating dynamic website layouts and web applications. And why do we use Bootstrap? We use Bootstrap to speed up development and avoid coding from scratch. Okay, so let's see what steps are required to install a Bootstrap framework. We need to follow two steps in order to install Bootstrap in Angular application. First step is to use npm command, and second step is to add the CSS and JavaScript file paths inside angular.json file. So as per the first step, I'll use the npm command to install Bootstrap, that is npm install Bootstrap. Hit enter. Now, once the installation is complete, the Bootstrap package will be added to the Node Modules folder. Let me open Node Modules. Inside node modules, here you can see the Bootstrap folder. Inside Bootstrap, there is dist JavaScript and SCSS folder. Inside dist folder, we can find two folders, CSS and JavaScript. And inside these folder, we can find the mean.css and mean.js file. That path we need to paste inside angular.json file. Okay, so that is our second step. Before that, we can also see the version of Bootstrap inside package.json file. Here, let me search Bootstrap, and here you can see the version of Bootstrap is 5.3.3. Now let's complete our second step is to add Bootstrap mean.css and Bootstrap mean.js files path inside angular.json file. So here inside the styles and scripts array, let me copy and paste the required path. So this path is for CSS. So we need to add inside styles array. And next, let me copy the JavaScript path and paste this inside scripts array. Now save the changes and let's use a Bootstrap button to test if Bootstrap is installed successfully. So here inside div, let me add one button with class btn and btn primary, which means I want to render blue color button on the browser. Save the changes and let me open browser. And as unexpected, we cannot see the blue colored button on the browser because I missed one important step. That is, after installing any new packages or dependencies, it's important to restart the application. And to do this, we need to stop the current server and restart it using command ngs. Okay, now let me jump into the browser. Still we cannot see the blue colored. Oh, that's my mistake. It's btn, not brt. Now save the changes. And finally, we can see the blue colored button on the browser. Let me add one more class that is margin 5. And let me add one more button, success. And success means green color. Now save the changes and go back to browser. Here you can see we have successfully rendered two Bootstrap buttons on the browser. One is in blue color and one is in green color. Okay, it means by following two steps, like one step is to install npm with command npm install bootstrap, and second step is to add these two file paths inside angular.json file. And by following these two steps, we have successfully integrated Bootstrap in our Angular 19 application. So under the directives topic, we have seen the three main types of directives in Angular: component directives, structural directives, and attribute directives. We also installed Bootstrap in our Angular 19 application and discussed about component directive in detail. Now let's proceed with structural directives. As I mentioned earlier, structural directives were mandatory in Angular projects version 16 and below, but starting from Angular 17, we have the option to use new built-in control flow statements as alternatives to structural directives, which we will explore now. So first, we will examine the example of built-in structural directive, and then we will see how to replace it with built-in control flow statements. So inside Visual Studio Code, I have created a new component called structural directive ngIf versus if. So let me add the selector of this app structural directive ngIf versus if component inside app.component.html and import the same component in app.component.ps file. Now save the changes and let me open the structural directive ngIf versus if component. Here I'll open HTML file and TS file. Before we start coding, let me check first on browser, is this component rendered or not. As you can see, the structural directive component is rendered in browser. Here, as we have already installed Bootstrap, so let me use Bootstrap classes, row, text center, and inside that div.call12.m3. And inside this div, I'll use bold tag. example of star ngIf versus @if. Okay. Now, what is the use of ngIf directive? We can use ngIf directive in Angular to show and hide a particular element in the browser. So here we will explore three different scenarios where we can use of ngIf directives. So let me structure the HTML page first, div.call4, and I'll just copy paste this div price. Alt Shift F, format the document, and now we will see all three scenarios one by one. So first, let's see how to hide and show a button based on the click of a checkbox. So here, let me add a checkbox with some text, input of type checkbox, and here I'll add a text, terms and condition. Save the changes and open the browser. Okay, just remove this round bracket and add the rate. And now here you can see checkbox with text, terms and condition. Now here, on click of this checkbox, I want to show a button, for example, submit button below this terms and condition. So first, let me add a button with name submit. After this div, I take one more div and inside that I'll use button.btn success. And the button name is submit. Okay, save the changes and here you can see the submit button. But I don't want this submit button on page load. I want this button when I click on this checkbox. Okay, so for that, I'll write a click event on this checkbox div and assign it a function. Okay, click equals to function name on click. And this on click function will be defined in the TS file. Okay, now here I'll define a boolean variable named isCheck of type boolean and assign it an initial value of false. And I'll use the same variable inside this onClick function, this dot isCheck equals to not this dot isCheck. It means when isChecked variable is false, it will set to true, and when it's true, it will set to false. Now I'll show and hide the submit button based on the isChecked variable. And to achieve this, we will use star ngIf directive and bind it to the isChecked variable. So here inside this button div, I'll use star ngIf directive equals to isCheck. And in order to use ngIf directive, we need to import it inside imports array. So either we can import ngIf or we can import common models. So I'll go with common model. Save the changes. And now let's check in the browser. Since each check is initially false, the submit button is hidden on page load. But once I click the checkbox, the submit button becomes visible like this. If I unselect this, the submit button becomes invisible. Visible, invisible. Select, unselect. So this shows how to utilize built-in structural directive ngIf to conditionally hide and show elements in Angular. Now let's understand the second scenario, how to hide and show a div when a button is clicked. And to achieve this, let's add two buttons, one to hide the div and another to show the div. So here let me add button.btn primary. Button name is show and I'll just copy paste the another button for hide. And instead of primary here I'll use danger. Okay, and before this button, let me add one input box with some value FED learning. Now save the changes and go back to browser. Let me add class margin 2. Here also I'll add class margin 2. Now here you can see on click of this show and hide button, nothing is happening. But I want this input box to appear when the show button is clicked and disappear when the hide button is clicked. And to achieve this, I'll add a click event to both buttons here and here. Click equals to, let's name the function show field for the show button and hide field for the hide button. And next, I'll declare both functions in the TS file, here, show field and hide field. And inside this function, I'll use a Boolean variable to control the visibility of this input box. So let's declare a Boolean variable name is input box of type Boolean and initialize it with the value true. Now in the show field function, I'll set is input box to true, and in the hide field function, I'll set it to false. Alt Shift F. Now save the changes. And based on this is input box variable, we will conditionally hide and show FAD learning input box. Let's copy this and go inside HTML file. And again, we will use star ngIf directive and bind it with is input box variable. Now let's check the functionality in the browser. Initially, you can see here the is input box variable is true. That is why we can see the FAD learning input box on page load. But when I click the hide button, the input box disappears. And when I click the show button, it reappears. Let me test it again. Hide, show, hide, show. Okay. Hope you understand the second scenario as well. In the first scenario, what is happening? On click of this checkbox, the submit button appear, and again when I click on this checkbox, the submit button disappears. And in the second scenario, on click of this button, we can hide and show the input box. Now let's explore the another scenario using the same ngIf directive, like displaying different messages based on specific conditions. And to demonstrate this, I'll add two input fields. So inside HTML file, here inside div, I'll add two input fields with class margin 1. Here I don't need class. Save the changes, and here you can see two input box. Now below this field, I want to display a message based on user inputs. Like if the user enters the same values in both the fields, like 1234, 1234, then I want to display the message both values are equal. And if the user enters different values, in this case, I want to display the different message like both values are not equal. And to achieve this, I'll first fetch the values from the input fields using two-way data binding with ngModel. So for that, I'll declare two empty string variables, input1 and input2. Input1 of type string equals to empty, and same input2 of type string equals to empty. And now let me bind these two variables with ngModel. So here I'll write ngModel inside square and round bracket. ngModel equals to input1 and same here for input 2. And in order to use ngModel, we need to import forms model inside imports array. So here, let me import forms model. Now next, below this input box, I'll add a message inside a div element. I'll use h4, and inside that, I'll write both values are not equal, and I'll copy this div and paste it one more time for both values are equal. Okay. Now let's check on the browser. We can see both the messages, but we want to display this message based on user input. If user types same values in both the fields, then I want to display both values are equal. And if the values are different, then I want to display both values are not equal. So for that, I'll use the ngIf directive to display the message based on input values. And I'll access the user inputs through the input1 and input2 variables. So to display the message conditionally, I'll set up the conditions like here star ngIf, and inside this double quotes, if input1 is not equal to input2, Then I'll display the message both values are not equal. And if input 1 is equals to input 2, then I'll display the message both values are equal. Okay, now save the changes and let's check in the browser. As you can see, initially we get the message both values are equal because we assigned empty values to both input 1 and input 2 variables. But when I change one of the input values, for example, if I type 123 in the first field, you will notice that the message changes to both values are not equal. But when I type the same value 123 in the second field, the message changes back to both values are equal because the values in the both fields are now identical. Let me do this one more time. Test, both values are not equal. And if I type the test in second box, then you can see the message both values are equal. So this is how we can change the message based on the input values. Okay. So here I have demonstrated three different scenarios where we can utilize the ngIf structural directive, but there may be additional scenarios where ngIf can be applied. For example, whenever you need to conditionally show or hide content, you should use the ngIf directive. Okay. Now let's explore how to replace the ngIf directive with a built-in control flow statement, that is @if @else block. Okay. And @if directive also enables you to conditionally show or hide page elements based on a logical Boolean condition. So let's explore this concept using the same examples. Let me split this. First, I'll comment out this existing div and write the @if directive syntax. Below this, I'll start by typing @if, and inside round bracket, I'll add the each check variable. And next, open and close curly braces, and I'll paste the same button element inside this if condition. That's it. Save the changes and let's check the functionality in the browser. Now, once I click on this checkbox, you can see the submit button. And on click of same checkbox, we can hide this submit button. Okay, it means @if directive renders the template when the expression evaluates to true and removes it from the DOM when it's false. Let me show this by opening the developer tool inside elements tab, inside app root, structural directive, inside first div. Now here you can see the submit button will get rendered only when I click the checkbox. Here you can see the submit button. Uncheck, check. Okay. So this was our first scenario with @if block. Now let's apply the same approach to the second example, that is show and hide the input box on click of button. Again, I'll comment out this @if directive div and wrap the same div inside @if block. And now I'll delete this ngIf directive and I'll bind the same is input box variable inside this @if round bracket. Now let's check in the browser. Once I click the hide button, the FAD learning input box disappears. And once I click the show button, it reappears. It means everything is working as expected. It's super easy, right? Now let's quickly apply the same @if directive to the third example as well. Here I'll comment out the existing conditions and put the first condition inside @if block. Our first condition is input 1 is not equals to input 2. Then I'll display the message both values are not equal. And one important thing to remember is that an @if block can have one or more @else blocks. For example, any number of @else if block like this and one else block. Okay, I repeat, @if block can have one or more else block. For example, any number of else if blocks and one else block. but all the else blocks can come after the initial @if block. Okay, so I'll put the second condition input 1 is equals to input 2 inside else if block, and I'll just delete this one more else if and else block. And if both inputs are equal, then I'll display the message both values are equal. Okay, now let's open the browser, and when I type something in the first input box like test123, then you can see in this case the first input box value is test123 and the second input box value is empty. That is why we are getting message both values are not equal. And when I type the same input value in the second input box like test123, I get the message both values are equal. So it means our third scenario is also working as expected with @if and else block. So far we have seen how to use ngIf structural directive with three different scenarios. And the same scenarios we have seen with new control flow statements like @if and else block. And kindly ignore the spelling mistakes. And one more thing, when I click on this text terms and condition, then also this submit button is appearing and disappearing. So let me correct this, because here you can see we have added this click event on div. Instead of div, we should add this on input so that it will apply for this checkbox only. And let me correct the spelling terms and conditions. Also, I want to keep the heading in H3 tag, and this message I'll keep in paragraph tag. Save the changes and go back to browser. Now, when I click on this terms and conditions text, the submit button is not appearing. But when I select the checkbox, then only submit button appears on the browser. And when I unselect this checkbox, it disappears. Okay, let me go back to Visual Studio Code. And the advantages of using @if block are: first is conditional rendering. And second advantage is improved performance. Conditional rendering means the @if block conditionally includes or excludes a template based on the evaluation of an expression. And improved performance means elements wrapped within an @if block are only rendered in the DOM when the associated expression evaluates to true. And this leads to better performance as unnecessary DOM elements are not created when they are not needed. I hope you now understood how to use the ngIf directive and how to replace it with @if and else block. And now let's dive into the next structural directive, *ngFor, and explore its corresponding built-in control flow statement @for block in detail. So what is the use of ngFor directive? The ngFor directive is used to repeat a piece of code for each atom in a list, such as iterating over arrays, displaying lists, creating tables, and rendering dynamic content on the web. So let's understand this with an example. So first, let me create a new component for ngFor, structural directive ngFor versus for. And let me add the selector of ngFor component inside app.component.html file. Also, we need to import the same component inside imports array. So here I'll import structural ngFor directive. And as of now, I'll comment out the ngIf directive. Now save the changes and let's check in the browser. Yeah. And as we discussed earlier, the ngFor directive is used to repeat a piece of code for each atom in a list. And we can iterate a list using ngFor directive. So we will need either a simple array or an array of objects. So in this video, we will explore how to utilize ngFor directive with both arrays and arrays of objects. So first I'll define an array of employee objects which I'll assign to a variable called employees of type any array symbol equals to array, and this contains object with properties such as emp name, emp number, emp email, and emp department, emp dept. Okay. Now let me add some dummy data to these properties. So emp name John, employee number 101, emp email john@gmail.com, and department IT. And I'll create two more objects. Second employee name Bob, employee number 102, employee email bob@gmail.com, and department HR. Third employee Peter, employee number 103, employee email peter@gmail.com, and employee department QA, quality assurance. Okay. So we have created one array of objects with name employees. Now let's structure our HTML document using Bootstrap classes. And to speed up the process, I'll reuse the basic layout from previous component with some minor changes. So here, example of ngFor versus for. And let me delete this. Yeah, save the changes and let's check in the browser. Yeah, here you can see example of ngFor versus for. Now we will display this employee list in a web dropdown. And to achieve this, I'll create an HTML select element and then I'll use ngFor directive to populate it with options. So select, let me add class padding 2, and inside this I'm creating an option element for each employee. And inside this I'll use star ngFor directive. And this ngFor directive will iterate over the employees array. And for each option element, I'll bind the value attribute to the employees number using the property binding. So here you can see the drop down. Now I'll write the syntax of ngFor directive. Let me copy this employees variable from here and I'll paste it here. So now here we need to create local variable with keyword let emp of employees. And I'll bind the emp number to this value property. Okay. Now we can access all the properties of this employees array. Like here, we have accessed employee number with local variable emp. So similarly here, I'll display the employee name and email using string interpolation syntax. Like emp.emp name dash emp.emp email. And one more thing, in order to use ngFor directive, we need to import common module in imports array. And it will import from @angular/common module. Now let's check in the browser. And as you can see here, the dropdown now display both employee name and employee email address. So here, as per requirement, you can bind any property of object. So for example, here, instead of employee email, you can bind employee number. Now you can see the employee name along with employee number. Okay. So I'll go with employee email. And with this, we have successfully completed our first scenario where we have utilized the ngFor directive to render the employee list in a dropdown. Now let's move on to the second scenario where the ngFor directive will be utilized. And in this scenario, I'd like to display this same employee list in table format. And to achieve this, I'll utilize the HTML table element with Bootstrap classes, table dot table and table border. And the table is divided into two main sections. First is T-head and second is T-body. This T-head section defines the table header containing the column names. So here inside table row, I'll add 4 table header. for name, for number, email, and last for department. And next, tBody section defines the table body containing the data. And for each employee object, a table row will be created. And now I'll use the ngFor directive to display the employees array data inside the table. So here I'll use same syntax, let emp of employees. And this syntax defines a variable emp that represents each employee object in the employees array. And now, using string interpolation, we will display the value of emp name property for each employee object in the corresponding table cell. So inside td, I'll write emp.emp name with string interpolation. And similarly, I'll display the rest of the properties using the same syntax. So here, emp.emp number, emp.emp email, and last emp.emp department, DEP. Now let's open the browser and verify that the employee list is displayed in the tabular format. And we can see that everything looks good. In first scenario, we can see the employee list as a drop-down value. And in second scenario, we can see the same list in tabular format. Okay, so we have seen two examples with an array of objects. Now moving on to the third scenario, and here we will explore using ngFor directive with an array. And to demonstrate this, I'll declare a new variable called company list, which holds an array of company names as a strings. So this is the type of string array. And I'll add few company names inside this array. Atos, Capgemini, Accenture, and TCS. Now let's discuss how to display this company list in the browser. And we can render this list in various formats, such as an unordered list, div, buttons, etc. So first, let's try to iterate over the company list inside UL and LI tag using the ngFor directive. So here I'll use UL tag to create unordered list. Inside the UL tag, I'll use a li tag to represent each list atom. And now I'll utilize ngFor directive to iterate over the company list array. ngFor equals to same syntax, let company of company list. And we can display this company list using interpolation syntax. So here I'll write company. Now let's verify the output in the browser. And as expected, we can see the company list displayed in the browser. I'll just change the class here, call to, and for table, I'll give call 6. Now you can see the company list with dots because we have used UL tag. UL means unordered list. And if needed, we can easily convert this to an ordered list by replacing the UL tag with an OL tag. And this will result in a numerically ordered list. Here you can see the list in numeric order. Also, we can iterate over the company list using the div element. So for that, first I'll add one more new row. After this, I'll add one HR tag and then I'll just quickly delete the unwanted code from this. And let me correct this with call 444. Okay. Now we will iterate the same company list using a div element. And now inside this first call for div, I'll paste this code. And instead of this li, I'll write div. And this will render each company name in a separate div element. And here you can see the output. Once I inspect this, you can see each company name in a separate div element. Also, we can iterate over the same list using a button element. So here I'll write button.btn.btn primary. And here I'll use ngFor directive. And then I'll write company inside string interpolation. Now save the changes. Okay, for space, I'll add margin 1 class. And here, instead of 4, I'll add 8. I'll just delete this div. Now save the changes and here you can see the output. So this will generate a separate button for each company name in a list. If I add more data in this company list array, it will also be displayed like here. If I add Tech Mahindra, Google, Amazon, now save the changes. And here you can see the complete company list array as displayed on the web. This we have displayed through ordered list, and this we have displayed through div, and last we have displayed the whole company list through buttons. This means we are iterating over the list dynamically. Okay, so this is how we can utilize the ngFor structural directive in Angular as per the requirements. Now, let's examine how to achieve same results using the @for block or @for new control flow syntax. So to begin, let's revisit the previous example where we used ngFor directive to iterate over the employees array of objects within a dropdown. But this time we will utilize @for block. So for that, I'll comment out this existing option element and implement the same functionality using @for syntax. And @for block allows you to declare local variable directly inside the parenthesis without using the let keyword. So here I'll directly write emp of employees semicolon. And here we must implement the track feature. Track emp variable. Okay. So when using @for block, we need to utilize track feature. Like if you have worked with ngFor directive to iterate over large lists, you might have used track by feature to improve performance. And the track feature helps Angular what changed in a list. So it only updates what's necessary instead of rebuilding the entire list. And the track feature works similarly to track by, but with a key difference. While track by is optional when using ngFor, and the track feature is mandatory when using @for. Now inside this for block, I'll just copy paste the same option without ngFor directive. Now save the changes and check the browser to see if our previous dropdown still populates the entire employees list. And as you can see here, the same employees are listed as options in the dropdown: John, Bob, and Peter. It means everything is working as expected with @for block as well. So what is this @for? The @for block is a feature that repeats a section of HTML for each atom in a collection. And it's commonly used to iterate over arrays or lists and generate dynamic content based on the previous data. And what is the difference between ngFor and @for? Answer is using ngFor directive requires importing the common module in Angular, whereas using the @for block does not require importing any additional modules in Angular. Okay, now next, let's populate the table data using @for block instead of ngFor directive. So let me copy the same syntax from here and I'll comment out this complete tr, and here I'll paste the same @for syntax because we are populating same employee list in this table. Okay, so what I'll do, I'll just paste the same tr without ngFor. Now I'll shift F and let's verify the output in the browser. And as expected, the employee table has rendered with corresponding data. Okay, so similarly, we can utilize @for block for the unordered list. But this time we will iterate the for loop over company list array. So let me comment out this, and below this I'll write the syntax of for block. Now here I'll use company of company list track company. And inside this for, I'll paste this list without ngFor directive. And I'll apply the same for statement to the another div and button as well. So here, let me paste this and comment out this. Copy, paste, and instead of this div, I'll add button without ngFor. Okay. Now save the changes. And as you can see here, the same company list is now displayed in the browser with list, div, and button. But this time we have used @for, not ngFor direct. So since we have replaced all instances of ngFor with @for block in this component, so in this case, no longer need to import the common module. Therefore, I'll remove it from the imports array, save the changes, and as you can see here, still our code is working as expected. Okay, so this is how we can replace ngFor with @for. And additionally, I'd like to share two more features of @for block. First is inside the for block, we can declare variables such as here, let f equals to $first, l equals to last, e equals to even, o equals to odd, c equals to count, and I equals to index. And first variable indicates whether the current row is a first row. Similarly, last indicates whether the current row is the last row. Variable even specifies whether current row index is even. Odd specifies whether the current row index is odd. Count displays the total number of atoms in the list. And index identifies the index of the current row. So if you want to know about the total number of atoms in the list, then you can simply print the variable C and you can easily get the total number of atoms in the list. Similarly, if you want to identify the index of a current row, then you can use variable I. Let me demonstrate how to utilize these variables. So here I'll use @if, else if, and else block to create conditional statements. Okay. So here I'd like to change the text color of first row to green. Also, I wish to change the text color of last row to red, and I'll leave the rest of the rows without any styling. So let's see how we will achieve this. So for first row, I'll use variable f to check if it's a first row. So here I'll write f equals to true. Then I'll add the style attribute to change the text color to green. Style color green. Next, I'll use the L variable, else if, and now I'll check L equals to true. I'll add a style attribute to change the text color to red. Here, instead of green, I'll write red. And finally, I'll use the else block to display the rest of the list without any styling. So here, I'll delete this style. Now, with this implementation, I expect only the first row to be green, the last row to be red, and the rest of the rows to have no styling. Now let's verify the output in the browser. And here you can see the first company is displayed in green and the last company is displayed in red color and the rest companies are in black color. Now moving on to the second point. If you are dealing with an empty array, you can utilize the @empty block to display a user-friendly message following the @for block. Like here, after this for block, we can write any user-friendly message inside this empty block. I'll write simply no company found. And let me clear the company list array. Now let's observe the output. Here you can see instead of empty space, we can see the message no company found. And this message provides a clear indication to the user that no data is available. Okay. So what is this empty block? The empty block is an optional section that can be placed immediately after the for block content. And its primary purpose is to display a message or content when there is no items available in an array. Okay, so this is all about @for block, and the advantages of @for blocks are mandatory tracking function and no explicit imports needed. Mandatory tracking function means that @for block requires developers to use tracking function, ensuring better performance and minimizing unnecessary re-renders. And no explicit imports needed means, unlike ngFor directive, the @for syntax is automatically included in templates, eliminating the need for explicit imports. Okay, so I hope this explanation helps you to understand the @for and ngFor directive. Now next, let's explore the third structural directive called ngSwitch. Also, we will cover the new @switch syntax, which serves as an alternative to the traditional ngSwitch directive. So first, let's start by understanding the *ngSwitch directive, and then we will see how ngSwitch can be replaced with @switch. So let me open Visual Studio Code, and here I am going to create new component called ngGenerate component. Component name structural directive ngSwitch versus switch. Enter. Okay, and let me quickly add the selector of ngSwitch component inside app.component.html file. Save the changes. Let me import the same component inside imports array. Structural ngSwitch directive. Okay, now save the changes and let me close our component files, and let's open the ngSwitch file, HTML file and TS file. Okay, and inside HTML file, I'll copy paste the heading from *ngIf directive. Here, let me edit ngSwitch versus switch. Here you can see example of ngSwitch versus switch. Now, what is the purpose of ngSwitch directive? And the answer is used to add or remove DOM elements based on the value of a switch expression. So for example, let me create a number variable. Let me split this, and I'll open the TS file here and HTML here. So inside TS file, let me create a number variable name grade of type number and initialize it with a value of 0. Now let's move to the HTML template, and to demonstrate the ngSwitch directive, we will explore a scenario with multiple conditions. So let's consider an example where we will display student grades like first grade, second grade, third grade, etc. And to do this, I'll add 3 buttons within this call12 container. Okay, so button .btn success. Button name is first grade. Also, I'll add one more class, margin 1. This button is for grade 1, and this is for grade 2, and this is for grade 3. And grade 2 button color primary, and this third grade button color I'll write warning. Okay, save the changes and let's check in the browser. And as you can see, our buttons are looking as expected. Now, on click of each button, I want to display a unique message. And to achieve this, we can utilize the ngSwitch directive. But before implementing ngSwitch, I'll add a click event to each of the 3 buttons. So here, click equals to, I'll call a set function with corresponding number values. Like for first grade, 1, second grade, 2, and third grade, 3. And next in the TypeScript file, I'll define the set function with a single number parameter x of type number. And within this function, I'll assign this past number to the grade variable, this dot grade. Okay, now let's implement the ngSwitch syntax. After this button, I'll add one more div, and inside this div, I'll wrap the ngSwitch directive in square brackets similar to property binding. Okay, and I'll assign the grade variable, and the initial value of grade variable is 0. Now inside this ngSwitch directive, I'll add all possible switch cases, and each case will use the star ngSwitch case syntax followed by the corresponding grade number. For example, here let me take one more div, and inside this div star ngSwitch case equals to 1. And for grade 1, I'll display the message, "Congratulations on your outstanding achievement, first class." And now I'll replicate this same div 2 more times. And I'll update the case number with corresponding message. So for grade 2, I'll display the message, "Congratulations on your achievement, second grade." And for grade 3, I'll display the message, "Congratulations on your achievement, third grade." So instead of class, I'll write grade. Okay, save the changes and let's recap. So far we have created 3 buttons: first grade, second grade, and third grade. And when each button is clicked, it calls a set function with a grade number. And inside the set function, the past number is assigned to the grade variable. And after that, we have assigned the same grade variable to the ngSwitch directive. And then we have added 3 cases to handle each grade. Like first case handles first grade, second case handles second grade, and third case handles third grade. Now let's check the output in the browser. Okay, can't bind to ngSwitch. So here, one thing we missed. To use ngSwitch directive, we need to import either ngSwitch or the common modules. So I'll import the common module and I'll delete this ngSwitch. Okay, save the changes, and now we can see our web page without any errors. And when we click the buttons, we should see the respective messages. So let's check. When I click on the grade 1, "Congratulations on your outstanding achievement, first grade." Similarly, on click of second grade button, I receive a message regarding second grade, and on click of third grade button, I receive a message regarding third grade. But when the page loads, no message is displayed. And if we want to show a message when none of the cases match, then we can add it inside the ngSwitch default syntax. So let's add a default message inside ngSwitch default. So here I'll copy paste the same div, and instead of ngSwitch case, I'll write ngSwitch default with message "no result found." Okay, and here let me add class margin 3. And now on page load, none of the ngSwitch case match the value of grade variable. Then our code will render the ngSwitch default case. So let's check the result in the browser. And as you can see here, the "no result found" message is displayed on page load. But when I click on any button, I get the respective message corresponding to that button. It means ngSwitch default case is used to render a template when none of the ngSwitch case blocks match the value of the expression. Okay, so this is all about the ngSwitch directive in Angular. Now, let's explore how to replace the ngSwitch directive with @switch block. So for that, let me comment this div, and after that I'll take one more div, and inside this div I'll write the @switch syntax. And the syntax of @switch block is similar to JavaScript switch case syntax, like @switch and then the condition in round bracket. So in our case, we need to pass the variable grade. and then open and close curly braces. Now, inside this switch block, we need to add cases for grade 1, 2, 3 using @case syntax. So here I'll write @case, and inside round bracket, we need to pass the grade value. So for first case, I'll pass 1. And for grade 1, I'll display the same message. Congratulations on your outstanding achievement, first grade. And similarly, I'll copy paste the same case 2 more times. Second case for second grade. This third case for third grade. And here also I'll write third grade. And lastly, we can display default message by using @default syntax. So inside this block, I'll write no result found. Okay, so this is the syntax of @switch block. And what is @switch? @switch syntax helps us to show different content based on a value. It is useful when we have multiple options to display and we want to choose the right one based on a specific value. Okay, and what is default block? This default block is optional and can be omitted if not needed. But if no @switch matches the expression and there is no @default block, the browser will not display any content. So we should always have a practice to write default block while writing the syntax of switch case. Okay, here also I'll add class margin 3. And now let's open the browser and test each button individually. And as you can see here, on page load, we are getting message no result found. But when I click on first grade button, I'm getting a respective message corresponding to that button. Similarly for grade 2 and grade 3. It means everything is working as expected with @switch block as well. So I hope you understand the example of @switch block as well as ngSwitch directive. And as you can see here, compared to ngSwitch directive, the @switch block is more readable, understandable, and easy to use. But we can achieve the same functionality using @switch or @if blocks as well. So when to use @switch block and when to use @if block? Answer is, if you have only two options to display, it is recommended to use the @if syntax instead of @switch. But when dealing with multiple options, then @switch provides a more efficient and readable solution. Okay, so hope you understand this as well. And just for recap, till now we have covered three types of structural directives: ngIf, ngFor, and ngSwitch, along with new control flow statements like @if, @for, and @switch. And I hope you understand all these concepts. But still, if you have any doubts, kindly leave them in the comments below. And with this, I have concluded our discussion on structural directives as well as new built-in control flow statements. Now next, let's shift our focus to the third type of directive called attribute directives. And for this, I have created a separate component named as attribute directive and imported it in the app component here as well as here. Okay. And to save the time, I have created a basic structure with Bootstrap classes. So first, let's start with ngClass directive. And what is the purpose of ngClass directive? ngClass directive is used to add or remove CSS classes from an element. And to understand this clearly, we will explore practical examples covering 2 to 3 scenarios for both directive, ngClass as well as ngStyle. Okay, so in our first scenario, we will add a dynamic class using ngClass directive. So for that, let me open this TS file in right side, and here I'll declare a variable with name text color of type string and assign it an initial value, which is a bootstrap class text success. Success means green color. Now, inside the HTML file, I'll create an h3 heading element with the text. This is the first example of ngClass. Okay, save the changes and let's open the browser. And here you can see our H3 element with text. This is the first example of ngClass. Now I want to apply the green color to this text. And we have already created a variable and assigned a text success class to this text color variable. So now how we can add this text color variable to this H3 element? So with the help of ngClass directive, we can do that. So here I'll use ngClass directive, and the syntax of ngClass directive is we need to wrap ngClass inside square bracket and assign it the value of variable, and the variable name is text color. Okay, so this is the syntax of ngClass directive. Now in order to use ngClass directive, we need to import it inside imports array. And again, either we can import ngClass or we can import common module. Well, import common module so that in future if you are working with ngIf, ngFor, ngClass, ngStyle, then you don't need to import each module inside imports array, because instead of adding everything we can import common module. Now let's open the browser and observe the rendered text in green color. Here you can see. Here you can see now our H3 element is in green color. And additionally, note that instead of using the ngClass directive, we can wrap the class property in square bracket like this. Because the class is the attribute of HTML element. So since this is attribute, we can wrap it with square bracket. And with this property binding also, we are getting same result. Now save the changes, and here you can see still our H3 element is in green color. This means we can add a dynamic class using either the ngClass directive or the class property binding. Okay. Now to make this functionality more dynamic, we can change the color of text on button click as well. So here what I'll do, after this H3 element, I'll add one BR tag. Then I'll create a button element with a class of btn.btn success.margin2 for styling. And the button's name is changed to green. Now, when this button is clicked, the click event binding calls a function called change color, and I'll pass the respective color. So here, since this is a green color button, I'll pass text success class, and I'll add single quotes around the class name to make it clear that it's a string. Okay. Now inside TS file, let me define the change color function with one parameter color of type string. And inside this function, I'll assign the parameter value to this text color variable. And now I'll create another button with red color, button danger, and I'll pass bootstrap class danger as a function parameter. Okay. So far what we did, we have created one variable with name text color and assign a text success bootstrap class as its value. And after that, we have bound this variable to the heading using ngClass directive. Okay. And then we have created two buttons. First button is for green color and second button is for red color, and added a click event to each button. This event calls the change color function with parameter text success and text danger. And within this function, we assign this color parameter to the text color variable. Now save both the files and test in the browser. Here you can see two buttons. First is in green colors and second is in red color. And we can see the text color is in green color because we have initialized the value of text color variable to text success, which means green color. But if we want to change the text color to red, then we need to click on the red color button. And now here you can see the text is in red color. Similarly, we can change it back to green color by clicking the green color button. Change to green, red and green. So this is actually dynamic. It means Dynamically, we are changing the color of text. Okay. So this is the first example of ngClass directive. Now let's move on to the another example where we will add CSS conditionally. Let me increase the font size. And our second scenario is adding CSS conditionally using ngClass directive. And for that, again, I'll declare a variable. Let me add first here. And now this is our second scenario. And for second scenario, I'll declare a new variable with name is text green of type boolean equals to, I'll initialize it with the value false. Okay. Next, I'll copy and paste the same heading inside second div. And here instead of first, I'll write second because this is our second example. And here I'll delete this text color variable. And instead of that, I'll use new variable that is text green. And this time to bind the class dynamically, I'll use conditional expression to evaluate the value of is text green variable. Like here, ngClass equals to is text green. And if this is text green variable is true, then I apply the class text success colon. And if this is text green variable false, then I'll apply the class text danger. Okay. So this is our conditional expression. It means is text green is true, I wish to apply the class text success. Otherwise, I wish to apply the class text danger. Since the isTextGreen variable is assigned the value false, it will execute the false condition. That means applying the class text danger. Therefore, on page load, we should expect the text to appear in red color. We'll save both the files and let me open browser. And here you can see the first scenario is in green color and second scenario is in red color. And also we can make this example more dynamic by using a checkbox. So here I'll add BR and after that I'll create a checkbox input element, input of type checkbox and binding its value to the isTextGreen variable using the ngModel directive. And in order to use ngModel, we need to import forms module. So here in ngModel equals to, I'll bind the variable isTextGreen. And as we know that ngModel directive is used for two-way data binding, which means that changes to the input element's value are automatically reflected in the isTextGreen variable and vice versa. And in other words, when the checkbox is checked or unchecked, the value of isTextGreen variable is updated automatically. Okay, so I'll add a text label next to the checkbox, that is change color. And now let's test this in the browser. Initially, the value of variable is false. That is why we can see the H3 element is in red color. Because in the condition we have written if the is text color is false, then we wish to apply the text danger class to that particular element. So now when I select this checkbox, as you can see here, the is text green variable becomes true and the text color changes to green. So to be more clear here, I'll just print the value of is text green color. Now you can see initially the is text green color is false. Once I click on this checkbox, it becomes true. And when is text green true, we wish to apply the text success class to this H3 element. And text success means green color. And when I deselect this checkbox, the is text green variable becomes false and the text color changes to red. Okay. Select, deselect. Let me delete this. And now let's move on to the third scenario where the user can add their own class as desired, which means let's add a custom class using ngClass directive. And to do this, I'll declare a variable with name user class of types string equal to, I'll initialize it with an empty string. And next, inside HTML file, I'll copy paste the same h3 element here. And this time I'll delete this condition. And instead of second, I'll write third. And here I'll bind the new variable user class to this ngClass directive. Now I'll add a br tag, and after that I'll create a text input element, input of type text, and binding its value to the user class variable. So again here I'll use ngModel equals to user class. And here I'll also add placeholder with text example success to provide a hint to the user about expected input format. Okay, so now as the user types into the input field, the value of the user class is updated automatically, and the same value is reflected in the class of h3 element. So let's save the changes and go back to browser. And as you can see here, initially the text appears in black, but if the user wants to change the text color to orange, then they can simply type text warning inside this input box like this. And you can see the text is in orange color. Similarly, I can type text primary and it changes the text color to blue. Similarly, I can type text info, text danger, text success. Okay, so this shows that users can add any color class through this input box. Okay, so far we have explored 3 different use cases of ngClass directive where we added and removed CSS classes dynamically. In the first example, we added a dynamic class using the ngClass directive. In the second example, we added CSS conditionally using the ngClass directive. And in the third example, we added a custom class using the ngClass directive. Okay, now let's understand the second type of attribute directive, that is ngStyle directive with similar examples. So I'll just copy paste the heading from here and let me change the name to ngStyle. Save the changes. And what is the use of ngStyle directive in Angular? The ngStyle directive is used to add or remove inline styles from an element. Okay, what's the difference between ngStyle and ngClass? The ngClass directive is used to add or remove CSS classes, whereas the ngStyle directive is used to add or remove inline styles from an element. Okay, so let's understand ngStyle with practical examples. So for that, let me copy paste the first example of ngClass directive and quickly modify the h3 element. So here instead of ngClass, I'll add ngStyle. And I'll also change the button colors to orange and blue. For orange, I'll use button warning, and for blue, I'll use button primary. Same here, I'll pass the parameter button warning and button primary. And I'll change the function name as well. This time I'll use update color function. And this button names will be changed to orange. And the second one is changed to blue. Next, I'll define this update color function inside TS file. So below this first example, I'll write the say update color function with uColor parameter of type string. Or instead of uColor, I'll write here ngStyle color. And I'll declare a new variable with name style color of type string and assign it the value orange. Now inside this update color function, I'll assign this ngStyle color parameter value to the style color variable. Save the changes and let's check in the browser. And here you can see the text is displayed in black, even though we have written these two buttons and we have written this respected function inside TS file, it won't work because we have not yet used the ngStyle directive. Okay, now to change the text color dynamically, we can use the style attribute with property binding or the ngStyle directive, similar to how we use the class attribute or ngClass directive. But additionally, we need to wrap the inline CSS within curly brackets, formatted as an object. So here, inside this curly brackets, I'll add color property. And here I want to assign the value of color to orange. So we have already created a variable and assign the value orange to that variable. So here, let me correct the spelling. I'll use the style color variable as a value of this color property. And along this color property, we can use another CSS properties like font weight. Here I'll add lighter. So similarly, you can add as many CSS properties as you want. Okay, so I'll go with these two. I want to change the color to orange, and also I wish to apply the font width lighter. Okay, so what we did so far, we have created a new variable called style color and assigned it the value orange. After that, we used this variable as the value of this color property inside the object. And we have also created two buttons and added a click event to change the corresponding content of the H3 element. Okay. And we passed the corresponding color as a parameter to the update color function and define the same parameterized function in the TypeScript file. And inside this function, we assign the parameter value to the style color variable. Okay. Now let's check the output in the browser. And here we can change the text color by clicking on the button and it's not changing. Okay, so here we don't need to wrap this style color inside quotes. And one more thing, we have assigned the color to the style color variable. So here also we need to pass the color. So instead of Bootstrap class, I'll pass orange color. And here also I'll pass blue color. Okay. Now save the changes and let's check in the browser. Now you can see the text is in orange color. And once I click on the blue color, the text changes to blue. And also we can change this text back to orange by click on this orange button. Blue and orange. Okay. Okay, so this is how our first example of ngStyle directive is also completed. And as I mentioned earlier, we can achieve the same result using the style property instead of ngStyle. So let's check this as well. Let me click on this blue color and again orange color. And it is working as expected. So it means both methods produces the same output. Therefore, we can choose any method to add style dynamically. Okay. Now let's understand the second example. And for the second example, I'll create again a new variable called isTextOrange. Okay, and assign it a false value to this variable as well. Now let's copy the second example from ngClass and I'll paste it inside ngStyle. And I'll do necessary corrections. Instead of using ngClass, here I'll write ngStyle. And instead of isTextGreen variable, I'll use isTextOrange variable. And here let me delete this condition. Let me change this to ngStyle. Instead of isTextGreen, here I'll write isTextOrange. And now, since this is the ngStyle directive, I'll wrap the color property inside curly braces. So here I'll use color and I'll use isTextOrange variable to the value of this color CSS property. Now we can add condition. If this isTextOrange true, then I wish to apply a color orange. Otherwise, I wish to apply blue. Okay. So what we did, we have created a new variable called isTextOrange and assigned a false value to it. And then we have used the same isTextOrange variable conditionally in the ngStyle directive Like if is text orange is true, the text will appear in orange color, otherwise it will appear in blue color. And the value of is text orange variable changes when the change color text box is selected or deselected. Okay, so let's check the output in the browser. And here you can see we can change the text color by selecting and deselecting the check like this. Okay, so this was our second example. Now let's understand the third example of ngStyle directive. And for this, I'll create a new object called custom class of type any equals to open and close curly brackets. And this object contains property color. It sets the text color to pink. Next property height. It sets the height of the element to 150 pixel. Next property, I wish to add width, and it sets the width of the element to 400 pixel. And last, I want to add border, 1 pixel solid black. So this border property sets a 1 pixel solid black border around the element. Okay, so this is for TS file. And now inside HTML file, I'll copy the third example of ngClass directive and paste it inside ngStyle directive. But this time I won't need the input box. I'll remove this br tag as well, and I'll replace this ngClass with ngStyle. And instead of this user class, this time we can use ngStyle directive to bind the CSS property defined in the custom class object to this h3 element. So here I'll write custom class. It means when the template is rendered, the h3 element will have the styles defined in the custom class object. Okay, so let's check the output in the browser. And here you can see the text is in pink, but we cannot see the border. So let me see here, instead of W, I need to write 1 pixel. Now you can see all the CSS styles, including color, height, width, and border, have been successfully applied to this h3 element. Okay, so it means we can add the CSS dynamically as per the requirements. Like if you want to change the color, we can directly change it from the TS file. Like instead of pink, now I'll apply yellow color. And since this is the example of ngStyle, so instead of ngClass, I'll write ngStyle. Now let's save the changes. And now you can see the text is in yellow color. So I hope you now have a clear understanding of both the ngClass as well as ngStyle directives. And with this, we have successfully completed the concept of Angular directives. And I assume you enjoyed learning with FAD Learning and found our tutorials helpful. Now next, let's dive into signals, a powerful feature introduced in Angular 18. So by definition, what are signals? A signal is a wrapper around a value that notifies interested consumers when that value changes. And signals can contain any value, including primitive values or complex data structure like arrays or objects. This means that a signal is used as a wrapper for some type of functionality and is used to notify multiple consumers that a change has occurred. You can read signal's value by calling its getter function, which allow Angular to track where the signal is used. So let's understand the types of signals. There are two types of signals available in Angular, writable signals and computed signals. What is writable signals? A writable signal provides an API for updating its value directly, and we can create writable signals by calling a signal function with the signal's initial value. So here you can see that we can use signal as a type of variable, and name of the variable is count. And we have to call or invoke the signal variable with round brackets like function. And to change the value of writable signal, we can either use the dot set method or the dot update operation to compute a new value from the previous one. But inside update function, we need to pass a callback function to update the value. Okay, now let's move on to the second type of signal, which is computed signals. A computed signal is also known as read-only signal, and it derives its value from other signals. So in this example, we can see that counter is a writable signal with the type writable signal, and double counter is a read-only signal or computed signal with the type signal. And this computed signal depends on the writable signal, which is counter. And it means once the counter value changes, the double counter variable will also update its value according to the requirement using the computed function. Now let's try to understand these two types of signals with a practical example. So let me open Visual Studio Code, and here I have created a component with name signals, and to render this component on web, I have imported the signals component inside imports array of app component and added the selector of signal component in the app.component.html file. Now let me close these two files and we will focus on signal component. So first let's understand writable signal. We can use a signal as a type of variable, and we can create a signal just like a variable. The only difference is that we need to use the signal function and pass the initial value inside parentheses. Like here, I'll create one counter variable, counter equals to, I need to use signal, which is imported from Angular/core, and I need to pass the initial value inside parentheses. So I'll pass 0. Okay. We can also write this counter variable like this, counter of type writable signal of type number equals to signal. Here we'll pass initial value 0. So either you can write like this or you can write like this. Both are same. So I'll go with this. And as I said, it is similar to our normal variable like this. Like how we create a normal variable. For example, count equals to, we can assign value 0. So this is how we can create normal variable. But when we try to create a signal variable, we need to use signal keyword and we need to pass initial value inside parenthesis. And one more thing, we can also create an array using this signal by adding the array inside parenthesis with or without values. Similarly, we can create an object by adding open and close curly brackets with or without values. So it means we can create signal variable same like normal variable. And how to call the signal variable in HTML file? We can call signal variable in HTML file like function means with parentheses. So here if I want to call this, then I'll use string interpolation and I'll paste the counter variable. But additionally, we need to add the parenthesis. So this is the difference between normal variable and signal variable. So in order to call signal variable, we need to use parenthesis after the variable name. Okay, so let me restructure this quickly. Here I'll add text counter value. Now save the changes and we can see the output on the browser. Here you can see we have initialized the counter signal variable with 0, which is why we can see the counter value 0 on the browser. Now this counter variable is a writable signal, which means we can change the value of this counter variable. Okay. So as we discussed a few minutes ago, to change the value of writable signal, we can either use the dot set method or the dot update operation to compute a new value from the previous one. So here I'll create one constructor and inside constructor I'll use dot set method to set another value for the counter variable. And how to access counter variable? By using this keyword, this dot counter dot set and then parenthesis. So here inside parenthesis we can pass the required value. So here I want to change the initial value of this counter variable from 0 to 5. Now save the changes and go back to browser, and now you can see the default counter value is 5. Okay, so this is how we can use dot set method to change the value of signal variable. Now we will see how to update the value of signal variable on click of button. So for that, I'll add a button called increment counter. And for this button, I'll add a click event with function on increment. Okay, now I need to declare this function inside TS file, and inside this function, I'll update the value of counter variable. So for that, again, I'll write this dot counter dot update, and here I need to use arrow function. So first, what we need to do, we need to take initial value, and then for increment the initial value, I need to add 1 into this initial value. Okay, so this is how we have written the on increment function. Now, when I click on this increment counter button, you will notice that the counter value increments by 1. See, now the counter value is 6, 7, 8, 9, 10, like this. For every click, the counter value is incrementing by 1. This is how we can make use of update method to update the value of signal variable. Okay, I hope you understand how to use dot set and dot update method to update the signal variables. Now you might be thinking, what's the point of signals when we can achieve the same results with the regular variable? Why do we need signal? Okay, so let's understand this first. Why do we need signals? Angular 18 has introduced one more feature called zoneless change detection. And with this feature, we can say that Angular no longer needs the zone.js library. This means that without signals, Angular relies on change detection cycle to find out if some data has changed and then update the UI based on that change. If you remember, we have used rxJS subject and behavior subject to manage and share data in our applications. It works by notifying all consumer subscribers of any value changes with the help of zone.js library. But signals works similarly, capable of holding values of any data type, including numbers, objects, arrays, and more. With the signal feature, whenever you change any value, it notifies all consumers without the need for zone.js library. Let's look at this code to see the difference between behavior subject and signal. Both behavior subject and signal can hold initial value. This also holding initial value 0 and this also holding initial value 0. With behavior subject, if you want to manipulate data, you need to use pipe and map operator, which we need to import from rxJS library. This means we need to rely on rxJS library while working with behavior subject. But we can now do the same operation with signals. And while working with signal, we don't need to import rxJS or zone.js library. So here you can see that with the help of compute method, we can manipulate the data. This means signals offers an alternative to subject and behavior subject by removing the need of rxJS and zone.js libraries. So let's understand this with practical examples. First, let me disable the change detection by adding change detection property inside this @component decorator. Change detection colon change detection strategy dot on push. By adding this line number 8, we can disable change detection in our application. Okay. Now I'll create a normal variable with name normal counter and I'll assign the value 0 to this normal counter. Okay. Now inside the constructor, let me comment out this function as well as this button as of now. And now inside this constructor, I'll add a set timeout function. Now inside this function, I'll change the value of normal counter variable to 50. Normal counter equals to 50. And I want to execute this function after 5 seconds. And additionally, I'll add one console.log to display the value of normal counter variable inside console. The value of normal counter. Okay, now save the changes and inside HTML file, instead of calling the counter signal, I'll call the normal counter. Let me comment out this counter. Now save the changes. What we did, we have added one set timeout function inside constructor and I have mapped this normal counter variable inside HTML file and I disabled the change detection strategy by adding change detection property inside this @component decorator. Okay. Now save the changes and open the browser and here you can see the initial value of normal counter variable is 0, I'll refresh the page, and after 5 seconds, this value should be 50. But as you can see here, after 5 seconds, the console logs the value 50, but the value of normal counter is not updating on the web. This is because we have disabled the change detection. One more time, I'll reload this page, and you can see after 5 seconds, you will see the normal counter variable 50 inside the console, but the same value is not updating on the web. And this is because we have disabled change detection strategy. Let's see what happens if I enable this change detection. And we can enable this change detection by removing the change detection from this @component decorator. So as of now, I'll comment out this change detection. Let me refresh the browser again. 1, 2, 3, 4, 5. You can see the value. Inside console, normal counter value is 50, and we can see the same value in the browser. So it means normal variable depends on change detection in order to display the change on UI. But now I'll show this with a signal variable. I'll again disable this change detection, and as you remember, with normal variable, disabling change detection means we cannot render the updated value on the browser. But now we will see that with a signal variable, we can render the updated value on the browser. So for that here, instead of calling normal variable, I will call signal variable inside this set timeout function. And we can set the value of signal variable using .set method. So here I'll set a different value, that is 30, and I'll comment out this normal variable. And same here, I'll uncomment this signal variable and comment out this normal variable inside HTML file. Okay. Inside console, let me change this variable to counter. And now let me clear the console as well as let me refresh this. Now you can see after 5 seconds, you can see the updated value in the browser as well as console. So it means that a normal variable relies on change detection to update any changes, whereas a signal variable does not. So this is the biggest advantage of using signals in Angular. Additionally, by removing the need of zone.js library, we can increase our application performance. Okay. Now let's understand the effects function in Signal. What is effects in signals? Signals are useful because they notify interested consumers when they change. And an effect is an operation that runs whenever one or more signal values change. And we use the effect function to execute code whenever the value of a signal changes. For example, I want to execute some code whenever the value of counter signal changes. And we can achieve this by using effect function. But we don't use effect function to change the value of signal. Instead, we can use it to execute some extra logic whenever the value of signal changes. And we can use the effect function anywhere in the program, such as inside constructor or inside ngOnInit lifecycle hook. Here I'll create an effect function inside constructor. Let me comment out this set timeout function, and let me uncomment this button. And here inside constructor, I'll write effect function, arrow function, then I'll log one message. Inside console.log, the value of counter is, I'll use counter variable. Here compulsory we need to use counter variable, this dot count. Okay. And effect we need to import from Angular/core. So inside this effect function, I have used the counter signal. Now, whenever the counter value changes, this callback function passed to the effect function will be called, and it will log this message in the console. Now save the changes and go back to browser. Let me clear this console. And once I click on this increment counter button, you can see the counter value increments by 1. Along with that, we are getting message on console. The value of counter is 6. It means that every time the value of this counter signal changes, this callback function passed to the effect function is called. Now you can see if I click on this increment counter button, the value increments by 1 and the respective message is logged on console. Now one more thing about the effect function is that we always need to specify the signal inside this function. For example, if you don't specify any signal inside the effect function like this, now save the changes. So in this case, we are not using any signal inside this effect function. So when this callback function will be called or on which signal change this callback function will be called is unclear. And the answer is it will never get called. So if you are not passing any signal inside this effect function, then this callback function will never get called. Now you can see on the browser. Let me clear this console. Here I click on increment counter button, but the message is not being logged because it's unclear to the effect function which signal change to execute on. But if we pass any signal here like this, now this callback function will be called every time the value of this counter signal changes. So basically the effect function allows you to define code that depends on a signal. So when to use computed function and when to use effect function? We use computed function to compute a value from a signal value, and we use effect function whenever we use to execute some code when the value of a signal changes. So I hope you now have a basic understanding of signals. So let's continue to explore signals and their capabilities. With the release of Angular 19, a new concept has been introduced called linked signal. Linked signal allows you to create signals that can be updated in real time, making it easier to manage complex data flows in your application. So first, let's quickly discuss the evolution of signals. Signals were first introduced in Angular 16 in developer preview, but support for many features was limited. For example, signals could not be used as inputs to components. Next, signals become stable in Angular 17. Angular 18 further improved signal stability and introduced zoneless change detection with signals, offering a more efficient and lightweight approach to detecting changes. And now, Angular 19 introduced a new concept in developer preview called linked signal. Now, let's understand the implementation variants of linked signal. Linked signal supports two implementation variants: shorthand syntax and source and computation configuration. Shorthand syntax provides a simplified syntax for creating linked signals, making your code more concise and easier to maintain. Whereas linked signal with source and computation allows us to define a source signal and a computation function to determine the updated value of the linked signal. So now let's understand these two implementation variants with practical examples. So let me go inside Visual Studio Code. And here I have already created linked signal component and imported that component inside imports array of app component, as well as added the selector of signal component inside app component.html file. So now we can see the linked signal content on the browser. Here you can see. Now when we learned about signal, we discussed there are two types of signals: writable signals and computed signals. Apart from computed signals, Angular now has a great feature called linked signals for defining signals that depends on other signals. So now here what I'll do, I'll create three variable. One is writable signal variable initialized with 1, one is normal variable initialized with 10, and one is computed signal variable. And this computed function calculates the value of total by multiplying the current value of quantity, signal and price. Now to display this total on web, inside h2 tag, I'll add the message calculated total value equals to, inside interpolation, I'll bind this total. And after this h2 tag, I'll create one button called calculate total. And for this button, I'll add one click event, and on click of this button, I'll call one function with name calculate. Now I need to declare this function inside ts file. And in this function, I'll set the value of quantity signal to 2. Quantity signal dot set, I'll pass 2. Now save the changes and go to the browser. Okay, let me correct the spelling of value, and this is signal, so we need to use parenthesis. Now save the changes and let's check on the browser. As you can see here, on page load we are getting total 10 because the initial value of quantity signal is 1 and price is 10. So it will calculate 10 into 1, 10. But when I click on this calculate button, you can see the expected value as 20 because on click of this button, we have updated the quantity signal value to 2 and 10 into 2, 20. Okay, so our code is working as expected with writable and computed signals. Since computed signals are read-only, we cannot directly set a value to it in comparison to writable signals. And to overcome this restriction, we can use linked signal, which is available in two forms: linked signal with shorthand syntax and linked signal with source and computation. So now let's execute the same functionality using linked signal. So for that, I'll copy and paste this computed function here, and I'll comment out this for now. And here, instead of using computed function, I'll use linked signal, which is imported from Angular/core. Okay, so what I did, I just copied this computed function and pasted it here, and instead of computed function, I have written linked signal. That's it. Now save the changes and let's check on the browser to see if our functionality is still working as expected. So let me click on the calculate total button, and as you can see, we are getting expected total, which is 20. But this total we got from linked signal, not from computed function. And if I change the value of signal to 5, then in this case, what will be the total? 5 into 10, 50. Now I'll click on this calculate total and you can see the expected output 50. So this is first implementation variant of linked signal with shorthand syntax. Now let's explore the second implementation variant of linked signal, which is linked signal with source and computation. Okay, let me copy and paste it again and I'll comment out this linked signal. Now, source with computation, linked signal function requires an object with three properties: source, computation, and an optional equal property. So to pass the expected values, instead of using the shorthand syntax, I'll create an object inside this linked signal with properties source and computation. The source property identifies the dependency signal in order to track the linked signal. And in this case, the linked signal depends on the writable signal, which is quantity signal. So here I'll write this dot quantity signal. And computation property defines the computation function that will execute when the source value changes. So here I'll use the same logic as before, which is to calculate the value of total by multiplying the current value of quantity signal and price. So how does it work now? When quantity signal changes, the linked signal detects the update. Then computation function is executed and displaying the total with the new quantity signal value. And the result becomes the new value of total. Now save the changes and let's check the output in the browser. Let me click on this calculate total and you can see the expected output 50 because we have set the value of quantity signal to 5. If I change it to 10, now we will expect the output 100. Here you can see the expected output. Okay, so this is how we can use linked signal with source and computation and this linked signal with shorthand syntax. And one more thing, we can add another property inside this linked signal called the equal property. This is used to specify a custom quality function for comparing values. And this is very simple. We just need to provide the a and b values similar to the sort function in JavaScript. And then we need to match a and b to determine whether the two values are equal. So as the equal function is optional, I won't go into detail about it here. But if you are interested in learning more about equal, I have covered this equal property in another video on signals. You can find the link in the description below, which includes a practical demonstration of equal property. So far we have seen the examples of writable signal, computed signal, linked signal with shorthand syntax, and linked signal with source and computation configuration. And kindly note that this linked signal API is still in developer preview, but it might change before it is stable. Now let's dive into another building block of Angular, routing. And as you know, Angular is a single page application framework, but we can still achieve multi-page navigation using routing. And this allows us to navigate between multiple components while running a single index.html file. Therefore, we will understand how to configure normal routes, default routes, and wildcard routes. And we will also cover the importance of router outlet directive and explore how to redirect between components using the href attribute as well as routerLink directive. So let's open Visual Studio Code and start with the root component. And as we know, the app component is the root component of any Angular application. And we can create multiple components under the app component using the CLI command ngGenerate component name. So far we have created multiple components like attribute directives, data binding directives, signals, structural directives, etc. But to render each component on the web, we have added the component selector in the app.component.html file here. But in a real world project, this approach is not feasible because Angular is a component based framework and we often need to redirect from one component to another. And to achieve this, we need to use routing. So to demonstrate route, let's create a navbar. And since we have already installed the Bootstrap, we will use Bootstrap navbar. Let me comment out this attribute directive component first. And now let me open browser and here I'll search Bootstrap 5.3 navbar. And here let me copy this first example, copy to clipboard, and I'll paste it into the app.component.html file. So here, instead of this selector, I'll paste the navbar code. And now I'll make some modifications to the navbar code. Like here, I'll comment out the first. You comment out this anchor as well. Also, I'll comment out this drop down. And here, instead of link, I'll write user and I'll add few more li here. This li is for data binding. This li is for structural directive. And this is for attribute directive. Now save the changes and let me open browser. And here you can see the navbar is displayed. I'll update the background color. Instead of tertiary, I'll write secondary, which should improve the appearance of navbar. Save the changes and now you can see it looks good. Now when I click on this link or if I type a component URL here like user, I want to navigate to the corresponding component, and to achieve this we will utilize Angular routing feature. So now let's understand how to add routing to an Angular application. Let's go back to Visual Studio Code and here we have an index.html file with a base href tag, which is automatically generated when we create an Angular application. And the href attribute specifies the base URL for all relative URLs on a page. So during navigation, the Angular router uses the base href tag as a base path to the component. Therefore, without this base href tag, routing won't work. And when we created our Angular application, we were asked, would you like to add Angular routing? Since we said yes, we don't need to install any third-party packages to implement routing because routing is a library included in Angular by default when creating a new project. And as a result, we have a file called app.routes.ts. And prior to Angular 16, this file was a module, but now it's a normal constant TypeScript file. So here we have an empty routes array created with the database routes. And this routes allows us to map a specific URL to a particular component, enabling us to access that component through a unique URL, such as a route defines the URL path that corresponds to a specific component. So now let's create route. And a route is an object that consists of two parameters. First parameter is path, and this is the URL path for your component. And it can be any name. For example, I'll write user for the user component. And second parameter is component. And this parameter specifies which component to render when the path is accessed. We need to provide the component class name here. And in our case, for the user path, I'll write user component. Okay, so this is how we can create routes in Angular. I repeat, a route is an object, and within that object, we have two parameters, path and component. And path refers to the link for your component, which can be any name. For example, we have created a user component. That is why I have set its path to user. And second parameter is component. This specifies which component to render when this user path is accessed. So in this case, when a user accesses the user path, it means they want to be redirected to the user component. Okay. So like this, we can add multiple route objects as needed. So here, let me add three more routes. One is for data binding component. And for this path, I want to redirect to data binding component. And next path is for structural directive. And for this path, I want to redirect to structural directive component. And last, I'll add attribute directive. And for this, I want to redirect to attribute directive component. Okay. So this is how we can configure the normal routes in Angular. But simply defining a route does not render the corresponding component on the web when we type the URL or click the navbar link. This is because Angular requires the router outlet directive in our template to serve as a placeholder where the router will render the component associated with the current route. So here after this navbar, let me add router outlet. And starting from Angular 17, it's compulsory to import router outlet in our modules imports array. So let me uncomment this and now save the changes. And here you can see on the browser the user components rendered along with the navbar. Okay, so what is routing? Routing enables navigation or redirection from one component to another. And what is router outlet? Router outlet is a directive or it is a placeholder where the router renders the component associated with the current route. Especially, it is a container where Angular displays the component corresponding to the current URL. Let's try another URL. Like here, instead of user, I'll write data binding. And here you can see the data binding component rendered on the web. Similarly, let me copy paste the next path, that is structural directive. So here instead of data binding, let me paste structural directive. And here you can see the component of structural directive rendered on web. And last, attribute directive. Enter. And we can see the attribute directive component also on web along with navbar. Now, let me open the developer tool. Let me clear the console. And if I reload the browser on localhost 4200 or enter an incorrect path, Like instead of user, I'll write users and hit enter. You can see I get a 404 error. This is because we haven't handled empty routes and wildcard routes yet. So let's configure an empty routes first. And empty routes is also called as default route, which means that when no URL is specified, a default route determines which component to render on the web. And the default route must be defined as the first object in the routes array. And there are two ways to define a default route. First way is similar to a normal route, but with empty path. So here path equals to empty string, comma, second parameter, component. And for this component parameter, we need to specify the component name that Angular will render when the empty path is accessed. So here, if the path is empty, I'd like to render on user component. Okay, so this configuration tells Angular to render the user component when the empty path is accessed. Let me save this and let me test in the browser. If I delete this and if I reload this browser on localhost 4200, now you can see the user component has rendered on browser. Now let's understand the second way to define the default route with three parameters. So let me comment out this first way, and below this I'll add the second object. And as I said, this second way is contain three parameters. First parameter is path, and this will be an empty string, comma, and second parameter is redirect to. This parameter specifies the URL path to redirect to when no URL is provided. And here you can see starting from Angular 18, the redirect to parameter accepts two types of values. First is string and second is redirect function. String type value means the component path where you want to redirect your application. And redirect function means this allows us to write an arrow function that specifies a conditional statement to determine the redirect path. And the redirect occurs only if the condition returns true, otherwise no redirect happens. But prior to Angular 18, only string type value were supported for the redirect to parameter. So as of now, I'll go with string type value and here I'll pass user path. Now third parameter we need to add path match. And this parameter specifies how the router matches URLs to routes, controlling whether the match is exact or prefix based. And again, it has two possible values. One is full, means the router only matches the route if the entire URL matches the route path. And second is prefix, means the router matches the route if the URL starts with the route. So in this case, we use path match full to ensure the router only matches the default route when the entire URL is empty. Now let's check the application in the browser, and let me reload this application on 4200. And this time also you can see instead of throwing an error, the application redirects to the user component. Okay, so this is the purpose of default route. But what if someone enters an incorrect URL? Like here, instead of user, I write users and hit enter. In this case, we are still getting an error. And to handle such routes, we use something called wildcard routes. So now let's configure the wildcard routes. So what is the purpose of wildcard route? Wildcard routes handle the URLs that are not defined in an application. And when the router encounters an unrecognized URL, it can redirect to a specified component. For example, a wildcard route can navigate to a 404 page for any invalid route. So to demonstrate this, I'll create a new component called page not found. ng generate component, page not found component. And inside HTML file, I'll add 404 page not found message. Div.textCenter, and inside this div, I'll take h3 and I'll add message 404 page not found. Save the changes and let's add the route for invalid URL. And note that the wildcard routes must be defined as the last object in the routes configuration. Default route must be the first object and wildcard route must be the last object in the routes configuration. And similar to normal routes, this object also contains two parameters. First is path, and this path specified as 2 asterisks to match every route. And second parameter component specified as page not found component. So save the changes and let's retest this scenario by typing an incorrect URL. So here instead of user, I'll write users, and here you can see this time we are redirected to the page not found component with 404 page not found message. And if I type a correct URL like user and hit enter, I can navigate to the user component. However, if I type incorrect URL, I am redirected to the page not found component. So this is the purpose of wildcard routes. Instead of throwing error, we can redirect that incorrect routes to the page not found component. Okay. So far we have covered the syntax of default routes, the syntax of normal routes, and the syntax of wildcard routes. And also we have understood how to redirect to another component through URL, like here. Now let's explore how to redirect from one component to another when a navbar link is clicked. In normal HTML, we use the href tag to navigate between pages. So let's try this with an example. So instead of this hash symbol, we simply provide the same path name of the respective component that we configured in the routes array. So first I'll provide the user path for this user link. And for data binding, I'll provide the same data binding path from routes array. Similarly, I'll copy paste the structural directive as well as attribute directive. That's it. Now save the changes and let me open browser and click on any link and you will be redirected to the respective component using href attribute. However, you might notice that the entire page is refreshed during the redirection. Here you can see. If I click on attribute directive, you can see the entire page is reloading. I'll do this one more time and you will see that the page refreshes with every redirection. Okay. But this is not ideal in Angular application because Angular is designed for building single page applications and single page application is a web application that loads a single HTML page and dynamically updates its content without requiring a full page reload. And what single page application does? In single page application, the server sends the necessary data to the client and after that only the required information is fetched from the server as the user interacts with the web page. The page is then dynamically rewritten to reflect the changes. And this is the core principle of single page applications. So now let's resolve the page reloading issue using Angular's routerLink directive. And to use this directive, first we need to import it inside imports array. So here I'll import routerLink. And there are 4 ways to use routerLink directive. So inside HTML file, we can use this routerLink directive instead of href. So here we need to write a routerLink with a lowercase r and an uppercase link. And we need to add the same path name user for this user link. So this is the first way to use routerLink directive. Now let's understand the second way. Second way is also the same. Only the difference is we can use the path name with forward slash like this. And the third way is instead of href, I'll paste router link. And here we can use property binding. So for that, we need to wrap this router link inside square bracket. But in this case, we need to bind the path name as a string like this inside single quote. So this is the third way. Now, fourth way. Again, I'll wrap this router link inside square bracket like property binding. And in this fourth method, we can wrap this path name inside square bracket like an array with single quotes. And after this path, we can add parameters like ID, name, status, etc. separated by comma. So in future, if you need to pass such kind of parameters, then you can choose this syntax to use router link directive. Okay, so with these four syntaxes, we can use router link directive in Angular. Now let's test this in the browser. And now kindly notice the refresh icon. Now when I click on this user link, I am redirected to the user component without a page reload. Similarly, clicking on data binding link, again I am redirected to the data binding component. Now I'll click on structural directive and does not refresh the page. So it is indicating that our router link directive is working as expected. Okay, so with this we have achieved routing on link click without page reload. Now let's quickly explore another directive called routerLinkActive directive. And this directive allows us to dynamically add CSS classes to an element when its link route is currently active. For example, currently we are on user component, but it is unclear to the user which link is active in the navbar. So to fix this, we can use the routerLinkActive directive. Okay, so for that, first I'll import the routerLinkActive directive inside imports array. RouterLinkActive, save the changes, and again I'll go inside HTML file, and here I'll assign the active class to the routerLinkActive directive. RouterLinkActive equals to active. Now next, I'll add the CSS for the active class in the SCSS file of same component. So here dot active, and inside this I'll write font weight bold. Okay, and now I'll apply the same directive to the remaining three components here. Save the changes, and here you can see now the current active link is displayed in bold, and when I click on another link, then that link becomes active like this. So it means user can easily understand currently which link is active. So this is how we can make the necessary changes using the routerLinkActive directive. Now we will explore how to navigate from one component to another using the navigate method. So what is the navigate method, or why do we need the navigate method? In Angular, the navigate method is a part of the router class that enables navigation between routes in an application. And we have already seen how to navigate between components using the router link directive. However, this method has limitations, like it can only be used for simple navigation without performing any task. And if you need to perform any task before navigating to the next page, we must use the router.navigate or router.navigateByUrl method. So let's create a scenario first inside user component where we have a login form with two fields and a login button. And on click of the login button, usually we need to perform an API call, and if the credentials are correct, we can navigate to another component. Okay, so I'll go inside user component. Let me open HTML and TS file. And here inside HTML file, I'll add one div with container class. And inside this div, I'll write one more div with class text center. And here let me add one h2 for heading. Welcome to login. After that, I'll take label for username. And then I'll take one input field with placeholder. Enter your username. And let me copy paste the same line for password. This input type will be password. Okay, next I'll take one button.btn.btn primary, and the button name is login. Okay, let me add br tag. Let me add few more bootstrap classes. Width 50, padding 5, border secondary. And for this main div, I'll add class deflex, justify content center, margin top 5, and also I'll add inline style, height 100%. Okay, so as you can see here, we have created a simple login page. Now, after entering username and password, when we click the login button, an API call should be triggered. And if the credentials are valid, the user should be redirected to another component, such as data binding, structural directive, or attribute directive component. And in Angular, there are two ways to navigate between routes. First way is to use the routerLink directive in the HTML template file along with the forward slash. And the another way is to use the router.navigate method in a TypeScript file. So let's understand this practically. First, let's try to navigating using the routerLink directive. And to do this, we need to import the routerLink in the imports array. And after that, we need to add routerLink to this button. RouterLink equals to, inside double quotes, we need to use forward slash, and then here we need to provide the routes. Inside routes.ts file, we have configured routes. So I'll copy the path of this structural directive component and I'll paste it here. Okay, that's it. Save the changes and let me open the browser. Before that, I want to show you, if I remove this router link directive, on click of this login button, as you can see, I cannot redirect to another component. And when I paste this router link directive here, now when I click the login button, I can navigate to the structural directive component. And this approach only provides basic navigation and doesn't support the more complex functionality we need. But the actual functionality requires us to first verify the user credentials and then redirect them to another component. But using router link doesn't allow us to perform tasks before navigating to the next page. So to achieve this, we need to use the navigate method. And to use navigate method, we need to add a click event to the HTML file. So let's remove the router link directive from this HTML file and replace it with click event. And that calls the login data function. Next, we will define this function in the TS file. So here. Now, to use the navigate method in the TS file, first we need to inject the router service. And for that, we will create an instance of a router service in the constructor and store it in a private variable. So here, constructor, and inside constructor, I'll create private variable called router of type router. And once we do this, the necessary imports will be automatically added from the @angular/route package. Now inside the login data function, in a real world application, we would typically implement authentication logic to verify user credentials. And upon successful verification, the user would be navigated to the next page. But for simplicity, let's assume our login credentials are correct and proceed with the navigation. So here, let me add comment like user verification logic And after that, we will use the navigate method provided by the router service. So here when we type this dot router dot, we see two available methods like navigate and navigate by URL. We will use both methods. So first I'll go with navigate by URL method, and this method accepts a root path as a string. Here you can see URL of type string. So inside double quote, I need to provide the path. And when the login button is clicked, we want to redirect the application to the structural directive component. So I'll add the path of structural directive component. Okay. Now save the changes and let's open the browser. Let me enter valid credentials here. XYZ, XYZ123 and click the login button. And here you can see I can navigate to the structural directive component. So this is how we can programmatically navigate between components from the TypeScript file. Now let's achieve the same functionality using the navigate method. So for that I'll comment out this line, and instead of this I'll use navigate method. Router.navigate, and here you can see this method accepts array where we pass route as the first element, and after this we can pass any additional parameters separated by commas. Let's save the changes and let me reopen the browser. First I'll navigate to user component and then I'll re-enter the valid credentials XYZ123 and click the login button. And again I can redirect to the structural directive component. Okay, so we have seen navigation between components using navigate method as well as navigate by URL method. And what is the difference between navigate and navigate by URL? Both methods navigate routes, but they differ in how they accept route paths. The navigate method takes an array of route paths, while the navigate by URL method takes an absolute. Next, let's examine another crucial aspect of Angular called lifecycle hooks and explore how they work. And as we all know, Angular is a component based framework and every component goes through different phases. These phases are essentially lifecycle hooks, and it is also called as component architecture. So in most of the interviews, you will likely be asked, what are lifecycle hooks? And you can answer this question. Lifecycle hooks are a series of methods that Angular calls at different stages of the component lifecycle. And these hooks enable developers to execute specific code at specific points, such as initialization, updates, and destruction. Also, you can explain it like when we create a component through the CLI and add its selector inside app.component.html file, Angular creates an instance of that component in the DOM. And only then we can see that component on the web. And whenever a new instance is created in the DOM, the component goes through several phases. And Angular gives us the opportunity to hook our code into these phases, which is essentially life cycle hooks. So in Angular, there are 8 life cycle hooks, and the component timeline, the constructor is called first, followed by the first life cycle hooks, that is ngOnChanges. So let's dive into the list of life cycle hooks and explore their execution order. First life cycle hook is ngOnChanges. This hook executes multiple times whenever a change occurs in the data bound with the @input decorator. And this is the only hook that works with an argument. But we will explore these hooks practically when learning about @input and @output decorators. So let's understand second hook, that is ngOnInit. This hook executes once after the component is initialized or loaded. Next hook is ngDoCheck. This hook also executes multiple times if any change is detected in the component, such as button click or any action or event. Fourth hook is ngAfterContentInit. This hook executes whenever the content of the component is projected through the ngContent element. Like if we initialize any content in the component using ngContent, this hook will be called. Now fifth hook is ngAfterContentCheck, and this hook works similarly to ngOnChanges, just as ngOnChanges is triggered when a change is detected in an @input decorator, and ngAfterContentCheck is triggered when a change is detected in the ngContent element. Next hook is ngAfterViewInit. This hook executes once after the component's view is fully rendered on the web. And next, ngAfterViewCheck. This hook executes once after the component and its child view are fully rendered on the web. And the last hook is ngOnDestroy. This hook executes before the component is destroyed from the DOM. For example, if we navigate to another component, the previous component will be destroyed and the new component will be added to the DOM. Okay, so these are the 8 lifecycle hooks available in Angular. Now let's learn how to write these lifecycle hooks in an Angular project, and we'll see the execution order practically. So for that, I'll use the user component where we created the login page and learned about navigate and navigateByUrl method. So as I mentioned earlier, in the component timeline, the constructor is called first, and the constructor is a special method that is called when an instance of the class is created. And to understand, I log a message to the console when the constructor is called. So here I'll just simply print constructor called. Okay, and we can use constructor to initialize variable value. Like if I declare one variable here, topic of type any, then I can assign the value to topic inside constructor. Topic equals to Angular 19, like this. So we can use the constructor to initialize variable value. Okay, so let me delete this and we'll go with console. Now save the changes and let me open the browser and open the developer tool. Here you can see we can log the message constructor called on the console because the constructor is called once an instance of the user class is created. Okay, now let's move forward to understand lifecycle hooks. And these 8 lifecycle hooks are still used in the same way as in previous versions of Angular. So after this constructor, the first lifecycle hook to be called is ngOnChanges. And this hook is only called when changes are made using the @input decorator. And we will dive deeper into this hook later. But for now, I'll add a console log inside ngOnChanges method, but it won't trigger since we have not initialized the @input decorator yet. And to use any lifecycle hook in Angular, the class must implement the lifecycle hook interface without the ng prefix. So here, let me implement onChanges hook. So next, we need to define the lifecycle hook ngOnChanges, and inside this hook, I log a message when ngOnChanges is called. So here, simply type ngOnChanges called. And since this is the first lifecycle hook, I'll add one inside the console for our understanding. Now save the changes and let's check in the browser. And we can see in the console that only the constructor was called and the ngOnChanges hook was not called because we have not initialized the @input decorator yet. Now let's write code for the second hook, that is ngOnInit. And ngOnInit hook is called after the component constructor and after the first lifecycle hook, that is ngOnChanges. And again, to use this hook, the user component class needs to implement the onInit interface. And next, we need to define the ngOnInit hook inside the class. And inside this ngOnInit lifecycle, we can write the code for API integration. Alternatively, we can call multiple APIs in separate methods and call those methods inside this ngOnInit lifecycle hook. So here, let me add comment to use this hook for API call. And here also, I'll add comment use for component input property. Okay, so for now, I'll simply log a message ngOnInit called and mark it as a second life cycle hook in the console. Now save the changes and let's check this hook in the console. Let me clear the console and let me redirect to the user component. And as you can see, the constructor is called first, followed by the second life cycle hook ngOnInit. Now similarly, I'll add remaining hook, then we will see all the outputs together in the console. So here I'll implement all the life cycle hooks without the ng prefix. Like third life cycle hook is do check, and fourth is after content init, and then after content check, then after view init, then after content init, then after view check, and last on destroy. Now let's define each hook one by one along with the respective message in the console. So here let me add third lifecycle hook, that is ngDoCheck, and this hook is called repeatedly during every change detection cycle. So here let me add comment use for every change detection. And I log console with message ngDoCheck called. Now next hook is ng after content init. And this hook is called after the child component's content, especially the ng content, has been initialized. So here I'll add comment use for ng content. And then I'll log one message with number 4 ng after content init called. Now fifth life cycle hook is ng after content check. And this hook is called after the child component's content or ng content has been checked. So this hook is called after the ng content has been initialized, and this hook is called after the ng content has been checked. So let me add console.log here with message ng after content check. Now next hook is ng after view init, and this method is called after the component's view has been initialized. So this hook is typically used for view child, getting element reference, and other view related tasks. So here let me add comment use for view child. And after that I'll log console with message ng after view init. After that, seventh lifecycle hook is ng after view check. And this method is called after the component's view has been checked. ng after view init is called after the component's view has been initialized, and ng after view check called after the component's view has been checked. So let me add console.log here with ng after view check. And finally, when the component is destroyed, the ng on destroyed method is called. So inside this method, let me add console.log with message ng on destroy called. Okay, so these lifecycle methods provide hooks for the component to perform specific tasks at different stages of its lifecycle. Now let's check the order of execution in the browser console. Let me open browser. I'll navigate to another component and let me clear the console, and then I'll re-render to the user component in the browser. Okay. Now here you can see that as soon as I render the user component, the constructor is called first. And since We did not add any code with the input property. The first lifecycle hook ngOnChanges is not called. Instead, we see the second lifecycle hook, that is ngOnInit, followed by the third lifecycle hook ngDoCheck. After that, fourth lifecycle hook is called ngAfterContentInit, and then fifth lifecycle hook ngAfterContentCheck called. After that, sixth lifecycle hook ngAfterViewInit called, and then seventh ngAfterViewCheck called. And to call the ngOnDestroy hook, I'll navigate to the another component, and here you can see, as expected, ngOnDestroy hook is also called just before the component is destroyed. Let me do this one more time. I'll clear the console, and again I'll redirect to user component. We can see constructor and 6 lifecycle hooks from second to 7. And once I click on this login button, the ngOnDestroy hook is called just before the component is destroyed. Okay, so this is how we have called all the hooks except ngOnChanges. And one more thing, as I mentioned earlier, this is the execution order of lifecycle hooks in Angular. It means you can write the code in any order, but it will be executed in the same order. For example, if I change the sequence of writing lifecycle hooks in the code, like if I cut these two methods from here and I'll paste them after the ngOnDestroy hook. Now save the changes and you can see the console. Let me redirect to user component and then I'll click on this login. And you can still see in the console that the same execution order is maintained just like before. 2, 3, 4, 5, 6, 7, 8. So this is all about the 8 lifecycle hooks in Angular. And apart from all 8 lifecycle hooks, the ones we frequently use are ngOnInit, ngAfterViewInit, ngAfterViewCheck, and ngOnDestroy. So for better understanding, I would request you to practice these 4 hooks in your project. Okay, so with this, I'll conclude our discussion on this topic. Now let's move forward and explore our next topic called pipes. In this section, we will dive into the built-in pipes and examine each one with practical examples. So let's begin with the definition. What are pipes? Angular pipes are a powerful tool for transforming and formatting data in Angular templates. Essentially, they are functions that take data as input, perform operations on it, and return the transformed data. So, this is the definition of pipes, or in other words, we can say pipes are simple functions that are provided by Angular by default, allowing us to format data before it is rendered on the user interface. And when to use pipes? Pipes are useful in various scenarios, including formatting data for display, such as dates, times, currencies, and more. Next, converting data types like strings to uppercase, lowercase, or title case. Next, we can use pipes for performing calculations or aggregations like sums, averages, and more. Also, we can use pipes for filtering or sorting data to display only relevant information. So, overall, pipes offer a convenient and efficient way to transform and manipulate data in Angular applications. Angular also provides us with some built-in pipes to format data. So let's move forward and understand the various types of built-in pipes available in Angular along with their one-line definitions. And the first built-in pipe is lowercase pipe. This pipe converts the string or text to lowercase. Similarly, we can convert strings or text to uppercase using the uppercase pipe. So both of these pipes are useful when we need to display text in a uniform case. Now, third pipe is title case pipe. It converts text to the title case where the first letter of each word is capitalized. Next pipe is date pipe. This pipe formats date according to the specified format, and we can use predefined formats or create our own custom formats, which we will see with an example while learning the concept of custom pipes. Moving on, let's discuss the next pipe, JSON pipe. It converts objects or data to JSON string, and this pipe is useful when we need to display data in a JSON format. Next is decimal pipe. This pipe formats numbers as a decimal values, allowing us to specify the desired level of precision. Next is percent pipe. This pipe converts numbers to percentages and displaying them with a percent sign. Next built-in pipe is currency pipe. This pipe formats numbers as currency values, allowing us to specify the desired format such as symbol, decimal places, and more. Next is slice pipe. This pipe extracts a specified subset of elements from an array or a string, allowing us to define the start and end indices. And the last built-in pipe is async pipe. The async pipe subscribes to an observable or promise and returns the emitted values as they become available. Okay, so Angular provides a total of 10 built-in pipes. Now let's learn how to use these pipes in templates. So let's open Visual Studio Code Editor. And for this built-in pipe, I'll create a new component called built-in pipes. And to render this component on web, I'll add a new route in the app.routes.ts file. And since we are already covered routing, I'll create a route instead of adding a selector to an app component. So here, let me add path, built-in pipe. And for this path, I'll bind the component built-in pipe. Next, inside app.component.html file, I'll add a new nav atom for built-in pipes component. And I'll update the corresponding router link path, built-in pipes. Now let's check the result in the browser, and you can see the new nav atom called built-in pipes on the navbar. And once I click on this built-in pipes nav atom, it should redirect us to the pipe component. And as you can see, the redirection is successful. Now next, let's close all the files and open the template and class files of the built-in pipes component. Now inside the class file, I'll declare a variable called Angular pipes of type string, and I'll provide a short definition of a pipe as its value. And the definition of pipe is use pipes to format data in Angular templates. Okay, now I want to display this pipe definition in the browser. So for that, I'll use the string interpolation to bind this Angular pipe variable inside this same components HTML file. So here, instead of this paragraph, I'll add a div with class margin 3. And inside this div, I'll add h3 tag. And inside this, I'll write pipe, and then with the help of string interpolation, I'll bind the variable Angular pipes. Now save the changes and let's check the result in the browser. And as we can see, the definition of a pipe rendered on the web. Now next, as we know that pipes can be used to format template data. So let's try formatting this string type data using pipes. So before that, I'll add another heading tag h3 with class text primary and margin 3. And I'll add text string type pipes. And instead of h3 here, I'll use h4. And first we will explore string type pipes. Now, when working with a standalone component, first we need to import the required modules or dependencies inside the imports array of the component's class file. So here, in order to use Angular pipes, we have to import it first inside the imports array. And for that, we have two options. Either imports individual pipes like uppercase pipe, lowercase pipe, etc. from the Angular/common package, or we can import the entire common module. And by adding the common module, we don't need to import each pipe separately. So I'll go with common module. So this is our first step. Now second step is to use a pipe in an Angular template. And to do this, we need to use the pipe operator like this, one standing line followed by the name of the pipe. So first we'll see the uppercase pipe. So like this, we need to write uppercase after the pipe operator. So this would format the Angular pipe variable data in uppercase using the uppercase pipe. Now save the changes and let's test it in the browser. And as expected, we can see that all the text assigned to the Angular pipe variable has been converted to uppercase letters. Similarly, I'll use the lowercase and title case pipe. And to do this, I simply need to replace the pipe name. So instead of uppercase, I'll write lowercase. And here I'll write title case. Also, I'll update the pipe name, uppercase, lowercase, and this is title case. Now save the changes and let's retest. And here you can see the same text is displayed in three different formats. First is in uppercase, second is in lowercase, and third is in title case. And title case means first letter of each word should be in caps like this. Now next, let's explore the slice pipe. So let me add the number here. This is first pipe, this is second pipe, this is third pipe. Now I'll add the fourth pipe. The name of pipe is slice pipe. And this slice pipe is used to extract a subset of elements from an array or a subset of characters from a string. So first, let's see an example with a string. And the syntax of slice pipe is pipe operator followed by pipe name slice. And after that, we need to provide the index like start index and end index. For example, 4 and 8. So here first I'll write few more example of slice and then I'll explain. So here you can see I have written 4 example of slice. In first example, I have added 4 index and 8 index. It means this returns the characters from the 4th index to the 8th index, considering that indexes start at 0. And in the second example, I have provided only one value, or we can say only one index. Then it returns the character from the 4th index to the end of the string. And in the third example, I have provided a negative value as the second digit. It means this returns the characters from the 4th index to 10 characters from the end of the string. And in last example, I have provided only negative value. It means this returns only the last 10 characters from the end of the string. Now let's check in the browser. And here you can see in first example, I have mentioned 4:8. It means you can see 0, 1, 2, 3, and then 4. So the string will return from 4th index to 8th index inclusive. So that is why we are getting output 5. And in the next example, we have provided only one value 4. So in this example, we are getting string from 4th index to the end of the string. And in third example, 4:-10, we are getting result as a string from 4th index to 10 characters from the end of the string. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is why we are getting output till Angular. And in the last example, we have provided only one negative value, that is -10, and this returns only the last 10 characters from the end of the string. And the last 10 characters are templates. Okay, now let's see an example with an array. So for that, here instead of string, let me add array with numbers 1, 2, 3, 4, 5, 6. And in this case, here I'll pass value 1:3. So as a result, this 1:3 returns the atoms from the first index to the third index. Therefore, we can expect the output to be 2 and 3 because this is our 0th index and this is our first index. And then this is second and this is third. So it will consider the first index and second index. It will not consider the third index. So let's check in the browser. And here you can see the output of last slice pipe is 2, 3. And here also we can provide only one index like 1. Then we will get 2, 3, 4, 5, 6. So from first index, we will get everything till last index. Same with negative value. If I write -1, then I'll get only last index 6. And if I give 1 colon -1, then I'll get 2, 3, 4, 5. Save the changes and you can see the output 2, 3, 4, 5. Same like string. So we have seen the slice pipe with a string as well as an array. Now, under the category of string type pipes, let's explore another type of pipe called JSON pipe. So here, let me copy paste the h4 for JSON pipe. And this pipe is used to convert data into a JSON string. And to demonstrate this, I'll create an object person data. And inside that, I'll write some dummy data like name, John, age 30, and city, Mumbai. Now, if I want to print this object data in JSON format on the web, then I simply use the pipe symbol after the object name. So let me copy this object and here I'll paste the object name and then pipe operator and then name of the pipe, that is JSON. Save the changes, test, and here you can see the object is in JSON format. Or to display the JSON data in formatted way, I can wrap the same code in pre-tag, which represents pre-formatted text and making it easier to read and understand. So save the changes and now you can see two JSON output, one using h4 tag and other using pre-tag. Okay. So these 5 built-in pipes, uppercase, lowercase, title case, slice pipe and JSON pipe can be used to format string type data. Now let's move on to the number type pipes. So let me copy and paste this h3 element and update the text with number type pipes. Now let's start with date pipe. So here let me take one more h4 tag and inside that I'll write date pipe. And this date pipe is commonly used pipe in Angular projects and it formats dates and times. So to demonstrate this date pipe, let me create a new variable called current date of type date and I'll assign it the current date, means new date. Now let me print this current date on the web. So here inside string interpolation, I'll write current date variable. Now save the changes and let me open browser and here let me comment out these string type pipes for now so that we can focus on number type pipes. Especially we will explore the date pipe. And as you can see here, the date is displayed with the day, month, date, year, time in hours, minutes, milliseconds. However, most of the time we don't need such a detailed date format. This is where the date pipe comes in handy. So we can use the date pipe in multiple ways to format the date according to our requirements. For example, inside interpolation, in order to use any pipes in Angular, we need to use pipe operator and then name of the pipe, date pipe. So with this date pipe, we can see the date like this format, month, date and year. Also, we can specify the date pipe along with its argument like colon and inside single quote, we can pass short as its argument. It means the date pipe is used to format the dates and the short argument specifies that the date should be displayed in the short format. Save the changes and here you can see the date is in short format. Similarly, I'll write the date pipe with other arguments. So here we can use short date, short time, medium, and then medium date, medium time. Same name. We'll now copy paste here. Now save the changes and let's test it in the browser. If we use only date pipe, then it will display the date in month, date, and year format. And if we use short argument along with date, then it will display date and time in short format. And if we use short date argument with date pipe, then it will display only the date from the short argument. Same, if we use short time argument along with date, then it will display the only time from this short argument like this. And next, if we use the medium argument along with date, then it will display the date and time in medium format. And if we use medium date argument along with date, then it will display the date from this medium argument. And if we use the medium time argument along with date, then it will display only the date from the medium date pipe argument like this. Also, apart from this, if we want other format, then we can create a custom pipe so that we can customize the date format as per requirement. Now let's understand the next pipe, that is decimal pipe. Let me update the name, decimal pipe, which is also called as number pipe. And this pipe is used to formats number as a decimal values with specified precision. So let's format the value of pi, and the value of pi is 3.141592653. And now if I want to format the value of pi up to 3 decimal places like 3.141, so in this case I can use the number pipe. And the syntax of number pipe is, we need to write the pipe name, that is number, and then colon, and inside single quotes we need to mention the value. Like first value is for before decimal and the second value is for after decimal. So I want one number before the decimal points and three numbers after the decimal points like this, 3.141. Save the changes and let's check. Here you can see the output 3.142. We are getting result 3.142 because the next number is greater than or equal to 5. And if I want 2 digit before the decimal point, then I need to write here instead of 1, 2. And now it will append a 0 before this 3 if necessary. So save the changes and here you can see 03142. And the same applies to the digits after the decimal point. Like here, if I edit this number like this 3.14, and if I want the 5 digit after the decimal point, in this case, now I should get the output 03.14000. So let's check in the browser. Here you can see 03.14000. Okay, so this is all about decimal pipe. Now moving forward with percent and currency pipe. Here, let me add the name of pipe first. Percent pipe, and this is currency pipe. And the percent pipe formats numbers as a percentages. Like here, if I write 0.25 and then pipe operator, and after that name of the pipe, percent. And next pipe is currency pipe. Currency pipe formats number as a currency value. By default, it displays the value in dollars, like here 123.20, pipe operator, and then name of the pipe, currency, and save the changes. And here you can see the output of percent pipe, that is 25%, and the output of currency pipe $123.20. And here we can also specify other currencies like colon EUR, euro. Here I'll write INR, Indian currency. Save the changes and here you can see the output of currency type values. in dollars, euros, and Indian rupees. And one more thing, we can also chain multiple pipes together. For example, let's format this date in uppercase. So here, after this date pipe, I'll use one more pipe operator and then I can write uppercase. So in this case, it will format the current date variable as a date using date pipe and then convert the result to the uppercase using uppercase pipe. So let's check in the browser, and here you can see, as expected, the formatted date is now in uppercase. Okay, so far we have explored Angular's built-in string and number pipes. And we can use these pipes as needed in our projects to format and transform data. Now, let's move on to the last pipe, which is the async pipe. So here, let me add the heading for async pipe and I'll comment out this number type pipe for now. Okay, here I'll add h4 tag for async pipe. And this is the last pipe, so I'll write number 10, async pipe. And this async pipe accepts as an observable or a promise as an input and automatically renders the output without requiring manual calls to then or subscribe. So to demonstrate this pipe, let's create a property inside TS file called atoms equals to, I'll assign it an observable using rxJS of operator. Okay, it is imported from rxJS library. And inside the of operator, I'll add a array with dummy data. So here, let me add the fruits name, apple, banana, mango. And now in the template file, let's use the async pipe to subscribe to the atoms observable and display the emitted array of atoms using ngFor directive. So here I'll take one UL tag and inside UL I'll take one li tag and inside li I'll use star ngFor directive. Or instead of using the ngFor directive, let's use the @for control flow statement. And the syntax of @for block is item of items semicolon and then we need to use track feature, track item. And I'll shift this li inside curly brackets. Okay. Now inside the string interpolation, we will bind the value of item. But we will not get the fruit list inside this list because the atoms is a type of observable. And in order to fetch the value from these atoms, we need to use the async pipe. So here, after this atoms, we will use the pipe operator followed by the pipe name async. Now let's test in the browser and we can see the fruit list apple, banana, mango in the browser. So it means the async pipe takes care of subscribing to the observable and displaying the data in your template. And with this, we have successfully covered all the built-in types in Angular. First, we have seen the string type pipes. Under this, we have covered uppercase pipe, lowercase pipe, title case pipe, slice pipe, and JSON pipe. Then we have seen the number type pipes. Under this, we have covered date pipe, decimal pipe, percent pipe, and currency pipe. And last, we have seen the async pipe. Now, let's dive deeper and learn how to create a custom pipe. Also, we will cover the key differences between pure and impure pipes. So first, let's understand what steps we need to follow to create custom pipes. But before that, let's discuss when we need to create custom pipes. So in Angular, we should create custom pipes when we need to format data in a unique way, or we need to reuse transformation logic across multiple components. Or also we can create custom pipes to improve performance by reducing calculations or sorting results. But these scenarios include cases where built-in pipes can't format data as needed. Now, let's move forward and discuss the steps to create custom pipe. And the first step is creation. we need to create a new pipe by either creating a new file for pipe or using the Angular CLI command ngGenerate pipe name. But if we create a new file for pipe, then we need to implement the second step, which is to implement the interface. Especially, we need to implement the pipe transform interface by adding the transform method to pipe class. Third step is to add transformation logic. In the transform method, we need to add custom transformation logic. And these three steps, creation, implementation, and logic, need to be implemented inside the pipe.ts file. Now, fourth step is declaration, where we import the custom pipe in the component class file of the component where it's needed. And finally, the fifth step is to use the custom pipe in the same component template file, just like we would use built-in pipes. Now, let's apply these 5 steps to create a custom pipe and explore few examples. So I will open Visual Studio Code Editor and let's follow the first step, which is creating a pipe. And to do this, I'll use the Angular CLI command to generate a pipe, and the command is ngGenerate pipe name. P for pipe name, and I'll write pipe name custom. Hit enter, and this command creates a new custom pipe with a default pipe syntax. We don't need to write it from scratch. And the Angular CLI command generates two files, a .ts file and a spec.ts file. And now we will focus on .ts file while the spec.ts file is used for testing. Now, inside the custom.pipe.ts file, you can see the default pipe syntax. And our custom pipe implements the pipe transform interface by adding the transform method to our custom pipe class. And this transform method takes in data as input, performs some operation on it, and return the transformed data. And this pipe transform interface is imported from Angular/core package. So if you create a pipe using the CLI command, you can skip the second step, which is implementing the pipe transform interface. And here let me change the type to any instead of unknown. So we have completed the first two steps, that is creation and implementation. Now let's move forward to the third step, which involves adding our custom transformation logic. So first, let's see an example of formatting a mobile number. For that, inside built-in pipes.component.ts, I'll declare a variable named mobile number of type any equals to, I'll assign a 10-digit number. Now, in the HTML file, I'll create a field for mobile number. Here I'll take H6 and inside that I'll write mobile number colon. I'll bind the value of mobile number variable using string interpolation. So for now, I'll comment out this string type pipes as well as async type. And now I want to format this mobile number by adding +91 and a space before it. Since we don't have a built-in pipe in Angular for this functionality, but if we need this functionality in multiple components, then we can add the logic inside custom pipe and we need to write required logic. I'll use a ternary operator, value, question mark, and inside string, I'll add +91 and one space. After that, I'll concatenate the value, colon, value. So this version of pipe first checks if the input value is truthy, and if it is, the pipe appends the +91 along with space to it. Otherwise, if the input value is falsy, the pipe returns the original value unchanged. So with this, we have completed our third step as well. Now let's proceed to the fourth step, which is declaration. So in our built-in pipes.component.ts file, we need to add a custom pipe inside the imports array. And after this, the final step is to add our custom pipe in the component template file. And the syntax is similar to the built-in pipes. After the variable name, we need to add the pipe operator followed by the custom pipe name. And you can find the pipe name inside @pipe operator. So I'll copy this name and I'll paste it after the pipe operator. And with this, we have completed all 5 steps. Now let's check the output in the browser. Let me comment out this number type pipe as well. And now, as you can see here, inside the class file, we have assigned a mobile number without the +91 prefix. But in the browser, the same mobile number is displayed with the +91 prefix. If I change this number to 909090, then you can see the same mobile number displayed in the browser with +91 prefix. Okay. So with this, we have successfully created and used custom pipe in Angular application. Now let's add the next use case to the same example. Like if we receive a mobile number as undefined or an empty string or null from the backend API instead of actual mobile number. Then in this case, I wish to display an A instead of an empty space. If I save the changes, now you can see the empty space. So here, instead of empty space, I wish to display an A. And to achieve this, I'll add a if-else condition inside our custom pipe.ts file. So here, inside this transform method, I'll write if, and inside this if block, I'll check if the value is equals to an empty string, or if the value is equals to null, or if the value is equals to undefined. Then I'll return the string NA. And inside else block, I'll move this conditional operator statement. Now, as we have assigned a null value to this mobile number, so with this logic, we should see an A instead of an empty space. So let's check the result in the browser. And as expected, we can see an A in front of the mobile number. Okay. Now next, let's explore the another example of custom formatting, especially formatting a date. And we have already explored the built-in dates along with its argument, such as short, short date, short time, medium, medium date, and medium time. I'll comment out this. And inside the browser, we can see the output of all these date arguments. But I want to display this date in the month and year format, like this month/year. So let's achieve this quickly in the same pipe class. So I'll comment out this number format code for now. And to change the date format to month/year using the custom pipe in Angular, we can create a new instance of a date pipe with the locale set to en-us. So here I'll write private date pipe equals to new date pipe. And we need to import this date pipe from Angular/common package. And inside round bracket, I'll set EN means English and US means United States. And next, in the transform method, we will use the date pipe instance to transform the date to the desired format. And to do this, we will call the transform method dot transform. And inside this method, I'll pass value, comma, format. For month, I'll write 2 times M slash for year, I'll write 4 times Y. And we need to return this statement. So what we did, we have created a new instance of date pipe with the locale set to en-us. And the en-us parameter specifies the locale to use for formatting the date. Next, in the transform method, we used the date pipe instance to transform the date to the required format, where MM represents a 2-digit month and YYYY represents a 4-digit year. Now, to use this pipe in our Angular template, we need to provide a custom pipe name along with the pipe operator. We have already imported the custom pipe inside class file. Now, inside HTML file, I'll copy this line number 16 and paste it below the mobile number. And I'll replace this built-in pipe date with custom pipe name custom. I'll also change the pipe name to customized date format and replace this H4 with H6. Now save the changes and we can see the date in the customized format on the browser. 02 means February/2025. Also, we can display the date with the month name instead of the month number. So for that, we need to write M 3 times. Save the changes and you can see instead of 02, we can see the month name Feb. Similarly, we can print the date with dashes instead of slashes. And this time, I'll print the date in DDMMYY format. Save the changes and you can see the date. First 02 indicates date, second 02 indicates month, and 25 indicates year. So this is how we can create our own date format as needed. So just to recap, so far we have explored 3 use cases for custom pipes, such as first, formatting phone numbers, second, replacing the empty values, null values, or undefined values with NA, and third, customizing date formats. So I hope you now understood how to create custom pipes in Angular. And by default, all custom pipes in Angular are pure pipes. And to create an impure pipe, you need to explicitly set the pure property to false within the @input decorator. Here, pure colon false. Okay. So this is necessary to make a custom pipe to impure because the pure property is set to true by default when creating a custom pipe. So now let's understand the difference between pure and impure pipes. So in Angular, pipes are used to transform and format data for display in templates. And pipes can be classified into 2 categories, pure pipes and impure pipes. So pure pipes are only executed when the input value changes. For example, in our mobile number formatting pipe, the pipe will only be re-executed when the mobile number changes, which improves performance. This means pure pipes have no side effects and Angular caches the output of pure pipes, so they are only re-executed when the pipe changes. And on the other hand, impure pipes are executed on every change detection cycle, regardless of whether the input value has changed. They can have side effects and are not cached by Angular. We will understand this better with an example. Therefore, both built-in pipes and custom pipes can be either pure or impure depending on how they are implemented. Okay, so now let's see the example of both. And we have already seen an example of pure pipe with mobile number formatting. But still, I'll create another example for both pipes. So first, let me create 2 more separate pipes. ELS. One for a pure pipe using command ngGenerate pipe name pure, and another for an impure pipe using command ngGenerate pipe name impure. Now, first we will finish the pure pipe example and then we will move on to implementing an impure pipe. Let me close this custom pipe and let me open the purepipe.ts file. And this time we will see the example of square a number. So let's implement the logic inside the pure pipe to square a number. And to do this, we will simply multiply a number by itself. So instead of null, I'll write value into value. We'll just delete this array and save the changes. So this pipe takes a number as input, square it, and return the result. Now you can use this pure pipe in our Angular template with its respective pipe name by importing it into the imports array of the required component class file. So here I'll import pure pipe and then inside HTML file, I'll create one more H6 element and inside that I'll write pure pipe colon square of 5 is. After that I'll use string interpolation and here I'll pass value 5, then pipe operator and name of the pipe pure. And I'll comment out this date pipe. So this would output the square of 5 is 25 because 5 into 5 equals to 25. Okay. So this pipe is called as pure pipe because it only uses the input it receives and doesn't rely on anything else. It always gives the same result for the same input and doesn't cause any other effects. Like if I refresh the page, I am getting same output, that is square of 5 is 25. But if I change the input here, instead of 5, if I write 6, then in this case, I'll get different output. The square of 6 is 36. So it means with a pure pipe, the output will only update when the input changes. Otherwise, it remains unchanged. Now, let's understand the example of impure pipe. So let me open impurepipe.ts file. And the definition of impure pipe is they are executed on every change detection cycle, no matter whether the input arguments have changed. Since time changes every seconds, a time example provides a perfect demonstration of how an impure pipe works. So here I'll use toLocalTimeString method to display the current time. And for the current date, I'll use new date dot toLocalTimeString. Okay. So this statement will display the current time. And now to use this pipe in a template, we must import the impure pipe into the required component. So after this pure pipe, I'll import impure pipe. And then we can apply it simply by adding the pipe name. So here I'll write impure pipe. And inside the TS file, we have already created one variable for current date. So I'll use same variable and then pipe operator followed by pipe name impure. Okay. Now let's check in the browser. And here you can see the time in hour, minute and seconds. Now let's refresh the browser multiple times. And as you can see, the impure pipe's value changes with each page load, even though the input value remains unchanged. This is because as an impure pipe, it executes on every change detection cycle, updating the current time in real time. So with an impure pipe, the output can change even when the input doesn't change. And note that using this impure pipe repeatedly can have significant effects on performance. However, in this case, the performance impact is likely to be negligible as the pipe only returns a simple string value. But in general, using pure pipes can improve application performance, whereas using impure pipes may compromise performance. And in Angular, all the built-in pipes are pure pipes except for async pipe. The async pipe is an impure pipe because it can return different values over time, even if the input doesn't change. And this is because the async pipe is used to handle observables and promises, which can emit new values asynchronously. So with this, we have concluded our explanation of pipes in Angular. And I hope this Angular 19 tutorial has been a valuable resource in your ongoing learning journey. Now next, let's continue our journey by dividing into another fundamental building block of Angular called Angular Forms. So you might wonder, why do we need forms in Angular? After all, we have already created a login page without using forms. But as our applications grow and become more complex, Angular Forms provide a robust solution for managing user input, validating data, and handling multiple form fields. That is the reason the Angular team introduced forms. So, what are Angular Forms? Angular Forms is a module in the Angular framework that provides a way to handle user input and validate form data. And they offer a robust and scalable way to manage forms in Angular applications. And in which scenario do we need to use Angular Forms? First, complex form validations. Angular forms are idle when we have a complex form validations. As they provide a built-in validation system, this makes it easy to validate user input and display error messages. Second, large-scale applications. Angular forms are suitable for large-scale applications as they are designed to handle complex data-driven forms. Third, Angular forms are useful for dynamic form generation, allowing us to create forms based on user input or server-side data. And last, two-way data binding. Angular forms provide two-way data binding, which means that changes to the form data are automatically reflected in the component's properties. So by using Angular forms, we can enable users to perform various data entry tasks and streamline our development process to build more robust and user-friendly applications. And Angular provides two types to building forms. First is template-driven forms. These forms are created using HTML template and suitable for simple forms. So the template driven approach is great for simple forms. It's easy to use and we can create nice looking forms without writing any extra code. Second type of form is reactive forms. These forms are created programmatically using the form control and from group classes and are suitable for complex forms. And reactive forms are also called as model driven forms or model driven approach. In this reactive forms, the form logic is defined in the component as an object, and this form offers several benefits, including easier testing of the component. Now, let's understand what are the steps we need to follow while creating the template driven form. And the first step is import forms module. We need to import the forms module in our component, and this module provides the necessary directives for working with template driven forms. Second, we need to build our form using standard HTML form elements such as input field, checkboxes, buttons, etc. And third step is we need to convert our HTML form to a template driven form by adding the ngForm directive to the form element. And this directive creates a form group instance from the form. Fourth step is to use form control. Although not explicitly required, form control is a building block of Angular forms. It represents a single form field and can be used to track the field's value, validation status, and user interactions using the ngModel directive. And the last step is to submit the form. We can use the ngSubmit directive to handle form submission. And this directive calls the specified method when the form is submitted, allowing us to process the form data. So by following these 5 steps, we can create a fully functional template driven form in Angular. Now, let's start by exploring an example of template driven form and then we will move on to reactive forms. So I'll jump into the Visual Studio Code editor and we will continue from there. So here I have created a new component called template driven form using the CLI command. Then I have added a root for it in app.routes.ts file with the path TDF, hence template driven form. And also I have added the new nav link labeled TDF to the navbar. Now inside the browser, we can see the TDF link on the navbar. And on click of this link, we can see the template driven form component rendered on the web. Now, as per the first step to work with template driven forms, first we need to import the forms module in the imports array to enable the template driven form functionality. And if you are working on a module based Angular application, then the forms module is imported in the ng module of the app.module.ts file. Alternatively, if you are working on a standalone component, you need to import the forms module inside the imports array of the respective component class file. So since we are working on an Angular 19 application which uses standalone components, so I will import the forms module inside the imports array of the template driven form component. So this is our first step. Now next step is to create an HTML template for the form using standard HTML form elements. So here I would like to use a Bootstrap form field. So I will open Bootstrap site for Bootstrap form. In here, let me copy this first div and paste this div inside our HTML file. Before that, I'll take one container class and inside this div, I'll paste a Bootstrap form field. And now I'll remove an unnecessary code. Like I don't need this ID. and I don't need this small element. I'll edit this field with first name. And for first name, type must be text. And since we are building a form, I'll move this div inside form tag. We need to change the placeholder, enter first name. Now I'll duplicate this div 3 to 4 times and quickly update the field's name accordingly. The second div for last name and third div for email. For email, type should be email and the placeholder should be enter email address. And here I'll update password. And for this password, type should be password and placeholder should be enter password. I would like to add one checkbox in the same form. So here I'll change the class with form check and label should be check me out. And for checkbox, type must be checkbox. And I don't need placeholder for this field. And for this input, the class should be form check input. Control X, Control B. And at last, I'll add one submit button with class btn.btn success. The button name is submit. Now save the changes and have a look on the browser. Okay, let me add margin for all this field. Margin 2. Okay, now save the changes and here you can see we have created a simple form. Let me add one h2 tag with text user information. And I'll add the class send. So with this, we have completed the second step. Now, as per the third step, Angular automatically converts our form with form elements into a template driven form using the ngForm directive. And to access the ngForm properties and methods, we can export the ngForm instance to a local template reference variable using the syntax hash and local template variable name, let's say user form equals to ngForm. And this ngForm directive creates a form group, which is a collection of form controls. And by using the template variable user form, we can access various properties and methods of ngForm. So this was our third step. Now the fourth step is to bind the form controls. And one form control corresponds to one form field. So in our HTML template, we have 5 form fields like first name, last name, email, password, and checkbox with label check me out. And to connect these fields to our component, we need to add ngModel directive to each one. And also the ngModel directives uses the name attribute to establish this connection. Like here, if I use ngModel directive without the name attribute, you will see an error message. Here, if I save the changes, you can see if ngModel is used within the form tag, either the name attribute must be set or the form control must be defined as a standalone in ngModel option. So this indicates that it's mandatory to include the name attribute when using ngModel. So here, let me add a name attribute with value first name. Now you can see error has gone. Now I'll declare a variable with name first name. So here, first name of type string equals to empty string. And now I'll bind its value to the ngModel directive using the banana in a box syntax. ngModel equals to first name. And now I'll print this first name variable below this heading using string interpolation syntax. And in the browser, as I start typing first name, FED learning, you will see the same text updated here with the first name variable. Similarly, we can do the same with the second field, last name. So here I'll declare a new variable named last name and bind it with ngModel. Here I'll paste the same name attribute and ngModel. And here let me update last name. And now below this first field, I'll print the last name. Save the changes and let me type something. Okay, here the last name should be like this. Now, if I type something in the last name field, and as expected, this also works like first name. But imagine in the future, if we have 20 fields, then we would have to declare 20 variables inside .ts file. So to avoid overloading our component class file with all 20 variables, we can create a separate file to store these variables. And that file is called as model. And it is good practice to keep component class files organized and focused on component logic. So for large numbers of form fields, consider creating a separate model file to store variables, which can also be reused across multiple components if needed. And in Angular, models can be created using two approaches, class and interface. And we should create a class when we need to add methods or logic to our model. In contrast, we should use an interface when we only need to define a shape or structure of our data. And both classes and interfaces can be used to represent data models in Angular. And we can create class using the command ngGenerate class name and create an interface using command ngGenerate interface name. So let me create a model by running the command ngGenerate interface name, I for interface, and followed by interface name, user. Enter. And this will generate a new file called user.interface.ts in the current directory containing the basic structure of an interface like this. Export interface name user. And if you want to learn more about TypeScript interfaces, kindly check out my interface video from the TypeScript tutorial. Now, inside this user interface, we can declare the properties required for our form. So let's add the 5 properties corresponding to these 5 form fields, like first name of type string. And additionally, we can define extra properties as optional by using the question mark. By doing so, we allow the forms to have some or all of those optional properties, making the interface more flexible. Okay, so this is how I have added 5 properties for the 5 fields of user information form. So here we are exporting the user interface, which means it allows us to import and reuse it whenever we need this model in our application. Now, inside .ts file, instead of these two properties, let's declare a new object called user object and assign it the type user. And let's initialize it as an empty object to store the user information. And make sure we have to import the path of this user interface. Now we have all the properties of user interface in user object. So let's bind each property to user object in the template file using the ngModel directive. So here, instead of first name, now I'll bind this first name with user object dot first name because we have declared this property inside user interface. So similarly, I'll update the last name user object dot last name, and I'll copy this name attribute and ngModel, and I'll paste this for all 3 form fields. This is for email. The value of ngModel will be user object dot email. This name should be pass, and the ngModel value user object dot pass. And this is check user object dot check. Okay, so this is how I have binded all the properties of user interface using user object. But here, if you try to assign a value to a property that is not defined in the user interface, then TypeScript will raise an error. For example, Here I am trying to access the name property instead of first name. So this will result an error saying property name does not exist on type user. It means this name property does not exist on type user means inside user interface. Okay. So let me update this with first name. Okay. So with this, we have completed our fourth step. Now our template is ready except for the final piece. That is our fifth step, submitting data to the component. And for this, we need to use the ngSubmit event to submit the form data to the component class. Let's use the event binding to bind the ngSubmit event to the onSubmit method in the component class. So inside parentheses, we need to write ngSubmit equals to onSubmit. And we need to pass the local template variable user form to the onSubmit method. And this variable references the ngForm directive, allowing us to access and extract data from the form fields within our component class. Now, when the user click on the submit button, the ngSubmit event will be triggered. So the final step is to receive the form data in our component. And to do this, we will create an onSubmit method within our component class file. And this method receives the ngForm directive reference, which we have named user form of type ngForm. And to verify the submitted data, we can log the form's value to the console using console.log. So here I'll write user form.value. Now save the changes and open the browser and fill out the form. First name, I'll write FED, last name, learning, email, fedlearning24@gmail.com, and password 1234. And then I'll click on this checkbox. And now first let me open the developer console to see the output. And now I'll click on the submit button, and here we can see the field values inside console: email, first name, is check, last name, and password. So with this, we have successfully created a template driven form using all the 5 steps. And also we have received the form data in our component. So let's review all 5 steps quickly. In Angular template driven forms, first we have imported forms module into the imports array of the template driven form component. Second, we have created an HTML form. And third, Angular has detected the form tag and we have converted that form into the Angular forms using the ngForm directive. Fourth, we have added the ngModel directive with name attribute to each form element. And finally, we have bound the submit event via event binding. Okay. Now we have gained access to the ngForm instance through the local template variable user form, and we can leverage its various properties and methods to determine the current state of the form. For example, here I'll use pre-tag. Inside that, I'll write some properties or methods like value, and inside double curly brackets, I'll bind the value of user form. User form dot value, and here I'll use JSON pipe. In order to use JSON pipe, first we need to import it inside imports array JSON pipe. Similarly, I'll add few more properties here like valid, username dot valid. This is for invalid. And third is for touched. Fifth is for untouched. This is for submitted. So here I have added 6 properties that determine the current state of the form. Let's understand all these properties with output. Property first name does not exist. Okay. Let me delete these 2 lines and now save the changes. And here you can see the output of value property is empty object because we need to fill the values inside the form. So here let me fill FED. You can see inside value, we can see the first name property. Similarly, if I type last name, that is learning, the last name property is added inside this value object. Same for email, password, and checkbox. Okay, now you can see the value object with all 5 properties of user information form. Now let me refresh the page and let's understand the second property, that is valid. And this valid returns true if the form is valid, otherwise returns false. And in our current scenario, none of the form fields are marked as required. So as a result, the form is considered valid even when no fields are filled in. This means we can submit the form without entering any value. And if I mark any field as required, like here, if I add this first name field as required and save the changes, now you can see the valid property returns false. And once I fill the first name, then it becomes true because we have filled all mandatory fields. Now the form is valid and we can submit the form. Now let's understand the third property, that is invalid. And this property returns true if the form is invalid, otherwise return false. In this case, our form is invalid because this first name is required field. Once I fill this field, the invalid property becomes false. Here you can see. So hope you understand the difference between valid and invalid property. Next property is touched. This property returns true if the user has interacted or touched with at least one form field. So right now this is returning false, but once I touch to any field, it becomes true. Here you can see. Similarly, untouched returns true if the user has not interacted or untouched with any form fields. And if I touched or interact with any form field, it becomes false, like this. Now last property is submitted. It returns true if the form has been submitted, otherwise return false. If I fill the required field and click on submit button, it becomes true. Here you can see. Okay, so this is how we have understood various properties and methods to determine the current state of the form. Now, let me comment out these property and let's understand how to set the values in template-driven forms. Under this, we will learn how to set default or initial values to form controls. Also, we will understand how to set values dynamically, and after that, we will see how to reset form values. Okay. So there are two ways we can set the value of the form elements. First is two-way data binding and second is using template reference variable. And we have already explored setting values using two-way data binding with the ngModel directive. Now let's move on to the second approach, that is setting values using the template reference variable. So let's start using the initial or default value. And as we all know, once our component is initialized, the ngOnInit lifecycle hook will get called. So we can set the default value to the user object as per the user model in the ngOnInit method. So let me implement ngOnInit first, and then we need to define the ngOnInit method inside class. Now inside this ngOnInit method, I'll print the user object with initial value. So here inside this object, I'll pass the initial value to all these properties. First name Rahul, last name Verma, email rahul@gmail.com, password 12345, and it pick true. Now save the changes and let's have a look at the browser. And as you can see here, the form has rendered on the browser with default values. Okay, so this is how we can set initial or default value inside ngOnInit lifecycle hook. But we have a user form reference variable, which is an instance of a ngForm. So once we have the reference, we can use the set value method of the ngForm to set the initial value. And to do this, I'll first create a new button in the HTML file with name set value. Warning. And here I'll add a click event and I'll assign a function called set values and pass the user form reference variable. And now I'll define the same function inside the DS file Here also I'll pass user form of type ngForm. And inside this set values method, we will declare a new object using let keyword. Let obj equals to, I'll assign the same values inside this obj object. And for now, let's comment out this user object in the ngOnInit method. And next, we will pass this new obj object to the set value method. Like here, user form dot set value, and inside round bracket, I'll pass the obj object. Now save the changes and let's refresh the browser. Okay, user form does not exist. User form. Okay, here let me correct the spelling. User form, and here we should be capital. Set values, and now save the changes and let's refresh the page. And here you can see the form is empty because we have commented out the code in the ngOnInit method. And to set the form values dynamically, we need to click the set values button, and now we can see the form with values. Let me refresh the page again, and again I'll click on set values button, and as expected we can see the form values. Okay, so this is how we have successfully set the values individually using the set value methods of each form control. But what if we want to set only these 3 properties instead of all 5 properties? Like here, if I comment out these 2 properties from this object, and now let me open developer tool again, clear the console, and once I click on this set value button, it will throw an error saying must supply a value of form field with name pass. And if I uncomment this pass, we can see the same message for each check property like this. Okay, which means that with the set value method, we must set all properties even if we don't need them. And to set only the required properties, we can use the patch value method. So let's try this out quickly. For patch value, I'll create another button named patch value with corresponding method called patch value. And I'll change the button color to primary. Next, I'll define this patch value method inside PS file. Below this, I'll pass same user form of type ngForm. And inside this patch value method, I'll copy paste the same object, but this time I'll not set the last 2 properties. Here I'll uncomment this eCheck property, and inside this patch value property, now we have set only 3 properties: first name, last name, and email property. Now here, after this object, I'll use the control property of ngForm, which returns a reference to the top level form group. And then I'll utilize the patch value method to update only the first name, last name, and value field. Inside this patch value, I'll write obj. Now let's check the result in the browser. If I click on set values button, it sets all form fields value. Now I'll refresh the page, and this time I'll click on patch values button. And as you can see, it sets only the required fields value, that is first name, last name, and email. And the password field is empty and checkbox is unchecked because we have set only 3 properties inside this patch value method. So this method demonstrates how to use the patch value method to update only a few fields at any time. So what is the key difference between the set value and patch value methods? The set value method sets a new value of an individual control, and it's strictly following the form group structure and replacing the entire control value. In contrast, the patch value method replaces only the properties defined in the object that have changed in the form model, allowing for more targeted updates. Now last, let's understand how to reset the form to its initial empty state using the reset or reset form method of the ngForm. So let's create a new button for reset with corresponding function name reset value. And I'll change the button class to secondary. Now next, let's define the reset values function inside the class file with user form of type ngForm. Now inside this reset values function, we can use either the reset method or we can use reset form method to reset the form. Let me comment out one method and let's test in the browser. First, let's populate the form field values by clicking either the set values or patch values button, and then we can reset the form. So let me click on set values, and then to reset the form, we can simply click the reset button. Here we can see our form is empty. Now let's comment out this reset method and uncomment this reset form method. And this time I'll populate the form fields value using patch value button, and then in order to reset the form, I'll click on reset button. Okay, so it means with the help of these two methods, we can reset the entire form. And these two methods not only clear the form's value, but also reset the form status, including its dirty, valid, cached states. Okay, so far we have explored how to create template driven form. Then we have seen how to set the default values using set value and patch value methods. And last, we have seen how to reset the entire form. Now we will take our existing template driven form to the next level by adding validations. So there are 5 built-in validators in template driven forms. First is required. It ensures the form control has a value, and if the control is empty, the form will be invalid. Next is min length. It ensures the form control value meets the minimum length, and if the value is shorter than the specified length, then the form will be considered invalid. On the other hand, we have the max length validator. This validator ensures the form control value does not exceed the maximum length, and if the value is longer than the specified length, the form will be invalid. Next built-in validator is pattern. It ensures the form control value matches a specified pattern, and the pattern is defined using a regular expression. If the value does not match the pattern, the form will be considered invalid. And the last validator is email. It ensures the form control value is a valid email address, and if the value is not a valid email address, the form will be invalid. So these built-in validators greatly simplify the process of form validation in template-driven forms. Now, let's open Visual Studio Code Editor and see how it works in practice. But before we dive deeper into built-in validators, let's check the form status by printing the valid property, like userForm.valid. Now open the browser and let me navigate to template-driven form component. And here you can see, as a result, the valid property returns false, indicating that the form is invalid due to the required first name field not being filled. Here you can see we have marked required for this first name field. So ideally, the form should not be submitted in an invalid state. However, let me open developer tool, and once I click on this submit button, I am getting the values of our user form. It means I can still submit the form even though it's invalid. And this nullifies the purpose of having validators if required fields can be bypassed. So in this scenario, what we need to do is disable this submit button if our form is not valid, so that the user cannot click on the submit button until they have filled in all the required fields, right? So let's do this now. And we know that the form group has valid and invalid properties. The valid property returns true if the form is valid, whereas the invalid property returns true if the form is invalid. So let's use this property to set the disabled attribute of the submit button. And to do this, we have to write disabled attribute property binding equals to, here we can either use not operator with the valid property like userForm.valid, or we can directly use the invalid property without not operator, like this. Both approaches achieve the same result. Let me comment out this line number 33 and save the changes. Go back to browser And as you can see here, the submit button is disabled. This is because the user form is invalid due to the required first name field being empty. Now keep an eye on the submit button. As soon as I fill in the required first name field, the submit button becomes active. Here you can see. And if I reset the first name field, the submit button is disabled again. And refilling the required value re-enables the submit button. So this confirms that our disable submit button functionality is working as expected. Now let's start working with built-in validators. And as discussed earlier, the first built-in validator is required validator. This validator returns true only if the form control has a non-empty value. So let's add this validator to first three fields. And to use this validator, simply add the required attribute to the form control, which refers to the form field value. So here we have already added a required attribute to the first name field. Similarly, we will add it to the next two fields for last name and email. Okay. And I'll comment out the set values and reset buttons for now, but I'll keep patch values button enabled because as we implemented earlier, clicking this button will populate the three fields like first name, last name, and email. So this allows me to bypass manual entries for these three required fields and I can easily test the form's validation. So now let's observe the submit button's behavior. Initially it's disabled, but as soon as all required fields are filled, the submit buttons becomes enabled. So let me click on this patch value button and as you can see, the submit button becomes enabled and this is the expected behavior for any form. So let's do this one more time. I'll refresh the page and this time manually enter the values. Here, let me fill first name and as you can see, filling in just a first name field doesn't enable the submit button because we have marked three fields as required and the submit button is enabled only after all three required fields are filled. So let me fill remaining two fields as well. And now that all three fields are filled, and here you can see the valid property becomes true and that is why the submit button is enabled. Okay, so this illustrates how the required validator works, ensuring that user provide essential information before submitting the form. Now let's move forward with the second validator, which is mean length. And the mean length validator specifies a minimum character requirement for a form controls value. And to use this, we simply add the mean length attribute to the input field and assign it a numeric value. For example, I'll assign 5. So this ensures that the input fields such as first name field must contain at least the specified number of characters. So in this case, 5 characters. If the changes, and let's click the patch value button to populate the required fields. And next I'll update the first name field and notice the submit button. When I enter the name like Bob, which contains only 3 characters, the submit button remains disabled. Also, you can see this valid property returns false due to the mean length validator, which requires at least 5 characters in this field. But as soon as I enter 5 or more characters, the form becomes valid and the submit button is enabled. So the mean length validator verifies that the length of the input value is at least the specified minimum number of characters and blocking form submission until this requirement is satisfied. Now let's use the max length validator, which works exactly opposite to this mean length validator, which means that with the max length validator, the input value does not exceed a specified maximum number of characters as defined in the attributes value. So I will apply the max length validator to the second field, that is last name, and the syntax is similar to mean length. Simply add the max length attribute and assign it a numeric value. I'll assign same value 5. Now again let's populate the first three fields by clicking the patch value button. And in the second field, if I try to enter more than 5 fields like X, Y, Z or anything, the max length validator will prevent me from doing so. In the second field, I cannot enter more than 5 characters. So this demonstrates the key difference between mean length and max length validators. Mean length needs at least 5 characters, while max length allows only 5 characters or less. Now let's understand the fourth type of validator, which is pattern. This pattern validator requires that the control value must match the regex pattern provided in the attribute. For example, in this second field, let me increase the max length to 15 and the pattern is up arrow and inside square bracket small a to z and capital A to capital Z plus dollar symbol. So this pattern ensures that the only letters are allowed, even spaces are not allowed. So let's test this in browser. Let me click on batch value button to fill first three required fields. And in the second field, if I enter any text less than 15 character, the form is valid. However, if I enter or type numbers like 1, 2, 3, 4, or if I add a space or special character like hash, dollar, at the rate, etc., the form becomes invalid due to the pattern validator, as well as our submit button is also disabled. It means we can enter only letters like from A to Z. Okay. So this is how we can utilize pattern validator to add a specific pattern, thus restricting user inputs and preventing form submission. So we have seen required validator, mean length, max length, and pattern validator. Now, last validator is email validator. I'll apply this to email field. And this email validator checks that the entered value is valid email address and it is typically used for email fields. Let's first test the email field without the email validator. If I remove this at the rate from this email address, as you can see, I can submit the form even if I enter an email ID without the at the rate symbol because our form is still valid. But adding the email validator, let me save these changes. Email validator restricts form submission. Now, if I remove the at the rate symbol from and same email address, the submit button becomes disabled. If I try to enter the email address here, abc@gmail.com. So as you can see here, it only becomes enable when I enter a valid email format, such as any name at the rate and then gmail.com or any other correct format. It means this email validator ensures that user enter a valid and properly formatted email address, preventing incorrect or invalid email submissions. Okay. So in this way, Angular built-in form validators can be utilized. But as a developer, we are aware of the validators applied to each field. However, from the user's point of view, it's essential to display short or meaningful error messages that guide them in understanding and correcting their mistakes. So now let's understand how to add effective error messages. And as we know, Angular automatically creates a form control instance for each form field that has the ngModel directive applied. And we have already accessed properties such as value, valid, invalid, touched, and more of the user form using the template reference variable. In the same way, we can access the same properties of the form control by creating a new local variable for each form control. So let's get access to the form control instance by assigning the ngModel to a local variable. And the syntax is hash local variable name. For first name, I'll use fname variable equals to ngModel. This is how we can create a local variable for this form control. And by doing this, the variable fname holds a reference to the first name form control. Let's access the properties of form control. Let me copy the first four properties from here. I'll paste this below the first name field. Let me comment out this line number 3. And let me update this user form with fname. I don't need this JSON. Let me delete this JSON from imports array as well. And now, when I enter a value in the first name field, you just observe how the properties change. Yeah. The value property returns the entered value. The valid property returns true. The invalid property returns false. And the touched property returns true. So with the help of local variable of this form control, we can access these properties. value valid, invalid, and touched. And this indicates that we have successfully gained access to the first name field properties, allowing us to track its state in real time. Now, let's make use of these properties to display the respective error messages. For that, we need to write the if condition. And you can use either the *ngIf directive by importing the common module in the imports array, or you can use built-in control flow syntax using @if block. Since I'm working on an Angular 19 application, I'll use the @if block syntax. And for this, I don't need to import any module in the imports array. So for this form control, we have added two built-in validators, mean length and required. So I wish to render two different messages conditionally. So I'll write the if syntax with the condition fname question mark dot errors question mark dot required. And we need to wrap this required inside square bracket in single quotes. Okay, so this first name refers to the form control instance for the first name field. After that, I have added question mark dot errors for safely navigates to the errors property, avoiding null or undefined errors. And then I have written question mark dot required. This checks if the errors object has a required property. And if this condition is met, I'll display a short error message. So for this, I'll use small tag with class text danger to show the error message in red. And the error message is first name is required. Okay. So similarly, I'll add another condition for mean length. So here I'll replace this required with mean length, and the message for mean length is the minimum length of the first name should be 5. Okay, save the changes and let's test these messages in the browser. And on page load, the message first name is required is displayed. However, as soon as I start typing, the error message changes to the minimum length of the first name should be 5. And once I meet the minimum length requirement, no error message is displayed because the field becomes valid. So this indicates that on page load, the required validator is triggered, and once I start typing, the mean length validator is triggered. But we don't want the application to display errors when the form first loads. Instead, error should only appear after the user interacts with the field. And that is where the dirty and touched property come into play. A form control is considered dirty when the user manually changes its value, whereas a form control is considered touched when the user clicks or away from it. So let's try these two properties as well. So before this first if condition, let me add one more if block with condition fname.dirty or fname.touched. And now I'll move these two if block inside this if block. Okay. Now let's retest the functionality. And this time, no error message is displayed on page load. But when I touch the first name and leave the field empty, the required validator is triggered with message first name is required. And when I enter less than 5 characters, the mean length validator is triggered with message the minimum length of the first name should be 5. And when I enter 5 or more than 5 characters, no error message is displayed because this time our field becomes valid. Okay, so similarly, let's add error messages for the remaining two fields. Now I'll comment out these properties. And for last name field, let's create a local template variable hash lname equals to ngModel. After that, I'll copy the same if block structure from here and I'll paste it below this last name input field. Now I'll update the local variable with fname and also make sure to update the error message to reference last name. So this is for last name, and for this last name field, I'll add error message to the pattern validator. The error message for pattern validator is last name does not match the required pattern. Okay, so this is for second field, that is last name. Also, I'll add the similar error message to the third field, that is email. So here, let me create local variable with hash symbol email ID equals to ngModel. And let me update this L name with email ID. One error message for required. Email address is required. And second error message for email validator. And the message for email validator is please enter a valid email address. Now save the changes and let's test the forms validation. Now when I focus on a field and then click away without entering any text, as you can see, the required validator is triggered and displaying the respective error message. And for the first name field, entering less than 5 characters triggers the min length validator and showing an respective error message. Next, the last name field has a pattern validator, and when I try to enter numbers or special characters, I receive the error message last name does not match the required pattern. It means the pattern validator is triggered. Okay. Similarly, email field has an email validator. If I enter an invalid email address, I get the error message, please enter a valid email address due to email validator is triggered. So let me type the proper email address, and with this, our form becomes valid, and now we can submit the form. Okay. So with this, we have learned how to display error messages using built-in validators in Angular forms. Now last, let's understand how to disable all the browser's built-in form validation. And we can disable the browser validation by adding the no validate attribute on the form element. Like in HTML, the no validate attribute is used to disable the browser's built-in form validation. So when this attribute is added to a form element, the browser will not perform any validation on the form fields, even if they have attributes like required, min length, max length, pattern, etc. So if the no validation attribute is used to disable the browser's built-in form validation, then why would we want to do that? Actually, this attribute is useful in specific scenarios such as custom validation. When we want to perform custom validation on the form fields using JavaScript, we can use the no validate attribute to disable the browser's built-in validation. Second, no validate attribute useful for server-side validation. In some cases, we may prefer server-side validation over client-side validation. So by adding the no validate attribute, we can bypass the browser's built-in validation and rely exclusively on server-side validation. So this approach is particularly useful for complex validation rules or when integrating with existing server-side validation frameworks. And third scenario is progressive enhancement. If older browsers doesn't support HTML5 form validation and we are still using HTML5 validation attributes without no validate, it can prevent form submission. So in this case, adding the no validate attribute can help by disabling HTML5 validation and allowing the form to submit. So the disabling browser validations can be bad for users because they won't get instant feedback when they fill out a form incorrectly. So only use the no validate attribute when it's really necessary. Now, moving on from the practical implementation, and let's discuss the advantages of template-driven forms. Template-driven forms offer several advantages, including easy to use. Template-driven forms require minimal setup and configuration, making them user-friendly to work with. Second advantage is rapid prototyping. Template-driven forms enable quick creation and testing of forms, accelerating the development process. Next advantage is simple validation. It provides straightforward validation using HTML5 attributes, simplifying error handling. Next, less code required. It minimizes the need for extensive coding, reducing development time and effort. Next advantage is easy data binding. Template-driven forms simplify data binding, automatically connecting from controls to data models. And last advantage is fast development. Template-driven forms streamline the development process, enabling developers to quickly bind and develop forms. So these advantages make template-driven forms a popular choice for building simple to medium complexity form in Angular application. Now, on the other hand, template-driven forms also have some drawbacks, including limited control, restricts ability to customize form behavior. Next, difficult debugging makes it hard to identify and fix form-related issues. Next, limited reusability. Form components are not easily reusable across applications. Next, tight coupling. Form logic is tightly coupled with template, making changes difficult. Next disadvantage is not suitable for complex forms. Struggles to handle complex form logic and validation. And last disadvantage is limited unit testing capability. Makes it challenging to write unit tests for form related code. So these disadvantages highlight the limitations of template driven forms, particularly when dealing with complex forms or applications that require more control and flexibility. So the conclusion is that template driven forms are a convenient and easy to use way to handle user input and validate form data in Angular. However, they may not be suitable for complex forms that requires more control over form validation and submission. And for complex form, we can use reactive forms. So let's move on to reactive forms, which offer more control and flexibility. So what are reactive forms? Reactive forms are forms where you set up the structure and rules in your components code. You create a blueprint of your form using form groups, form controls, and form arrays, and then connect it to the form in your HTML template. So let's start by understanding the required step to create a reactive form in Angular. To use reactive forms in Angular, first we need to import the reactive forms module, and this module provides all the necessary directives and constructs for building reactive forms in Angular. Second step is to create a form group instance, which can be done using either the form builder or the form group constructor. Third step is to create a form template in your component HTML file and map the form group instance to the form using the form group directive. Next step is to add form controls to your template form fields using the form control name directive. And the last step is to handle the form submission event and perform any necessary actions such as validating the form data or sending it to a server. So by following these 5 steps, we will create a reactive form similar to a template driven form. But before this, let's understand the building blocks of reactive forms. In the reactive forms approach, we need to build a form model using 3 essential components: form group, form control, and form array. And these 3 components are the building blocks of the Angular forms. A form control represents a single form control, such as an input field, checkbox, etc., and it tracks the value, validity, and dirty state of the control. Second, form group is a container for multiple form controls, and it provides a way to manage multiple form controls as a single unit. And third building block is form array. It is a container for multiple form controls or form groups, and it provides a way to manage multiple form controls or groups as a single unit. In addition to form controls, form groups, and form arrays, there are another important concept in reactive forms called form builder. It is a useful service, makes it easier to create form controls, form groups, and form arrays. But the form builder is not considered one of the fundamental building blocks of reactive forms. So now let's put all these concepts into practice and build a reactive form. So I will switch to the Visual Studio Code editor, and here, to save time, I have created a new component for the reactive form and added a new route for it. And also I included it in the navbar list. Here you can see reactive form with path ref. So now you can access the reactive forms directly from the navbar. So let me open the reactive form component to create a reactive form. And as per the first step, to start working with reactive forms, we need to import the reactive forms module, which is imported from Angular/forms module. And if you are working on a standalone component, add reactive forms module in the imports array of the same component like this. Otherwise, you need to import it in the root module or a shared module if you are working on module based application. Since we are working on a standalone component, I have imported it in the imports array. Now let's move on to the second step, creating a form group instance. In the template driven form, the forms module automatically creates form group and form control instances from the HTML template using the ngModel directive. In contrast, reactive forms require us to manually build the form model using form group, form control, and form array. And in the template driven form, most of the code is written in the template file, whereas in reactive forms, we write the code in the class file. So first, I'll create a variable called reactive form of type form group. And now let's create a new form group instance which represents the entire form. So inside constructor, I'll write this dot reactive form equals to new form group. Now let's add form control instances inside the form group. And each form field needs its own form control. For example, I'll create a text input for a first name in template file and pair it with a form control instance, which I will name first name, colon, new form control. And I'll give it an initial value of an empty string. So with the help of new form group, we have created the instance of reactive form. And with the help of new form control, we have created the instance of first name field. Now similarly, I'll create form control instances for the other fields such as last name, email, password, and eCheck. Password is of type number, so I'll remove the double quotes. And eCheck is a type of boolean, so I'll remove this double quotes as well. Okay. So now each of these fields will have its own form control instance, and it allows us to track their values and validity separately. Now let's move on to the third step, creating a form template and mapping the form instance to the form group. So I'll go inside HTML file now, and to create form template, I'll copy the code from the template driven form component.html file and paste it into the reactive form component.html file. And I'll remove the unnecessary code related to the template driven form and convert this form to the basic HTML form. I'll add reactive form to the heading for clarity. And since we are working on reactive forms, we don't need the ng module or name attribute. So I'll remove those code from all the fields along with the built-in validators and error messages. Okay, so I have now converted this template driven form into the normal HTML form. And as per our third step, we need to map it to the form group. And in template driven forms, we used the hash symbol to create a template reference variable and link it to the ngForm directive. However, in the reactive forms, we need to bind the newly created form to this HTML form tag. And to do this, we will use the form group directive in square brackets and assign it to the form name. What is our form name? Our form name is reactive form. So this code will connect our form template to the form group instance, which we have created few minutes before. Okay. So this was our third step, creating a form template and mapping the form instance to the form group. Now moving on to the next step, that is adding form controls to our template form fields. Since each form field corresponds to one form control, so we will bind these instances using the form control name attribute in each respective field. On the other hand, in template driven forms, where we use ngModel directive along with name attribute to bind form field values. But in reactive form, we only need to use the form control name attribute. So let's add form control name attribute to all fields. And the value of form control name attribute should be matched with this form control instance. Now I'll copy this form control name attribute from here and quickly I'll paste it for rest of the fields. This is for last name, here for email, this form control name for password, and here for e-checked. Okay, now with this, we have completed the fourth step as well. Now the final step is form submission. So we need to call the onSubmit function. And to call the onSubmit function, we have two options. Here we have already created a submit button, and if the type of submit button is submit, so in this case we can use the ngSubmit directive in the form element. So here inside round bracket I'll write ngSubmit equals to onSubmit. So either I can call onSubmit method like this using ngSubmit directive, or we can call the onSubmit method with the click event in the submit button like this. Okay, so I'll go with ngSubmit directive. Now next, let's define the onSubmit method inside the class file. And this method return an object with a value property. So inside console.log, I'll write reactive form.value. Okay, so with this, we have completed all 5 steps of the reactive form. Now let's go ahead and print out all the form values to the console. So let me open developer tool and let me enter some values into all the fields. First name, let's see Poonam, last name Patel, email poonam@gmail.com, password 12345, and I'll select this checkbox. Now, when I submit the form, I'll receive an object containing all the form fields with their entered values. Okay, so everything is working as expected till now. Now, we have our top level form group, that is reactive form, but we can also create nested form groups if needed. For example, we can create a separate form group for the address similar to our reactive form. So inside this reactive form, I'll create an address form group, address colon new form group. And inside this, I'll declare address related form controls such as city colon new form control, and I'll pass empty string. Similarly, I'll add two more fields. Second is for street and third is for pin code. And I'll remove this double quotes for pin code. Okay. Now our form model has two form groups. The top level form group named reactive form and a nested form group named address. And we have already used the form group and form control name attributes to connect our top level form group, that is reactive form, to the template. Now, to link this nested form group to the template, we will add a form group name directive to the template. So after this check me out, let me take one more div, and here I'll write the attribute form group name equals to address. So this is our nested form group name. And we have linked this nested form group with template with the help of form group name attribute. I'll add class margin 2 for this div as well. And inside this div, I'll add an h5 tag with margin 2 class for address. And after this h5, I'll add 3 new fields. So I'll copy this div and paste it 3 times. And let me edit the label. This is for city, this div for street, and this div for pin code. And placeholder will be enter city name, enter street name, and enter pin code. And last, I'll bind these fields to their respective form control names. So for city, we need to bind form control name with city. For street, so street, and for pin code, I need to write pin code. And this form control name should be matched with this form control instances. Okay, so now let's print the value of address form group. Let me enter the city name, Mumbai, street name, Journey Road, and pin code 12345. And once I click on submit button, here you can see we are getting a separate object for address containing all the address related fields like city, pin code, and street. Okay, so we are able to print the value of nested form group as well. Now next, similar to what we did in template driven forms, let's disable this submit button if the form is invalid. And to disable the submit button, we can use either the valid property with not operator or the invalid property of the form. So let's use property binding to disable the submit button. I'll wrap the disabled attribute in square brackets and set its value to reactive form.invalid. And this will disable the submit button if the form is invalid. And to test this, we will make the form invalid by marking a field as required. So for first name, I'll add required. Now let's check in the browser. And as expected, when the page loads, the submit button is disabled because the first name field is required. But as soon as I type something into the first name field, the submit button becomes enabled. If I remove the value from first name, it becomes disabled. And if I enter any value to this required field, the submit button becomes enabled. So this behavior is same as in template driven forms. Okay. Now let's see how to set default values in reactive forms. In template driven forms, we used the set value and patch value methods to set the default values. And we will use the same methods to fill reactive form controls. And we can set default values in two ways, either by setting the value while adding form controls inside the form groups. Like this, we can pass the default values, or by using the set value and patch value methods. So let's try using the set value method first. And I repeat, we use set value method when we want to update all form fields. So when using set value method, we need to provide values for all controls, which means we can't use it for the partial date. Okay. So I'll copy the buttons from template driven form and paste it inside the reactive forms. Here I'll comment out these two buttons and let's work on set value button. And this time I'll add the button name set all values with a click event that calls the set all values function without parameter. Then in our TypeScript file, I'll define the set all values function, which will call the set value method on our reactive form. So here this dot reactive form dot set value, and inside this method I'll create an object with key value pairs for all fields, where the keys are the form control names like first name, and the values are set according to our requirement. So I'll set Poonam for first name. Next for last name, I'll set Patel. Next is email, poonam@gmail.com. Next password, I'll set 123. Next is check, I'll set true. After this, I need to set the values for nested form group as well. So we need to write the nested form group name, that is address, colon, inside curly brackets. Again, we need to pass the address related form fields value. So city, I'll set Mumbai. Street, I'll set Journey Road. And last pin code. 1, 2, 3, 4. So this is how we need to set the all fields value in order to use this set value method. Now save the changes and let's click on the set all values button. Must supply the value for form control name with each check. Okay, each checked. Here C should be in caps. Okay, because while creating the form group instance, I have written C in caps. Okay, now let me click on set all values. And as you can see, the form fields populated with the provided values. And in order to reset the form, we can use reset method. And to do this, I'll add one more button inside the template file called reset. And when this reset button click, it will call a function named reset form. Next, we need to define this reset form inside TS file. And this method simply calls the reset method. So here I'll call reactive form dot reset. That's it. Now let's populate the form fields by clicking the set all values button and then reset the form using the reset button. Okay. Now let's try using the patch value method. And when to use patch value method? When we only want to update some of the form controls, not all of them. So this patch value method allows us to fill in partial controls of the form. Okay. And to demonstrate this, let me uncomment this patch value button and update this with set partial values. And I'll edit the function name with set partial value. And I'll not pass any parameter to this function. Okay. So let's define this function inside the TS file. And this method calls the patch value method on our reactive form. So let's call the reactive form dot patch value. And inside this patch value, I'll paste this same address object with key value pairs of the required fields. So with this patch value method, we can set the required fields. We don't need to set the value for all the fields. Okay, so in this case, I want to set the address related fields only. So now when I click on the set partial button, only the address fields are populated. And when I click the set all values button, all fields are populated. So it means we have two options to populate form controls. We can use set value method to fill all controls at once. Or we can use patch value method to fill only some of the controls. And we can also update or reset a single form control value using the syntax reactive form dot controls. And here we can access the specific form control using the controls property. And we can add control name in square brackets like first name. And then we can use the patch value method to update the controls value. So inside patch value, we need to set the value. Here I'll set Poonam, semicolon. So I'll just comment out this code for now. And let's reset the same field on click of reset button. So I'll comment out this line number 59. And here, instead of patch value, I'll call reset method. That's it. Now here, by using this controls property, on click of set partial values, we are setting the first name field value to Poonam. And on click of reset button, we will reset the first name field. So let's test this on the browser. When I click on the set partial values, as you can see, only the first name field is populated. And to populate all fields, I click on the set all values button. And finally, when I click on the reset button, only the first name field is reset. Here you can see because of this line number 60. So we can use this syntax to update a single form control value when needed. And on the other hand, use this syntax to update multiple form control values at once, especially when dealing with nested form groups like this address group. So this is useful when updating a group of related fields. Now last, we can disable a reactive form field by using the disable property. So let's try this out. For example, if I want to disable a checkbox field, I'll call the disable property. Like here reactive form dot controls Inside square bracket, I'll pass the control name, that is eCheck.disable, and round brackets. That's it. Now let's check the result in the browser. And here you can see I cannot click on this checkbox because it is disabled. Let me set the default value to true. And now you can see the checkbox is disabled and I cannot uncheck or check it. So in reactive forms, we can enable or disable properties as needed. Just like the disable property, we can use the enable property to enable a field. So far we have covered how to create the reactive form. After that, we have explored how to set default values using set value and patch value methods. And we have explored two building blocks of Angular forms, that is form group and form control. And now we will learn about form builder, and also we are going to dive into third fundamental building blocks of Angular form, that is form array, including how to add validations. So let's start with form builder. So building multiple forms with form group and form control can be lengthy and time consuming. As you can see here, creating each form field requires repeating the same code. Fortunately, Angular offers a solution called Form Builder. The Form Builder is a service that simplifies the process and making it easier to create instances of form control, form group, and form array with less code. And we need to follow only two steps to use Form Builder. First is inject the form builder service into your component constructor. So here, let me inject it with private fb form builder. And it is imported from Angular/forms module. So this is the first step to use form builder. Now second step is use form builder to generate our form controls. So now we need to refactor this reactive form to use form builder service, such as instead of creating a new form group, I'll use form builder.group. So this .fb.group. And inside this reactive form, for each form control, we need to pass an array with an initial value, which can be empty or a default value. So let me paste this array to all form controls. Here we are getting an error because here also we need to use form builder instead of form group. So this .fb.group. Now save the changes. And as you can see, the code is now more concise and less repetitive. But either way, whether using form builder or form group, the template code remains the same. So it means we can switch to form builder without making any changes to our template. Okay, so hope you understand the use of form builder. Now let's move forward and learn about the third building block of Angular forms called form array. And form array is the extension of form group and form control, and it helps us to handle dynamic form controls. So when do we use form array? Form array becomes essential when dealing with forms that have a changing number of form controls or form fields. For example, we are creating a form where users can add or remove their skills. But one user might have two skills while other has five. So this kind of situation, we should use form array. So the key difference between form group and form array is that form group is a collection of form fields, while form array allows us to add or remove fields dynamically. So to understand more, let's create a simple example of form array where users can add or remove skills. So first, let's add a skill array similar to the nested form group for address. But this time we will use form array instead of form group. So let's write skills colon this dot fb dot. So for form array, here we need to write array. And this initialize the form array with an empty array. That's it. This is our normal form group. And this is our nested form group. And these are our form controls. And this is our form array. Now, to access this skills form array, we need to create a getter method. And we can define the getter method using the get keyword. So get followed by the getter method name. let's say skills, and which is of type form array. And in this method, we should return the skills form array from the reactive form. So I'll write return this dot reactive form dot get, inside round bracket I'll write skills as form array. So this as form array informs TypeScript that the returned value should be treated as a form array. Okay. Now next step is we have to define the structure of our form array. And to do this, I'll create another method called new skills, and this method returns a form group containing a single form control named skill with an initial value of an empty string. So here, instead of creating a form control directly, I'll use a form builder to create a form group. So before this skill, I'll return this dot fb dot group to this skill inside this form builder dot group. So now this method will generate a new form group instance representing a single skill. However, we can add here as many form controls as needed. Like we can add experience, project, etc. But I'll go with only skill. Okay. So inside TS file, we have created a form array. After that, we have created a getter method, and then we have created a new form group instance. Now, inside template file, after this check me out, I'll create a div with class form group and margin 2. And to map the nested form group with template, we used the form group name attribute. Similarly, to map the form array with the template, we use the form array name attribute equals to skills. Now next, I'll create a button.btn.btn primary, and button name is add skill. And on click of this button, it will call the add skill method. So let's define the same method in the TS file. And this method adds the new skill to the skills form array. So I'll write this dot skills dot push, and inside round bracket I'll write this dot new skill. So this creates a new form group instance using the new skill method and pushes it into the form array using the push method. Now inside template file, I'll use the ngFor directive to iterate over the controls in the skills form array. So here inside div, let me use star ngFor equals to let skill of skills dot controls, and I'll declare an index using let I equals to index, which assigns a current index to a variable I. And inside this loop, I'll add one more div for each skill. So I'll bind this div to the form group at the current index I. So I'll use the form group name directive inside square bracket equals to I. And now I'll display the skill number starting from 1. So inside double curly brackets, I'll write I plus 1 because index starts from 0. And then I'll write text skill name, and after that input text field for the skill name. And to bind the input field to the skill form control, I'll use form control name attribute equals to skill. And last I'll create one more button, delete. And this button called the delete skill method. Click equals to delete skill to delete the skill at the current index I. So now let's define the same method inside TS file, delete skill, and it takes one parameter I of type number, which represents the index of the skill to be deleted. So inside this method, we will use the remove at method to remove or delete form group instance at the specified index I. Okay. So far we have added two buttons, add skill and delete button, which triggers the add skill and delete skill functions respectively. And when we click on add skill button, a text input field appears to enter a skill. And when we click delete button, the corresponding skill and input box disappear. So let's observe the browser's behavior. And I'll click on add skill button. We are getting an error. Can't bind ngFor. Okay. In order to use ngFor directive, we need to import the common module or the ngFor inside the imports array. So let me import common module. And now let me click on add skill button. And this time, as expected, an input field appears and it allowing me to enter my skill. And when I click the delete button, the skill and the input box disappear. So this is how we can add multiple skills. So let me add few more skills and I'll submit the form. Angular, then React, then third skill I'll add Java. And now submit button is disabled because of the first name field is required. So let me type Poonam and click on the submit button. After submitting the form, if we open the developer tools, I'll clear the console and let me click on submit button again. And here we can see the skill array with skills Angular, React and Java. And if I delete any skill, the updated array is reflected in the console. Here you can see. Now we are getting array with skills Angular and Java. Okay, so this is how form array works in Angular. And I hope you understand the concept of all three fundamental building blocks of Angular. Just to recap, form control represents a single form field, and form group represents a collection of form controls, and form array represents a dynamic array of form controls. Now let's dive into reactive form validations. And as we learned earlier in the template driven form, Angular provides 5 built-in validators: required, min length, max length, email, and pattern. And in the template driven form, we added validations directly in the template file. However, in reactive forms, we will use these same validations in the class file. So to start, I'll remove the required validator from first name field. And to use validators in reactive form, first we need to import validators from Angular/forms module. Validators. A validator is a function that checks an instance of form control, form group, and form array, and it returns a list of errors. And if the validator returns null, it means the validation has passed. And we can add multiple validators to an array separated by commas. So let's add the required validator to first 4 fields. After this empty string, I'll add an array, and inside this array, we can add multiple validators. First, I'll add validators.required, and the same validator I'll paste for last name, email, and password. Now next, I'll add rest 4 validators as well. So let me add pattern validator to the first name field, validators.pattern, and inside round bracket, I'll copy the same pattern which we have provided in the template driven form and paste it here. Now next I'll add min length validator to the last name field, validators dot min length with minimum of 10 characters. Next I'll add max length validator to the email field, validators dot max length. I'll specify a maximum of 15 characters. And also I'll add email validators to the email field, validators dot email. Okay, so I have added 5 built-in validators to these 4 fields. And by using these validators, we can ensure our form data meets the required criteria. Now save the changes and let's test the validations in the browser. And as we have already disabled the submit button for invalid forms, we need to fill the first 4 fields correctly to enable it. So since we have added required validators to these fields, I'll start by adding ABC1, 2, 3, 4. to all four fields: first name, last name, email, and password. So as per required validator, we have added values to all four fields. But if you notice, the submit button remains disabled due to the other validators such as min length, max length, pattern, and email. So let's correct each field one by one. For first name field, we have added required and pattern validator. And since we have already entered the values in all four fields, we have taken care of the required validator. So let's focus on the other validators. That is, for first name, we have added pattern validator. And this pattern only allows characters from A to Z. So to fix this, I'll remove the numbers from first name field. Now let's move on to the next field, last name. And for last name, we have added required and min length. And it requires a minimum length of 10 characters. So I need to update this field with 10 or more characters. So let me type few more characters and move on to the next validator. Next validator is max length. It has a maximum length of 15 characters for the email field. So I'll ensure the email value is less than 15 characters. And we have added only 7 characters. So this value we have added as per our max length validator. Now last validator is email validator. And it requires a proper email format such as abc@gmail.com. So as soon as I update the email field value with proper format, you will see that the submit button becomes enabled. However, if I miss any validator, the submit button will become disabled again. For example, if I add more than 15 characters to the email field, the submit button will be disabled. So this demonstrates that our built-in validators are working as expected with reactive forms as well. Now let's add error messages for users to understand what went wrong. And to do this, I'll copy the if block from template driven form and paste it into reactive form. So after this first name, I wish to add the error messages. And in reactive form, we can access each form control using the form name.controls property. And our form name is reactive form.controls. And inside square bracket, we need to pass the respective form control name. So I'll pass first name. Okay. So this syntax allows us to access form controls without creating local variables for each field. So let me update the code using this syntax. And for first name field, we have added required and pattern validator. So here, let me update with pattern. And the error message for pattern validator is first name does not match the required pattern. Let me remove this extra round bracket and now save the changes. Let's test our form on the browser. Let me refresh the browser. And when I click on the first name field and then leave it empty, the required validator is triggered and displaying an error message, first name is required. Similarly, when I type a number or special character like 1234 or dollar, percentage, etc., the pattern validator is triggered and displaying an error message, first name does not match the required pattern. Okay. Now quickly add similar error message to the rest of the validators. So let me copy this if block and paste it below this last name field. Let me update this first name with last name. And for last name field, we have added required and min length validator. So here I'll update with min length, and the message for min length is the minimum length of the last name should be 10. After that, I'll add the same if block to the email validator. Here, instead of last name, write email. And for email, we have added 3 validators: required, max length, and email. So here I'll update with max length and here with email. And the message for max length validator, the maximum length should not exceed 15 characters. And last error message for email validator is please enter a valid email address. After that, we will need to add only required validator to this password field. So let me delete these two validators and I'll keep only required validator. Let me update this email field with password. Okay, so with this, we have added respective error message to all these four fields. Now let's retest the form. And when I click on all four fields and leave them empty, the required validator is triggered for each field and displaying the respective error messages. And as expected, when I type a number or special character in the first name field, the pattern validator is triggered with an error message. So let me remove this and add proper name, that is Poonam. Now next, if I type less than 10 characters in the last name field, the mean length validator is triggered with an error message. The minimum length of the last name should be 10. So in order to disappear this error message, I need to write 10 or more than 10 characters. Now next, if I type an email address with an improper format, the email validator is triggered with an error message. Please enter a valid email address. So let me type valid email address poonam@gmail.com. But it exceeds the 15 character limit in the email field. So in this case, email validator message disappears and the max length validator is triggered, displaying an error message. The maximum length should not exceed 15 characters. So I need to delete some characters from this email address. And last, for password field, we have added only required validator, so I can type anything inside password field. Okay, so this is how we have checked all the validators and our form is working as expected, along with displaying helpful error messages to guide the user. So that's all about reactive forms. And we have now covered the essentials of Angular forms. We have learned how to create template driven forms as well as reactive forms. Under this, we have explored how to set default values, reset forms, and add built in validators with error messages. Additionally, I have highlighted the key differences between template driven form and reactive form to help you to understand the concepts better. But for now, if you feel confident about Angular forms, please like, share, and subscribe to FAD Learning for more useful content. So far, we have made great progress in our Angular journey, covering key concepts like components, data bindings, routing, pipes, directives, and forms. Now, it's time to take your skills to the next level by exploring the topics, services, and dependency injection. Let's start with the definition. A service is a self contained reusable piece of code that performs a specific task, making it easily shareable across multiple components within your application. In simple terms, a service is a piece of code that you can reuse in many components across your application. Next, let's discuss when should we use a service in an Angular application. Let's explore some scenarios. First scenario is when we want to share data between different components, we can use service. Second, when we need to share business logic across multiple components, then also we can use service. And third, when we need to interact with database such as sorting, retrieving, or managing data, we can use a service. Now let's visualize these three scenarios with a diagram and then we will put them into practice. So our first scenario is to share data between different components. Let's assume we are building an Angular application for a social media platform and we have a user data in the form of object. So this data need to share across multiple components. For example, dashboard component which shows the user recent activity, profile component which display the user's detailed profile information such as email, phone number, address, etc. Next, navigation component, which display the user's name and profile picture. Therefore, all three components need access to this user data to display their respective content. So in this scenario, we might think of copying the user data and pasting it into all three components. However, this approach goes against the dry principle of Angular, that is, do not repeat yourself. Therefore, instead of copying and pasting the user data into each component, we can create a service that stores the user information. And this service can then be injected into each component, allowing them to access user data. Now let's consider another scenario, sharing business logic across multiple components. So here, suppose we want to implement a feature that checks if a user is eligible for a premium subscription based on their profile information. So initially, we might add a method to components class file to encapsulate this business logic. But if multiple components needs this functionality, then duplicating the code in each component would not be practical. And this is where the service comes in handy. The service can encapsulate the business logic for checking premium subscription eligibility, and then any component that needs to implement this logic can simply inject this service and use its method to determine eligibility. So by sharing the business logic through a service, we can maintain and update it in one place, avoiding code duplication and making our application more efficient. Now let's explore these two scenarios with a practical example, and then we will move on to the third scenario. So let me open Visual Studio Code Editor, and here let me create a new component called profile, and generate component profile. Then inside the component's TypeScript file, I'll add user data object to display dummy data. ID1, name John, username John, and email john@gmail.com. Okay. Now next, in the template file, I'll bind the user data object and display its value to showcase the user's information. Here, let me take one div with class margin 3, and then inside this div, I'll take one UL tag and then li. This li for ID, and I'll bind this ID with user data.id. Similarly, I'll bind name, username, and email. Name, username, and last email. Okay. Now save the changes and let's check the result in the browser. Okay, I forgot to add this profile inside the routes. So let me add this quickly inside app.routes.ts file. After this user, I'll add profile, and component will be profile component. Now inside app.component.html file, after this user, I'll add one more li for profile. Now save the changes and let's check the result in the browser. Let me navigate to profile component, and as we can see, we have successfully displayed the dummy user data. But now, what if we want to display the only name from this user object in another component, like in data binding component? If I want to display the same name inside this data binding component, then what we have to do? So in this case, we would typically paste the same code into the data bind component class file and bind the names to the template file, just like we have binded with this profile component template file, right? But as we discussed earlier, this approach involves duplicating code across multiple components, and which is not ideal. So to avoid duplicating code across multiple components, we will use a service. So now let's create a service called shared data using the CLI command ng generate service as for service and service name shared data. Enter, and this command generates two files, a .ts file and a spec.ts file. But we will focus on .ts file, which contains a basic service skeleton, and we will add our service logic to this file. Now, in Angular, components use the @component decorator, while services use @injectable decorator to enable dependency injection. And the @injectable decorator tells Angular to inject constructor arguments through its dependency injection system. And what is dependency injection? Dependency injection allows components to receive dependencies rather than creating them manually. And by using dependency injection, we can make our code more modular and reusable. Okay. Now in our service, we use the provided in metadata with the value root. This means that if you are working on a module based Angular application, instead of adding the shared data service to the provider's array of app module, you can create a single instance of this service that can be shared across the entire application. Okay. Now let's move the dummy data from the profile component to the service file. Let me copy this user data and paste it inside service. And I'll comment the user data from profile component TS file. Now, by doing this, our profile component now relies on the shared data service. So to fetch the service data in the component, we first need to inject the service through constructor. So here, let me add constructor, and inside round bracket, let's inject the shared data service. Private service name shared data shared data service. Okay. So this is how we used to inject the service in component. And injecting the service means we are injecting the dependency, which is the core concept of dependency injection. Now, once injected, we will store the user data in a local variable. So let's create one local variable called dummy data of type any, and let me store the user data into this dummy data. This dot dummy data equals to this dot shared data dot user data. So with the help of underscore shared data, we are accessing the shared data service. And inside shared data service, we have added the user data object. Okay. So now we have stored all the user data inside dummy data variable. Now let me bind this dummy data to the template file to display the user data. But this time we will get user data from service, not from component. So let's test in the browser, and we can see the same user data in the browser. But this data is coming from share data service. Okay. So this is how we can fetch data from service to component. And now I can easily display the username in the data binding component by injecting the shared data service. So let me copy this code and let me go inside the data binding.ts file, and here I'll paste the constructor code. So here we need to import the service, and then with the help of this dummy data, I can bind the name. So here let me bind username equals to, using string interpolation, dummy data dot name. Save the changes and let me test in browser. Okay, property topic. Okay, for now I'll comment out this code as well. Now I'll navigate to data binding component, and as expected, we can see the same username displayed here as well. Okay, so with this we have completed the demonstration of our first scenario. Now let's move forward and work on second scenario, that is sharing business logic across multiple components. And to achieve this, I'll add a new property to this existing object user data called subscription with the value of basic. Now we have our data, and I want to display a message saying you are eligible for premium subscription if the user meets the eligible criteria. And the criteria are: the subscription type is basic, and the email address ends with @gmail.com. And I want to implement the same functionality in multiple components. So we will bind this functionality in same profile and data binding components. So to achieve this functionality, what I need to do? I need to write the method in both the profile and data binding component with specified criteria, right? So instead of duplicating the same business logic in both the components, I'll add the logic to the service file, and then using dependency injection, we can access the same logic from any component that needs it. Okay, so let's create a method here called is eligible for subscription. And inside this method, I'll add a conditional statement to check if the user meets the eligibility criteria. So inside if block, I'll add condition this dot user data dot subscription equals to basic, and this dot user data dot email dot ends with @gmail.com. Dot. We need to write this format inside quotes. Now, if these conditions are true, the method will return true. Otherwise, it will return false. Okay, so what I have written here, this is eligible for subscription method will return true only if the user's subscription type is basic and their email address ends with @gmail.com. And this AND operator ensures that both conditions must be met for the method to return true. Otherwise, this method will return false. Now let's call this method in the profile component. And here we have already injected the shared data service through constructor. So let's display the message directly in the template file. And to do this, we can add a conditional if statement to check if the user is eligible. So I'll use @if block. And inside this if block, we can either directly call the method like this dot underscore shared data dot this is eligible for subscription, or we can store the result of this method into one variable. Like here, I'll create one more variable is eligible of type Boolean, and after this dummy data, I'll store the result of is eligible for subscription method into this is eligible variable. And now we can bind this is eligible variable to this if block. Okay, so either approach will work. Now, inside this if block, I'll add one h4 tag with Bootstrap class text success. And inside this h4 tag, I'll write the message, you are eligible for a premium subscription. And inside else block, I'll write a message, you are not eligible for premium subscription with class text danger. Okay, now save the changes and let's test in the browser. Let me navigate to profile component. We should see the message you are eligible for premium subscription in green color. But if I change the email address to end with yahoo.com, in this case, the message should change to you are not eligible for premium subscription in red color. So this logic we have used in profile component. Now, if I want to display the same message in data bind component, then I just need to bind this is eligible for subscription method inside the data binding component.ts file. So here, let me create one more variable called is eligible of type Boolean. And then I'll copy the if condition block from profile component template file and paste it into data binding component template file. Save the changes and let me navigate to the data binding component, and here you can see you are not eligible for a premium subscription. And if I correct the email ID like gmail.com, Then we will receive message you are eligible for a premium subscription in green color. Okay, so with that we have completed exploring our first two scenarios, and in both scenarios we have used service to avoid duplicating code and make our application more efficient. Now let me go back to PPT and let's explore the third scenario, connecting to a database and retrieval operations. And in our previous two scenarios we worked with dummy data, but in real world project, we typically deal with large amounts of data. And this type of data usually comes from a REST API or backend API. For example, imagine we are receiving the user data from a backend API instead of our dummy data. And to demonstrate this scenario, we will use the JSON placeholder user API. So to fetch data from this API, we need to send the HTTP request to the backend database. Then we will get data as a response in the form of observable. And we will do this in our service file. Once we set up the service, we can inject it into any component that needs the data. But before we implement this third scenario, let's understand how Angular HTTP service architecture works. So let's imagine we have data stored in a database and we have created a service that multiple components will use. But in an Angular project, we create services and components, but we don't create databases. So when we need a data, we add a REST API to our service. However, simply adding a API is not enough. We need to send the HTTP GET request from service file to the database to retrieve the data. And once the database receives the request, it sends the data back to the service as an observable. So let's imagine that now our service holds the data in the form of an observable. But here is the important part. The component can't access the observable data directly into the component class file because observables are lazy, which means they only execute when we subscribe to them. So for our components to access the data, they need to subscribe to the observable. Okay, so this is how HTTP service architecture works in Angular. Our service sends a request to database and service receives the data as an observable, and then our components subscribe to that observable to access the data. So hope you understand the HTTP service architecture. Now let's explore the third scenario with a practical example. So I'll go back to Visual Studio Code Editor and we will continue from there. So the first step is to configure your application to work with REST API. And let me open the app.config.ts file. And if you are not working on a module based Angular application, then you need to add a provide HTTP client module to the providers array in your app.config.ts file. And this will import from angular/common/HTTP module. So this is our first step in order to work with REST API. Now next step is, let me search the JSON placeholder API and I'll copy this user API and store it in a variable called API data or API URL equals to, I'll paste this URL. Okay. Now next, we need to send the HTTP GET request to the database. Database means this database API. And to send the HTTP request to database, we need to use the HTTP client model. So let's inject the HTTP client model inside the constructor private underscore HTTP :HTTP client. And after that, I'll define one more method called getUserData. And this method returns the HTTP GET request with this API URL. Okay. So let's return underscore HTTP dot get, and inside round bracket, we need to pass the API URL. That's it. So with this syntax, we can send the HTTP GET request to the database. Okay. So what is happening here? Our shared data service is sending a HTTP GET request to the database, and the database will respond by sending the data in the form of an observable. This means now our getUserData method holds the user data in the form of an observable. And to access this data, component needs to subscribe to this getUserData method. So inside profile component, we have already injected the share data service. So now let's subscribe to the get user data method. For this, I'll create new method called get data, and inside this method, I'll call the get user data with the help of share data service. So this dot share data dot get user data, and we need to subscribe to this get user data service because this method is holding the data in the form of observable. And now after this subscribe method, we need to handle the response. So to handle the response, we will use the fat arrow function and store the response in the local variable. So let's create a local variable called API data of type any, and I'll assign this response to API data. Now let's call this getData method in the ngOnInit lifecycle hook. So let's implement ngOnInit lifecycle hook on init, and here I'll define the ngOnInit lifecycle hook. And inside this, I'll call the getData method, because this ngOnInit hook is called once the component is initialized on the web. Okay, so that's all we need to do in our TypeScript file. But don't worry, if some of the concepts are unclear, we will revisit HTTP GET request when we cover CRUD operations later on. Now, let's take a look at API data, and it's currently in an array of objects format. So here inside array, we can see multiple objects. So in our HTML file, we will use for loop to iterate over the API data. And here, let me add comment. This is the example of sharing data across multiple components. And this example is of sharing business logic across multiple components. And third example is interaction with API. Okay. So here, let me copy this URL and comment out this code for now. And I'll paste this URL here, and inside URL, let me use the ngFor directive. Let data of API data. And now I'll bind this ID, name, username, and email ID with data. Now save the changes and let's test the list of users in the browser. Let me navigate to profile component. Let me see the error. Can't bind ngFor. Okay. In order to use ngFor directive, we need to import the common module inside imports array of same component. Okay. Now let's retest. And as expected, you can see all 10 users displayed, which matches the number of users provided by API. We are getting 10 users from this JSON placeholder users API. Okay. So in this example, profile component uses the shared data service to fetch user data from the API when the component is initialized. And the best part is that this service can be shared across multiple components wherever user information needs to be displayed. So with this, we have successfully demonstrated all three scenarios where we can use service in Angular. We can use service to share data across multiple components, to share business logic throughout the application, and to share API data across multiple components throughout the application. And Angular services serves three key purposes. First purpose is code organization, which means services keep your code organized by separating different concerns. Second purpose is reuse, which means services can be shared across multiple components, making it easy to reuse code. And third purpose is dependency injection. Dependency means an object or service that another object relies on. And injection is the process of passing a dependency to an object that needs it. So this makes components more modular, flexible, and easier to test. And how does dependency injection works in Angular? The first step is to register a service with Angular, and this is done using the @injectable decorator or in the @ngModule decorator. Next, when the application starts, Angular creates an injector, and the injector is responsible for creating instances of services. Next, when a component needs a service, it requests it by adding the service to its construct. And then the injector uses the component context to resolve the dependency. After that, if the service instance doesn't exist, the injector creates it. Next, the injector provides the service instance to the component. And last, component uses the service instance to perform tasks. This is how dependency injection works in Angular. And with this, we have wrapped up our coverage of services and dependency injection. Now let's put these fundamentals into action by exploring CRUD operations, where we will use get, put, post, and delete API methods to interact with data. So what does CRUD mean? CRUD stands for create, read, update, and delete operations. And these fundamental operations require data, which is typically retrieved through APIs. Earlier, while learning about services, we used a dummy API from JSON placeholder for demonstration purposes. And for practice, you can visit bceptor.com, which offers free backend APIs for testing and development. On this platform, you will find a wide range of APIs, including GitHub, JSON placeholder, e-commerce API, fake API, and many more. And apart from using existing APIs, we can create our own API using JSON server. So today, we will also learn how to use JSON server in Angular. So let's set up JSON server first. And this process involves three steps. First, install JSON server using command npm install -g space json-server @0. And this @0 flag ensures that you install the stable version of JSON server. It automatically generates IDs in integer format when you add new data to the database. Enter, and note that if you install JSON server without the @0 flag, IDs may be generated in hexadecimal format instead of integers. So this is our first step. Now next step is to create a new file with a .json extension at the root level. For example, here let's create a file named db.json, and we will add some sample data to this file. And especially we will create a users array within the object users array. And inside this array, I'll add individual user objects like id :1 name Shivam, username Shivam, and email Shivam@gmail.com. This is how I'll create two more users. Okay, so this is how I have added three user objects inside this users array. And with this, we have completed the first two steps. Now, let's move on to the third step, that is running the JSON server. And to do this, use the command json-server space --watch space file name db.json. Hit enter. This will start the JSON server and provide us with API endpoints, such as localhost :3000/users. Notice that the endpoint includes the name of the array we created in the database file, which is users. And if we navigate to this URL, we will see the data which I have added to the db.json file. Okay, so with this, we have completed setting up our JSON server. And now we have a fundamental endpoint URLs with data. And this means our backend is ready. And now let's shift our focus to the Angular side. So in this terminal, our JSON server is running. And this first terminal, our Angular project is running. Okay. So let me open one more terminal. And as we have already learned that services plays a crucial role in managing database connections and to maintain clean and organized code. So instead of mixing component logic and database code in the same file, it's better to create a service and keep all database related code within that service file. So I'll start by creating a new service using the command ngGenerate service as for service and service name CRUD. Enter. And this command will create two files. One is .ts file and one is spec.ts file. We will focus on .ts file. And also we learnt when working with dependency injection, we follow a specific architecture for making HTTP request. We create a service that sends an HTTP GET request to the database, and then the database responds with data in the form of an observable. And to retrieve this data, component needs to subscribe to the observable. And once subscribed, component can access all necessary data from the service, right? So let's begin with the GET API call. So inside this service file, we will send an HTTP GET request to the database. For that, first I'll inject the HTTP client service through the constructor private HTTP:/HTTP client. And for best practice, let's store the endpoint URL in a variable called base URL of type string equals to, I'll paste our endpoint URL. Now, before making the HTTP GET call, let's create an interface using command generate interface name iUser. For clarity, I have used the prefix I to indicate it's an interface, but you can choose any name that you like. Now, inside the iUser interface, we will add properties for the users. So here, let me add ID of type number, name of type string, and username of type string, and last email of type string. Okay, so this interface will help us to define the structure of the user data that we will receive from the API. So whatever properties you have in the API, ID, name, username, email, that you have to add inside the interface with their data types. Now let's jump into service file, and here I'll create a method called getData. And within this method, we will return an HTTP GET call request using http.get. So this .http.get, and inside the parenthesis, here you can see we need to provide the URL of type string. And we have stored our endpoint URL in base URL variable. And since we have created the iUser interface, we will define the data type as iUser and square bracket. These square brackets indicate an array of user objects. Okay. So this is how we have sent an HTTP GET request to the database from the service file. Now next, I'll create a new component called ngGenerate component name CRUD. And let's add the root for this CRUD component inside approutes.ts. So let me search app.routes.ts file. And here I'll add one more object for CRUD, and the corresponding component name is CRUD component. And also inside app.component.html file, I'll add a link for this CRUD component. So here, let me copy paste the link, and the last link is for CRUD. And here, let me change the name to CRUD or CRUD operations. Now save the changes and let's open the browser on localhost 4200. Let me minimize this page, and here you can see the CRUD operations in the navbar list. So let me navigate to this CRUD operation component, and we can see the CRUD component loaded on the browser. Now in this CRUD component, we will display the list of users. And since the data is available in our CRUD service file in the form of an observable. And as per HTTP service architecture, in order to fetch the observable form data, the component needs to subscribe to that method. So let me open the CRUD component.ts file, and here first we need to inject the CRUD service through construct. So here private CRUD CRUD service. After that, I'll create new method called getAllData, and inside this method, let's subscribe to the CRUD service method. And how we can access CRUD service? With the help of local variable CRUD. So this dot CRUD dot get data method dot subscribe. And to handle the response, we will use a fat arrow function and store the response in the local variable called API data of type iUser interface square bracket equals to empty array. Now let me store the response in local variable, that is API data equals to response. Okay, so by doing this, now we are holding the user list inside this API data variable. But to load this list of users on page load, we will call this getAllData method inside ngOnInit lifecycle hook. And to use this method, we need to implement onInit. So here implements onInit, and then we need to define method inside class with ng prefix ngOnInit, and then I'll call getAllData method inside this ngOnInit. Now let me open the browser, and here I'll open developer tool, and let's add a debugger to see if the data is being assigned to the API data variable or not. And to do this, I'll open crud.component.ts file in the sources tab. And here I'll add breakpoints after this subscribe. Now I'll refresh the page, and once I over to this response, we can see the list of users. And if I press F10 and over to this API data, and the data is now available in the API data variable. Okay, so now we have data inside our CRUD component TS file. So next, we need to display this data in the browser by adding API data to the HTML file. So inside HTML file, let's create a table and populate this table with API data. Let me take one div with class container, and I'll add heading with class text center dot margin 4, and I'll give heading Angular 19 CRUD operations with JSON server. And after this heading, I'll add table with class table dot table success and table stripped. And inside this table, I'll add thead and then tr, and inside tr I'll add th. This th for ID, second is for name, third is for username, and fourth is for email. And after this thead, I'll add tbody. Again tr and then td. Now inside this tr, we need to iterate data over the API data variable. So here I'll use the ngFor directive, star ngFor equals to let data of API data. And for this ngFor, we need to import the common module or ngFor module inside the imports array of same component. So here let me common modules. Now save the changes, and inside HTML file, I'll bind this table data with API data. So using string interpolation, here I'll bind data.id, and this is for data.name, data.username, last data.email. Okay, save the changes, and let's go back to browser, and here you can see all three users listed in the table. So let's recap what we have done so far. We set up the JSON server, then added dummy data inside this db.json file, and after that established the HTTP connection with database from this service file. And next, in our CRUD component, we subscribe to the service method to retrieve data here and bound it to the template file. And one more thing, to make this HTTP connection, we had to add provide HTTP clients to the providers array of app.config.ts file. Here you can see we have added when learning about services. So without this, we can't establish the HTTP connection with database. Okay. So previously, we made an HTTP GET call using the JSON placeholder user API while learning about services. And this time we made the same HTTP GET call using the JSON server. And now with this user list, we will perform CRUD operations such as create, read, update, and delete. And to understand each operation clearly, I'll create separate component for each one. Specifically, I'll create an add user component for creating a new user, ngGenerate component, add user. Next, I'll create a view user component for reading the user. And last, I'll create update user component for updating a user. Okay, I have created 3 separate components for create, read, and update. And also I'll add routes for these 3 components in app.routes.ts file. So after this CRUD, I'll write the path add user, and for this component will be add user component. Next, update user. For this component will be update user. And last, view user. Component for view user is view user component. Okay. So for this CRUD operation, we have created 4 components and we have added the 4 routes for all 4 components. Now let's move forward with the first operation, which is creating a new user. And for that, we have already created a add user component. So in the CRUD component template file, I'll create a new button called add user component. Button.btn.btn info, and I'll add the one more class margin 2. And the button name is add new user. And when this button is clicked, it will call add new user function. Okay, next I'll define the same function inside the TS file of same component. And when the add new user function is called, I want to navigate to the add user component. And to achieve this, we will use the routers navigate or navigate by URL method. And to use routers method, first we need to inject the router through constructor. Private router :route. Now inside this add new user method, I'll call the router.navigate_by_URL method and pass the routes inside this parenthesis. And what path we have added for add user? This path we have added. So I'll paste this path here. Okay. So this navigate by URL method allows us to navigate from one component to another component. And if you need to pass extra parameters with the route, such as ID or status or anything, we would use the navigate method instead of navigate by URL method. We'll see that when updating the user. Now let's test this. Let me click on this add, and as you can see, we are navigating to the add user component. Now to add a new user, let's create a reactive form within this app user component. So let me close this interface, and now let me open the add user component template file and class file. Inside template file, let's create a form. I'll take view with class container. After that, I'll add form. Then I'll add heading with class text center and margin 4. And I'll add heading add user. After that, I'll add first field, div with class form group and margin 3. Inside this div, I'll add one label with class form label. And the field name is name. Then after this label, I'll take one input box with class form control. And placeholder for this input is enter the name. Now I'll copy paste the same field 2 more times. The second field is for username. Placeholder will be enter the username. Third field for email. The placeholder will be enter the email. Okay, save the changes and have a look in the browser. Okay, let me add few more Bootstrap classes. Width 75, margin top 5, and MX auto means horizontally center. Sorry, I am adding this classes to the heading. Instead of heading, I need to add it to the form. Class equals to width 75, margin top, margin X auto, and PG color info. Also, I'll add padding 5. Okay, and hopefully I have added same color to the add new user button. Yes, button info, and here background info. Now last, let me add 2 buttons inside div with class text center and margin 3. Inside this div, I'll add button dot btn dot btn success. So I'll add one more class btn lg for large and margin 1. And the button name is add. And I'll add one more button for cancel. For cancel, I'll change the button color to danger. Now on click of this cancel, I'll add one click event equals to I'll add the function name on cancel. Now let's define the same function in the TS file. And when this cancel button is clicked, I want to redirect back to the CRUD component. So let me inject the router first through constructor private router router. Now inside this onCancel method, I'll call routers navigateByUrl method. Inside this, I'll provide the path CRUD. Okay. Now on click of this cancel button, we are redirecting to the CRUD component. So we have created the basic form inside the add user component. Now to make this form reactive, I need to import reactive forms module inside the imports array. And next, let's create the form group instance. So for that, I'll create a variable called add user form of type form group. And to initialize it, I'll use form builder service. So let me inject form builder private fb form builder. And now I'll assign the result of form builder to this add user form variable. Like here, add user form equals to this dot fb dot group unexpected token, a constructor method. Okay. We need to write this code inside constructor. Okay. So here I have assigned the result of form builder dot group to this add user form variable. Now inside this, let's add the form control instances. And each form field need its own form control. So for this add user form, I'll add 3 form controls. First is for name, second is for username, and third is for email. And I'll pass an initial value to each form control as a string. Okay. Now we have both the form template as well as the form instance. So now we need to connect them. And to do this, we will use form group directive. Inside square bracket, I'll write form group equals to, we need to bind this to our form instance, that is add user form. Okay. Next, each form field correspond to a form control. So in order to link this form field with form control, we can use form control name attribute to each field. So here, let me add form control name equals to name. Let's add this attribute to rest two fields as well. This is for username and last for email. Now last we need to handle the form submission. And for that we will call onSubmit function using the ngSubmit directive. ngSubmit equals to onSubmit. And finally, let's define this onSubmit method inside TS file. And this method will return an object with a value properties. So let's add console.log, and inside this I'll add this dot add user form dot value. Save the changes and let's test our form. And we are getting an error, can't bind to form group since it is not a known property of form. We have provide the type of add user form is form group. We have imported reactive forms component. Instead of this, we need to import reactive forms module. Sorry for this. Now save the changes and let me open developer tool. Now let me add some data into this add user form. Let's add Vishal, username also Vishal and email ID vishal@gmail.com. And when I click on the add button, you can see an object logged to the console with the values we entered. Now next we want to send these same values to our JSON server. And to add data to the server, we will use post method. So in our service file, let's create a new method called postDate. And this method will take our form data, which is of type iUser. That is our interface. And then we can send this data to our endpoint URL. Okay, so inside this method, let me return this .http.post, and inside parenthesis, here you can see this method expect two parameters. One is URL of type string and second parameter is body or form data. So here, let me add base URL, comma, date. Now save the changes and go inside add user components.ts file and let's subscribe to the post data method inside onSubmit method. Before that, we need to create an instance of CRUD service here. For that, we need to inject CRUD service through constructor. Private CRUD of type CRUD service. Now we can access the CRUD service methods. So here CRUD dot post data, and here I'll pass data as add user form dot value dot subscribe, and inside the parenthesis again I'll use fat arrow function, and once the data is successfully posted, I want to navigate back to the CRUD component. So here let me call the router method router.navigateByUrl, and inside that I'll pass the CRUD component path. Now let's test everything by adding a new user data. Let me add another data here, Vivek, Vivek, and then vivek@gmail.com. Now once I click on add button, the application will redirect to the CRUD component and we can see the fourth user added in the table. Also we can refresh this endpoint URL. Here also you can see the user which we have added few seconds before. Okay, so we have successfully implemented get and post API call, and hopefully this explanation has helped you to understand the process clearly. Now let's move on to the third API call, which is put. Let me comment out this console. And so far we have used get method to fetch data from the API. And then we have used post method to send new data to the API. And now we are using put method to update existing data in the API. Okay, so to demonstrate the put API call, first let's create a scenario. Inside CRUD component.html file for update, view, and delete operation. Let me add 3 more th here. One is for update, next is for view, and last is for delete. Next, I'll add corresponding data in 3 table cells inside this T body. Inside TD, I'll add one button, button.btn.btn warning. Also, I'll add one more class, btn small, and margin 1. And this button is for update the user. Same button I'll add for view and delete. For view, I'll change the button color to secondary, btn secondary. This is btn hyphen warning, and this is btn hyphen danger. Save the changes and let's have a look in the browser. Let me add few classes to this t head. Class equals to call2. And for email, I'll change it to 3. And now for these 3 buttons, I'll add call1. Yeah, now it looks good. Okay, so I have added 3 buttons, but first we will focus on update functionality. So let me add a click event into this update button. Click equals to on update. Now let's define this on update method inside the TS file of CRUD component. And on click of this function, it will redirect us to the update user component. So let me call the router method again, router.navigateByUrl, and inside this, I'll pass the path for update user. We'll just copy paste the same path to avoid the spelling mistakes. Now let's test in the browser. If I click on the update button, I am redirecting to the update user component. But inside this update component, we are unclear which specific user we want to update, right? So to solve this, we have added an update button for each record. So when I click on one of these buttons, I want to update the corresponding user record. But how do we identify the specific record to update? We can do this using the primary key, which is the user ID, right? So this 1, 2, 3, 4. And to achieve this, let's modify the route first. So inside this route.ts file, we need to include the ID parameter after this update user path. So we need to add forward slash, then colon and ID. And this ID we will take from the user table data, right? So I'll again go back to CRUD component.html file. And here let me pass data.id. We are getting all the user data inside this API data. And using ngFor directive, we are accessing whole API data using data variable. So I have passed data.id as a parameter to this onUpdate method. And when we click on this update button, we need to pass the ID along with the route. So here, let me modify this onUpdate method. Now it will accept ID parameter, which is of type number. And when navigating to the update user component, we will use the navigate method instead of navigateByUrl, because here we need to pass the ID along with the update user in the array. So let me add square bracket here. After route, I can pass ID. So hope you understand the difference between navigateByUrl method and navigate method of route. If you need to pass extra parameter along with route, we should use navigate method. And if you only need to pass the route, then we should use navigateByUrl method. Now let's test this. If I click on fourth user update button, you can see the ID in the URL. Okay. Now if I click on second user, you can see the respective ID in the URL. So now we can fetch the user record correspond to this ID. And to do this, let's create a new method in the service file. Let me open CRUD service. And here I'll create new method called getDataById. And this method will take one parameter of type number. And inside this method, I'll again send the HTTP GET request to the database, requesting only the record with the matching ID. http.get of type iUser, and inside parenthesis, I need to append ID to the endpoint URL. This dot base URL slash $ID. So by doing this, we are expecting only one user record correspond to this ID from the database. Now to retrieve the user record from this getDataById method, the component needs to subscribe this method. And which component requires the user record? The update component requires user data. So let me open the update user component.ts file. And from this file, we need to subscribe to the getDataById method. So here, first I need to inject the service through constructor private CRUD of type CRUD service. And then instead of creating new method, I'll add code inside onInit lifecycle hook. For that, I need to implement onInit and then need to define ngOnInit lifecycle hook. And inside that, let me subscribe the service method CRUD dot getDataById. And here you can see this method expects one parameter ID which is of type number. So we need to pass ID in order to subscribe this method. And we receive this ID from the CRUD component through the URL that we have already seen. Before subscribing to this method, we need to fetch ID from the URL. And to fetch ID from URL in Angular, we can use activated route service. And in order to use any service, first we need to inject it. So private active route of type activated route. After this, I'll create a new property called user ID with a type of object that has a property called UID, which is of type number. And then inside ngOnInit lifecycle hook, we will assign the value to this UID property. So let me access the user ID with this keyword, this dot user ID equals to inside curly brackets UID colon. Now I'll access the activated route. Activate route dot snapshot property dot params. First, let me write syntax and then I'll explain. Inside square bracket ID. Now I'll explain this line. So this active route which provides information about the current route. And next, snapshot. This is the property of activated route that provides a snapshot of current routes parameter. And params is the property of snapshot that contains an object with the routes parameter. And this ID is accessing the value of the ID parameter from the routes parameter. Now let's log the ID to verify its value. So inside user ID dot UID. Let's test in the browser. Let me go inside CRUD operation and I'll open developer tool. Let me clear the console. And if I click on the first user update button, we are receiving the same ID from the URL, right? If I click on the another record, like third record, I'll receive the corresponding ID in the console. So now we are getting ID in user ID.uid. So let's subscribe to this method now. So I'll pass the parameter user ID.uid to this getDataById method. Dot subscribe and inside parenthesis, again we need to handle the response using fat arrow function. And I'll store the result in local variable called user data of type any. So I'll store the response in user data equals to response. Now save the changes and let me open browser. And here I'll go inside sources Let me open the update user component.ts file, and now I'll add debugger to this line number 29. Let me go inside CRUD operations, and I'll click on this fourth user. And if I over to this response, we can see the user's information. If I click on F10, now you can see the respective user data is available in our local variable user data. Now next, let's display this record in the browser using the update component template file. I'll go inside update component template file, and here you can choose to display the data in a table or a form depending on your preference or requirement. For this example, I'll use the form, the same one we used to add a new user. So let me copy the complete form from the add user component template file and paste it into the update user component template file. And here I'll just change the form name to update user and the heading to update user. And after that, I'll change the button to update, and everything else remains the same. Now next, let's define the onSubmit and onCancel method in the TS file. So I'll copy the onCancel button from add user component and I'll paste it inside update user. Here we need to inject the router, private router of type router. And next, we need to define the onSubmit method. Now inside this onSubmit method, we need to send the updated data to the server. But before that, we need to create an instance of this form using the form builder service. So let me copy the relevant code from the add user component class file and paste it inside update user component class file inside constructor. And I need to inject form builder, private FB of type form builder. And also we need to create update user form variable of type form group. Let me paste the same name to this line number 16. And additionally, here we need to pass ID. Okay. After that, we're getting so many errors. Okay, here I have added extra curly bracket. Now our update user form is also ready, and we have created the instance of that form. And we are getting the user record inside this user data variable. So let's populate this form with the user data values. And as we have discussed earlier while learning about Angular forms, to set form field data, we should use the set value method. So here I'll use set value method to set the user data in the update user form. So let me write update user form dot set value. Inside parenthesis, I'll add curly braces, and now I'll set the value to each form control. So ID colon user data dot ID, comma name colon user data dot name, comma username colon user data dot username, and last email colon user data dot email. Save the changes and let's have a look into the browser. Again, we are getting the same error that we need to import the reactive forms module inside the imports array. And now you can see the user data is populated in the respective fields. And also we can update the data. But after updating this data, we need to send it to the database. And to do this, we need to send an HTTP put request from service file to database, right? So I'll go inside service and I'll copy paste the get data by ID method and I'll modify the method name. Instead of get, I'll write put data by ID and I'll pass the updated data to the endpoint URL along with ID. Instead of any, I can use iUser interface. And here, instead of get, I need to write put. And here you can see this put method expect two parameters. One is URL of type string and another is data. So after this, I'll add comma and pass data. Now save the changes and let's go back to update user component.ts file. And inside on submit method, we will subscribe to the put data by ID method. So let me access the service with local variable CRUD dot put data by ID. And here we need to pass two parameter, that is user ID dot UID and update user form dot value. Right? After that, we need to subscribe to this method and then we need to handle the response. I'll use fat arrow function. And after successfully updating the data, I want to navigate back to the CRUD component. Right, so I'll copy the same line and paste it here. Okay, so with this, we have done the coding part of this update operation. Let's recap what we have done so far. So by adding ID in the route, we are getting respective ID in the route's URL. So we have fetched the ID from the route URL using the activated route service. Then we sent an HTTP GET request to the database to retrieve the specific user's data. After that, we have created a reactive form and populated the data in the browser using the setValue method. Then we sent an HTTP put request from the service to update the data in the database. And then the update user component subscribed to that put method. Now let's test the update functionality end to end. I'll reload the user list and I'll click on the update button of the first user record and we are not getting the selected user data. Let me retest. Here we have added set values. We are getting response and user data and okay. I need to set the value after this response. Okay. Now save the changes and let me go back to the browser here. Okay. Let me click on cancel button and now again I'll click on the update button and this time it redirects me to the update user component with the selected user data, right? Now I'll update the data. Instead of Shivam, I'll write just Shiva. Okay, and shiva@gmail.com. Now I'll click on the update button and you can see the updated data in the table. And if I update some data here, for example, Ganesha 123456, and then click on the cancel button, it will redirect me to the CRUD component without updating the user data. Okay, so everything is working as expected so far. And with this, we have completed the create and update functionality. Now, let's quickly finish the read functionality. And we have already created a view button to each user record. So let's add click event to this. So let me go inside CRUD component and here I'll add click event equals to I'll assign function on view. And let's define the on view function in the TS file of CRUD component. And inside this function, I'll write the code to navigate to the view user component, router.navigate. And similar to the update user functionality, ID in the root as well as in the function parameter. So here also I'll pass data.id and here I'll pass ID of type number. And instead of using navigateByUrl, I'll use navigate method. Our path name is give user, comma, ID. Save the changes and let me click on view button and I'm redirecting to the view component. Okay. Now let me open view user component template file and class file. And here also we are getting the respective ID inside routes parameter. And to access the route parameter, we will use activated route service. Let me open update user component and I'll copy the same code for accessing the route parameter. And I'll paste this inside the view component class file. Let me close this app route file and open the update user component.ts file. We'll copy the same constructor from here and paste it inside view user component. Let me import the service, activated route, and router, and last form builder. We don't need form builder for this view user component. I'll not import this. Okay. Let me delete this set value method. And here also we need to subscribe to the get data by ID method to access the data from the service file. And since we have already covered this coding part a few minutes ago, so I'll reuse the existing code and move on quickly. Okay, so that is it we need to do inside the TS file. Let me go inside HTML file to bind the user data values in the template file. Okay, since we are getting data inside this user data variable, so we need to bind this user data values to the template file. And here I'll use few HTML tags and Bootstrap classes to do this. So let me add a div with class container, and inside this I'll add one more div with class width 50, adding 5, and then I'll add margin top 5, MX auto, and that's it. We'll see later. Next, I'll add heading with class text center and margin 4. The heading is view user. Then I'll take one more div, and inside this div I'll add paragraph for name, and for value I'll add b tag with class text info, and here we can bind the value of user data dot name. Now I'll copy the same paragraph and paste it 2 more times. Second paragraph is username, and third paragraph is for email. User data dot username, user data dot email. And after this div, I'll add one button with class btn dot btn success. The button name is close. I'll add click event to this button, and the function name is onClose. Let me define the same function inside TS file, and on click of this button, I want to redirect to the CRUD component. So let me call the router method router dot navigateByUrl, and inside parenthesis, I'll pass the path, that is CRUD. Now let's have a look into browser. Okay. If I click on close button, I'm redirecting back to the CRUD component. Okay, the view button is in gray color. So let me add one more class to this div, bg secondary, and text white. Save the changes and let me click on the view button. And now we can see the div user component in gray background. But we are getting an error, cannot read property of undefined. Okay, let me add here question mark. Save the changes, close. Let me click on view button, and everything is working as expected. Okay, when I click on the close button, I return to the users list table in the CRUD component. And when I click on the view button, I am redirecting to the view user component where I can read the user data. So now we have completed everything except the delete functionality, and which is actually very simple. All we need to do is open the CRUD component.html file and add the click event to the delete button equals to on delete, and we need to pass the ID through this function data.id. Now let's define the same function inside TS file with parameter ID of type number. And inside this function, we need to call the service method to delete the specific user record. So let me open the CRUD service file, and inside this service, In order to delete the data, we need to send an HTTP delete request to the database. So let me create new method called delete data with parameter ID, which is of type number. And inside this method, let's return the this.http.delete, and inside parenthesis, we need to pass base URL along with ID. That's it. Now let's subscribe to this delete data method from the CRUD component TS file. And now let's subscribe to the delete data method. CRUD data, we need to pass ID. After that, subscribe, and then response. And once the data is deleted, I'll reload the user list by calling the getAllData method. Save the changes and let's open the browser. And let me click on the delete button. And as you can see, the record is deleted successfully and the remaining user list is reloaded. And we can also display a message to the user, such as the confirmation alert or prompt, to let them know the deletion was successful. Like here, let me add one alert with message record deleted successfully. And after this alert, we need to reload the remaining users on the browser. Now save the changes and let me revisit the browser, and let's test by clicking the delete button. And this time I receive an alert with message record deleted successfully. And once I click the OK button, the remaining user list is displayed in the browser. Okay, so this is how you can add this type of alert after creating, updating, or deleting a user record to provide confirmation to the user. And with this, we have covered all 4 CRUD operations, which includes get, post, put, and delete API calls. We have used get method to retrieve data from the API, and we have used post method to add new data to the API, and we have used put method to update existing data to the API. And last, we have used a delete method to remove data from the API. Now last, let's test the CRUD operation functionality from start to finish. I'll reload the page on localhost 4200. Let me navigate to the CRUD operation component. And first, I'll add new user by clicking on this add new user button. Let me add the values in each field. FED learning, username is FED, email ID is fedlearning24@gmail.com. Now I'll click on add button, and as you can see, the third record is added to the table. Now let me click on the update button, and if I update the fields, FED learning, and here I'll add hyphen and then click on the update button. And as you can see, the update functionality is also working as expected. Now let me click on view button and we can read the respective user data. Let me click on close button and I'll navigate to the CRUD component. And finally, delete the user. Let me click on this delete button and I'm getting one alert. And once I click on OK, the record is deleted. Okay, so everything is working as expected. And if you observed, we have utilized most of the Angular's fundamental building blocks, including components, routing, directives, data binding, reactive forms, services, and dependency injection throughout this CRUD operation example. Now next, we will explore an alternative to the HTTP client module, and with the release of Angular 19, a new approach to handling HTTP request has been introduced called the Resource API. So let's dive into the new features of Angular 19, focusing on the resource and rxResource APIs, and see how they work with a simple example. And what's the difference between the resource and rxResource API? Essentially, we use the resource API for asynchronous operations that return promises, whereas we use rxResource API for asynchronous operations that return observables. Now let's explore how to utilize both resource APIs in our project to perform asynchronous operations. So let me open Visual Studio Code Editor. And until now, we used the JSON placeholder API and also created our own API using JSON server. But for this example, we will use another sample API from the Biceptor website. So let me open browser and I'll open the Biceptor website. And let's select a sample API. So today I'll choose the fake store API. And to use this API, we will store this endpoint URL in a string variable. So to demonstrate this example, I'll create a new component and service using the CLI command. So I'll run command ng generate component name resource API and hit enter. This command will generate a resource API component. Then I'll add a new route for this component inside routes.ts file. So here, let me add one more route for the resource API. And for this path, I'll add component resource API. Now save the changes and let me run this project in another terminal with command npm start. And now if I navigate to localhost 4200/resource API and hit enter, we should see the resource API component rendered in the browser. Next, for the service, I have created a new folder called services. And inside this folder, I have moved all existing services. Now I'll create a new service for the resource API under this services folder using command ng generate service. And I want to create service under this services folder. So first I'll write services and then slash followed by service name resource. Enter. Now inside resource.service.ts file, I'll store the dummy API endpoint. So here let me create new variable with name base URL of type string equals to inside double quotes. I'll copy paste this endpoint URL. But using only the base URL, we can't retrieve any data as you can see here. So to get data, we need to append a specific API endpoint to the base URL. For example, appending this API/products to this endpoint URL, we will retrieve a list of products available in the e-commerce store. Similarly, if I append API/users to this same base URL, we will retrieve a list of all registered users. Here you can see. So let's create a new table and display the same data in the browser. Let me copy this URL and paste it below this URL and I'll comment out this URL for now. Now, to fetch data from the REST API, we typically send an HTTP GET request to the database. And the database responds with data in the form of an observable, right? So let's do this quickly. So inside this service file, I'll create a method called getAllData. And within this method, we will send an HTTP GET request to the database API to retrieve the data. And to do this, we first need to inject the HTTP client module through the constructor. So private HTTP:/HTTP client. And now we can send the HTTP GET request using the API URL. Return this.http.get and then inside this get method, I'll use string literals to call the API. Dollar inside curly braces, I'll call base URL and then I'll append this API/users. Now I don't need this API, so I'll delete this. Inside this get API method, first I have called the base URL and after that I appended /API/users because this endpoint returns the user data. Now let's subscribe to this method from the resource API component and we will store the response in a local variable within that component. So let me open resource API component.ts file and here first we will inject the resource service through constructor. Private resource of type resource service. After that, I'll declare one variable called API data of type any, and then I'll store the API response to this API data variable. So let's create one method here called getData, and inside this method, I'll call the service method, and I can access service using resource.getAllData.subscribe, and inside this subscribe, I'll store the response in the local variable API data. So this dot API data equals to response. And after that, to load this data as soon as the page loads, we need to call this method inside the ngOnInit lifecycle hook. So let me implement onInit, and then we need to define ngOnInit method. And inside this, I'll call getData method. And this ensures that the data is fetched and displayed as soon as the component is initialized. Now let's display this API data in the browser through the HTML file. So let me open the HTML file, and inside this file, I'll copy and paste the same table we created for the CRUD operations. So let me copy this table from the CRUD component.html file, and let me paste it inside our resource API component.html file. And now I'll do some minor modifications. I'll update the heading to Angular 19 resource and rxResource API. And I'll change the table color to info, and then according to the API response, I'll update the column names. Let me see the response. User ID, username, email, and password. So here I'll edit this ID with user ID, and next username, next email, and last password. Okay. Now inside tbody, I'll delete these three TD. And in order to use this ngFor directive, I need to import the common modules inside the imports array. And then I'll bind this column data with API data. And by matching the property names with the API response, let me synchronize the property names to ensure accurate data binding. So instead of ID, I'll write user ID. Instead of name, I'll write username, then email, and last password. Now save the changes and let me open browser on localhost 4200. Here I am getting an error, property add new user does not exist. Okay, let me delete this button and now save the changes and let's reload the same page. And as you can see, the API data displayed in the browser. Okay, so this is the process we have followed so far to connect with database. However, starting from Angular version 19, we can utilize the resource and rxResource API to fetch the same data from the backend. So let's understand how to display the data using the resource and rxResource API. So first, let's display the data using rxResource API, and then we will move on to using the resource API. But what's important to remember is that both resource and rxResource API serve the same purpose. However, they have unique technical approaches. The main difference between them lies in how they manage asynchronous data. And as I said in the beginning of this topic, resource API works with promises, whereas rxResource API works with observables. So let's begin by exploring the syntax of rxResource API. So inside this service file, instead of this getAllData method, let's create a new variable called rxResourceData equals to, I'll assign the value returned by the rxResource API. And we need to import this rxResource from angular/core/rxjs-interop. Now inside this rxResource API, we need to pass an object with a loader function. And this loader function will be an arrow function that makes an HTTP GET request to the specified URL. So I'll copy this same HTTP GET request from line number 15 and I'll paste it to line number 19. So just like before, this HTTP.GET method returns an observable. Now, normally a component needs to subscribe to the service data to retrieve the observable API data. However, rxResource automatically handles subscription and unsubscription to the observable. So as a result, we need to store this rxResource data variable in a local variable within the required component class file. So let me go inside resource API component.ts file, and here inside getData method, let me comment out these three lines, and below that we can simply assign API data to the resource.rxResource data. That's it. Now, if we open the browser, we won't see any data in the table. But if I open the developer tool and if I add the breakpoint in the TS file of resource API component, and now I'll refresh the page, press F10. And now if I over to this API data, there is a method called value. Inside template file, we need to bind the API data with .value method. So by doing this, we can access the data from resource and rxResource API. Now save the changes and let's refresh the browser. Let me remove this breakpoint. You can see the data is now displayed in the table. But remember, this data is coming from rxResource API. Because inside service file, you can see we have used rxResource API to handle the HTTP request. Okay, so I hope this explanation was clear. Now next, let's move on to the resource API. And similar to the rxResource data, I'll create a new variable called resource data equals to, this time I'll use the resource API. So instead of rxResource, I'll write resource. And inside this resource API, again I'll pass an object with a loader function, but this loader function defines an asynchronous operation that returns a promise. So this time I'll use the fetch API instead of this http.get API. And inside this fetch call, I'll pass this same API URL. And then I'll use the .then method to pass the response data as a JSON. So I'll use .json method with response. And finally, I'll return promise of type any. Okay, so let me break down this line of code. This fetch method sends an HTTP request to the specified URL, and this .then method is called after the response is received. And this response.json method parses the response data into JSON format. And last, as promise of type any is a type assertion, it tells us that the passed JSON data is returned as a promise of type any. Okay, so in summary, this loader function does three things. It fetches data from the URL, parses it as a JSON, and returns the result as a promise. Now, next step is inside the component class file, I'll store the resource data in a variable. And same we did for rxResource API. So let me open the TS file, and inside this, I'll copy this line number 26 and comment out for now. And here, instead of rxResource data, I'll use resource data. It means I am assigning the resource data to the same local variable API data. And inside template file, we have already bound the API data with the .value method, because as I mentioned earlier, when using the resource and rxResource APIs, we need to use .value method to access the data in the template file. Okay, so now let's test the output in the browser. And once again, we have access to the same data using the resource API. So the conclusion is both resource and rxResource API automatically handle subscription and unsubscription to observables, and we can use resource API for asynchronous operations that return promises, whereas we can use rxResource API for asynchronous operations that return observables. So I assume you should have a good understanding of how to send and retrieve data to and from a service file. Now next, we need to understand how to share data between components. However, before we dive into that topic, I wish to cover a small concept called reusable components. So what are reusable components? In Angular, a reusable component is a self-contained piece of code that represents a UI element or a group of UI elements. And its purpose is to be used multiple times throughout an application, making it reusable. So let's understand this with an example. Let me open new terminal and I'll create new component called reusable using command ngGenerate component reusable. Okay, now I'll open app.route.ts file and I'll add routes for the reusable component. The path name is reusable and for this path, component will be reusable component. Save the changes and in the app.component.html file, to save the space, I have added two drop-down menus to the navbar for directives and forms and moved relevant list items inside these menus. Under directive, I have moved structural directive and attribute directive, and under forms, I have moved template driven form and reactive form. And also I have added new atom to the navbar for resource API. But I'll not include the reusable component to the navbar. Instead, I'll reuse this functionality in other components. Now let me close these files and I'll open reusable component.ts file as well as HTML file. And next, I'll visit the Bootstrap website and search for the alert. So here, I'll copy this alert success div and I'll paste it inside reusable component template file. And then I'll modify this text to read. Inside bold tag, I'll write hello all, welcome to FAD Learning. Now save the changes and let me load the browser on localhost 4200/reuse. We are getting 404. Sorry. We have added the path for reusable component is reusable, not reuse. And now we can see an alert displayed in green. Okay. So let me go inside Visual Studio Code. And so far we have added an alert code inside this reusable component. But I want to add the same alert in other components as well. So instead of adding same code in all the components, I can reuse this component in other components, such as CRUD component, add user, update user, and view user components. And to do this, what I need to do? I need to copy this reusable component selector and paste it inside the required component template file. So I'll open CRUD component template file and here after this container, I'll paste the selector of reusable component. And since we are working on standalone component, I need to import the reusable component inside the imports array of same component TS file. So here I'll import the reusable component. Save the changes and let me open the browser. Let me go inside CRUD operations and here you can see the same alert. So now similarly, I'll add the same selector in app_user.component. Also, I need to import the reusable component and then I'll open the update user component. Here also I'll paste the same selector. Again, I need to import the reusable component in the update component class file. And last, I'll add reusable component inside view user component. Now save the changes and let me run the JSON server. And to run JSON server, we can use command JSON server --watch db.json. Enter and our server is started. Now reload this application and we can see the data. So this is our user list which is coming from this endpoint URL localhost 3000/users. And on top of this user data, we have implemented all four CRUD operations: create, read, update, and delete. So now, so far we have added the same alert on this add new user component, update user component, and view user component. So let me click on add new user component, and here you can see the same alert displayed on add user component. Similarly, if I click on update user, you can see the same alert, and last on view user, we can see the same alert. Let me adjust the width of alert inside view user template file. Let me add this width 50 on this first div, and let me remove this from here. Now save the changes, and yes, it looks good. I'll do the same changes on update. Let me cut this width from here and let me paste it here. Now let me click on close button, and if I click on update button, yeah, I can update the data. This is Gmail. And click on update. Similarly, I can add new user. I need to adjust the width for add user component. Let me go inside add user template file and cut this width from here and paste it here. Okay, now the UI looks good. But you will see the same alert message rendered on each component. If I click on add user, then also I can see welcome to FED learning. If I click on the update button, then also I can see the same message, and same for view component. And this is how reusable component works. You implement functionality in one component and reuse it across multiple components. But what if you want to customize the reusable component functionality for each component? For example, you wish to display the different message for different component, but in the same alert box. So in that case, we will need to enable component communication, means sharing data between components. And there are 5 ways to share data between component in Angular. So for now, let's understand the first way to share data between components, which is called parent to child component communication. So we will use input decorator to customize the reusable components functionality for each component. And in this example, I want to display a different message in the alert box for each component. So let's use @input decorator to achieve this functionality. So first let me close all the files, and I'll open only reusable component.html file and CRUD component.html file as well as TS file. Now let me focus on CRUD component template file. And since we have already inserted the reusable component selector inside the CRUD component template file, the reusable component becomes the child component and the CRUD component becomes the parent component. And to display a different message in the parent component needs to send the required data to the child component. This means the CRUD component needs to send the data to the reusable component. And then the reusable component will display the same data inside this alert box. But the updated data will only be displayed on the CRUD component page. So let's implement this practically. So first, I'll pass this message dynamically. And for that, I'll create a property inside reusable component class file called child property of type string equals to, I'll paste the same welcome message. And now instead of hard coding this message, I'll bind this property to the same component template file using string interpolation. So by doing this, whatever message we have added to this property, the same message will be displayed inside this alert box, right? And in our use case, we need to store the different message for different component inside this child property. Such as we want to display a different message for this CRUD component. And for that, CRUD component will send the required message to the reusable component. And to do this, inside the child component or inside the reusable component, we need to make this property an input property. And we do this by adding the @input decorator. I must be capital, and after input we need to add the parenthesis. And this input decorator we need to import from Angular/core package. Now this input decorator allows it to accept data from the other components. So in order to share data from parent component to child component, this was the first step we need to do inside the child component. That is creating an input property and binding it to the template file of the same component. Now, the second step is to bind the child component input property to the parent component's template file inside the child component selector using property binding. So inside square bracket, I'll bind this child component property. And then we need to assign it the value of a local variable in the parent component that holds the parent component data. So let me create a new property inside this CRUD component.ts file called parent property of type string equals to, inside double quotes, I'll store the required message for this CRUD component. And the message will be CRUD operations colon kindly find all users. Now let's provide this message to the child component by assigning the value of parent property to this child property. And that's it. Now save the changes. And when I access the reusable path, we can see an alert with the message, hello all, welcome to FAD Learning. But when I access the CRUD path, or if I navigate to these CRUD operations, you will see an alert with different message saying CRUD operations kindly find all users. Okay. So this is how we have sent data from parent component to child component using @input decorator. And what we did for that? First, we created an input property inside the child component called child property and bound it to the child component template file. And then we used property binding to the parent's component template file inside the child component selector. And finally, we assigned the parent property value to the child property. Okay, so now let's quickly add the same steps to the other component as well. So let me copy this line number 2 and let me open the add user component template file. And instead of this line, I'll paste this line. And now I need to copy this property from CRUD component class file. And let me open the add component class file. Inside that, I'll paste the same property with different message. This is of add user component. So let me write add user and message for add user, kindly add the user details. Save the changes. Let me do the same thing inside update component as well. Inside TS file, let me paste the same property. And now let me edit this message. Update user, kindly update the user details. Now inside the template file of the same update user component, I'll update this line number 2. Now same I need to do for view component. Inside template file, I need to update this selector, and inside TS file, I need to create the parent property. Let me copy this line number 14 and paste it. Let me update the message view user and the message for view user component. Kindly read the user details. Now finally save the changes and let's test all 4 alert boxes with different messages. So we are on CRUD component. So we can see an alert with message CRUD operations kindly find all users. Now let me click on add user component. We have added and I can add the new user by providing the value to this field. Vivek and vivek@gmail.com. And I have added the new user inside users list. It means our functionality is also working as expected. Now let me click on the update button. We can see the different alert message for the update component saying update user, kindly update the user details. And I can update the user details by adding a Ganesha, and you can see the name and username updated. Now last, let me click on the view button, and here also we can see the different alert message saying view user, kindly read the user details. Okay, it means everything works perfectly. And I hope you understand the concept of reusable components. And along with reusable component, we have also seen how to share data from a parent component to a child component using the @input decorator, which is one way to communicate between components. So to conclude, reusable components offer several benefits, including modularity, which means breaking down an application into smaller and independent pieces. Next benefit is reusability, which enables reducing code duplication by reusing components across the application. Next benefit is saving development time, which involves saving time and efforts by reusing existing components. Next is maintainability, which makes it easier to update and maintain individual components without affecting the entire application. And that we have already seen while demonstration, our CRUD operations are working the same as before. And the fifth benefit is consistency, which ensures a consistent UI and behavior across the application. Now next, to communicate between components, we will need to use some property decorators. So let's quickly understand the concept of decorators in Angular. And to understand decorators, we don't need to implement them practically. We just need to grasp the theoretical concept. And one important point to remember is that decorators are easily identifiable by the symbol prefix. So what are decorators in Angular? In Angular, decorators are special functions that allow you to extend or modify the behavior of classes, methods, or properties. And as I said, we can easily recognize decorators by the symbol prefix. In simple words, decorators are like labels or tags. They help us to identify and label different parts of our Angular application, such as here, we can easily recognize that this is a component. If I open any pipe, here also you can see @pipe, it means this is a pipe. Or if I open any service, here you can see the @injectable decorator, it means this is a service. Okay, it means decorators are like tags and we can easily recognize it with this prefix, and it helps us to identify and label different parts of our Angular application. And if we are not using decorators, we would have to write manual code to set up and configure each component, pipe, services, etc. So there is no need to write code for decorators. We can use them simply by adding this symbol. Now let's explore the different types of decorators available in Angular. And there are four main types of decorators available in Angular. First is class decorators. Class decorators are applied to classes to modify their behavior. And the example includes @component, @pipe, @injectable, and so on. Which means any decorator you see above a class is considered class decorator. For example, here you can see this @injectable decorator is above this CRUD service class. If I open the pipe.ts file, you can see this pipe decorator is present in above this custom pipe class. And this @component decorator is also above this CRUD component class. Therefore, these component, pipes, injectable are all class decorators because they appear above the class. And class decorators are used to modify the behavior of class. Now, next type of decorator is property decorators. Property decorators are applied to properties within a class and are used to modify their properties. And the examples include @input, @output, @viewChild, @viewChildren, etc. It means any decorator that appears before a property can be considered a property decorator. And we have already seen an example of input decorator while exploring the reusable component concept. Here you can see the @input decorator is written before a property or variable, and which is why they are classified as property decorators. Next decorator is method decorators. Similar to the class and property decorators, any decorator that appears before a method is considered a method decorator. For example, here let me create a method called onClick and I'll log one message inside that button click. Now, before this method, I'll add a method decorator called host listener. And inside the parenthesis, I'll pass the event name click. And now we are getting an error because this is the decorator. We need to use the @ symbol before this decorator and we need to import it from Angular/core. And now the error is gone. Okay. So in this example, the host listener method decorator is used to listen for a click event on a button. And when the button is clicked, the onClick method is called and prints button clicked to the console. Okay. So we can use method decorators to alter the behavior of class methods. Now let's move on to the last decorator called parameter decorators. Parameter decorators are used to modify or customize the parameters of a method. For example, we can use @inject decorator before creating an instance of a service. Like here inside this CRUD component.ts file, we have injected this CRUD service through the constructor. So here inside constructor before this private, I'll write @inject and inside parenthesis, I'll pass a CRUD service as a parameter to the @inject decorator. So this @inject decorator appears right before the parameter name in the constructor method, which is why it's called a parameter decorator. Okay. So if someone asks you about decorators in Angular during an interview, then you can answer decorators in Angular make it easy to mark and configure different parts of our Angular application in a simple way. And then you can explain these four main types of decorators. So by using decorators, we can avoid writing extra code, making it easier to build, manage, and scale our application. I hope you now have a clear understanding of decorators in Angular. Now, let's build on those concepts and dive into one of the most crucial topic in Angular called component communication. Under this topic, we will discuss the different ways to share data between components. First, what is component communication? Component communication is the process by which different components in an Angular application share data, interact, and coordinate with each other. So let's understand why is component communication required in Angular. Component communication is required in Angular because components are isolated, meaning each component has its own isolated scope, which means they don't have direct access to each other's properties or methods. Second, sharing data is necessary. In many cases, components needs to share data or interact with each other to achieve a specific functionality. Next, component communication is necessary for complex application. As applications grow in complexity, components needs to communicate with each other to coordinate their actions and share data. Next, reusability. Component communication enables reusability of components as they can be used in different contexts and communicate with other components. And last, component communication helps to decouple components from each other, making it easier to modify or replace individual components without affecting the entire application. So these are the key reasons why component communication is necessary in Angular. Now, let's explore the different ways to share data between components. And you may encounter this question in an Angular interview. What are the different ways to share data between components in Angular? Then your answer can be in Angular, there are 5 ways to share data between components. First, parent to child, sharing data from parent component to child component via @input decorator. Second, child to parent, sharing data from child component to parent component via @output decorator and event emitter. Third, sibling components, sharing data between siblings via input and output decorators. Fourth, parent to child. In this scenario, a parent component accesses and updates data in a child component and we will explore how to achieve this using the @viewChild decorator. And last, sharing data between unrelated components via a service. Now, let's understand each concepts one by one along with examples. And as you know, Angular is a component based architecture, and from Angular 17 onwards, each component is standalone by default. It means each component is independent, and to interact with each component, we need to establish communication between them. Like here, you can see we have a n number of components, and each component is standalone by default. And in Angular, we often communicate between parent and child components. But how do we establish this parent child relationship between these components? For example, consider we have two components, container and product. And to create a parent child relationship between them, you just need to insert the product component inside the container component. So by adding the product component inside the container component, we create a parent child relationship where container component becomes the parent and product component becomes the child. And now we can use the first two methods to share data between the container and product components, or we can say parent and child components. And our first method is parent to child. We can share data from parent component to child component using @input decorator. And we have already explored this concept while learning about reusable components. But we will review this concept with an example under this topic as well. Next, we will explore the second method for sharing data from child component to parent component. And this is the opposite of the first method, where we can share data from child component to the parent component using the @output decorator. Now, let's open Visual Studio Code Editor and implement both approaches. And the first approach is sharing data from parent component to child component. And to demonstrate this approach, I'll create two components, parent and child, using command ngGenerate component parent and ngGenerate component child. And first I'll set up the parent component HTML file. So here I'll take a div with container and text center class. And then I'll add one more div with class row and margin 5. Dot call 12 and then dot text warning. And now I'll add the heading inside this text warning div. And simply I'll add example of first and second. Inside round bracket, I'll add the method name parent to child and child to parent. Okay. Now after this div, I'll add one more div for new row. And inside this row, I'll add two columns, call 6 and then call 5. In between these two columns, I'll add one vertical line. For that, I'll use class .vr and I'll give padding 0. And inside first column, I want to render the content of parent component. So I'll add class text info. And inside that, I'll add heading h2 parent component. Alt Shift F, format the document. And now inside this second column, to make the child component a child of this parent component, I'll add a child component selector, app child. And you can find this selector inside child component.ts file. Here you can see the selector of child component. So I have already added the child component selector inside parent component template file. And also I need to import the child component inside the parent component's imports array. Here I'll import child component. Okay, so these two steps we need to do to render any component inside other component. First, we need to add the selector inside template file, and then we need to import the same component inside the imports array. Now, inside the child component template file, let's define the basic HTML structure. div.container.textCenter, and then I'll add this text info div inside the child component with heading child component. Now let's check in the browser. Okay, to load the component, I'll create a route for a parent component inside app.routes.ts file. Here, let me add one more route with path parent, and the component for parent path will be parent component. And after that, I'll add a link to the navbar. Here, let me copy paste the link, and here I need to update the path parent and this path for parent item. Okay, so this will allow us to navigate to the parent component by clicking on the navbar icon. Now save the changes, and when I navigate to the parent component, you can see this heading coming from the parent component template file. Here we have added example 1 and 2. After that, this parent component is also coming from this parent component template file, but this child component is coming from child component template file. So this confirms that our child component is also being rendered in the browser through the parent component. Now, in order to send data from parent component to child component, we need to use the @input decorator. So inside child component class file, let's create an input property called child input property of type string equals to, I'll initialize with an empty string. And now to make this property an input, we need to add the @input decorator prior to this property. And make sure we need to import it from Angular/core. And next, we need to bind this property with the same component template file using string interpolation. So after this div, I'll add one more div with class text warning. And here inside h4, I'll bind our input property, that is child input property. And here I'll add some margin 3. Now save the changes. And this is the first step we need to do in order to share data from parent to child component. We need to create the input property and bind the same property with template file. Now, second step is let's bind the same child input property in the parent component template file inside the child component selector using property binding, like this. And this technique is also known as custom property binding. Remember, earlier we studied property binding in the context of data binding, where we bound data to an elements property. However, in this case, we are creating our own custom property. Now after that, I'll create a local property of parent component class file called parent property of type string equals to, I'll assign it a value such as this is the parent component data. And then I'll assign the value of this parent property to the child input property inside the child component selector. Now save the changes and let's open the browser, and you will see the message displayed inside the child component. And the message is, this is the parent component data, but this message is actually coming from the parent component where we define in the class file. And we are passing this data from parent component to the child component using child input property. So I hope you understand this. First, we have declared one input property called child input property inside the child component class file. Then we bound the same property inside the child component template file. And third, we bound the same input property inside parent component template file within the child component selector. And last, assign the value to the parent property to the child input property, which means any data available in the parent property will be assigned to the child input property. That's it. Now let's move on to the second scenario where we will explore how to send data from child component to parent component. And to send data from child component to parent component, we will use @output decorator along with an event emitter. So inside this child component class file, let's create a new output property called child output property. And since this is the output property, we need to add @output prior to this property. And we need to import this from Angular/core. And we will set it to a new event emitter. Event emitter. This also we need to import from Angular/core of type any. So this is the syntax of output property. We need to write the @output decorator prior to this property and then set this property to a new event emitter. And here, why we are using the event emitter? Because we need to send data from child component to parent component through an event. So for that, first let me add a button inside template file. So below this div, I'll add one more div with class margin 3, and inside this div I'll add one button with class btn success, btn small, and margin 3. And the button name is send data. And after that I'll add a click event to it, and I'll assign one function send data. Means when this button is clicked, it will call this send data function. Now let's define the same function inside class file, and inside this function we will use the emit function on this child output property to send data from child component to parent component. So here I'll call child output property dot emit, and inside this emit we need to provide the value or data which you need to send to parent component. So simply I'll add this is the child component data and save the file. Okay. So what we did inside the child component, we have created an output property inside child component, and then we have created one button, and on click of that button we have called one function, and then we have defined the same function inside the class file of child component, and with the help of event emitter we are sending the data. So since we are sending the event from child component to parent component, we need to catch this event from parent component. And to do this, let me copy this child output property, and I need to add it to the child component selector inside the parent component template file using the event binding. So inside parenthesis, I'll paste this child output property. So here also we are creating custom event similar to this custom property. Now we need to assign this event to a new function called receivedDate and passing $event as a parameter to this function. Okay. Now let's define the same receivedData function inside the class file of parent component, and we need to pass parameter of type any or string, and inside this receivedData function we will assign this data to a local variable. So before that, let me create the local variable called receive message of type string. And now I'll assign this data to the receive message property. Okay. And last, to display this message in the browser, I'll bind this receive message variable to the parent component template file. So below this parent component div, I'll add one more div with class text warning and margin 3. And inside h4, inside string interpolation, I'll paste this receive message parent property. Now save the changes and let me open the browser. When I click the send data button, you can see the message from the child component displayed inside the parent component. Let me refresh the page and click on send data button. And we can see the message. This is the child component data inside parent component. Okay. So this is how the @output decorator works in Angular, allowing components to communicate with each other by emitting events. I'll quickly recap. We have created an output property inside the child component, and when the button was clicked, it emitted the required data. After that, in the parent component, we caught the event using event binding and passed the data to the function. And then we have stored the data inside local variable called received and display it in the browser through parent component template file. And with this, we have completed the first two scenario, sharing data from parent to child as well as from child to parent. Now let me switch back to presentation and explore the third method of sharing data called sibling components. This method combines the first two approaches using both the input and output decorators. This allows sibling components to share data in both directions. For example, let me add the pointer here and consider two components, child 1 and child 2, that wants to share data. And the common link between them is their parent component. So to share data from child 1 component to child 2 component, first, child 1 component send data to the parent component through an event using @output decorator. Then parent component sends the same data to the child 2 component using the @input decorator. And similarly, to share data from child 2 component to child 1 component, the same process occurs with child 2 component. So in this case, child 2 component sends data to the parent component through an event using @output decorator, and then parent component sends the same data to the child 1 component using the @input decorator. So in this approach, sibling components share data with each other through a common parent component using @input and @output decorators. So let's try this out as well. And to demonstrate this, how sibling components communicate, I'll create two more components called sibling 1 and sibling 2 using command ngGenerate component. Okay, Control C. And now I'll hit command ngGenerate component name sibling 1 and sibling 2. Now to make these two components sibling, I'll add them inside the parent component. So inside imports array, I'll import these two sibling components, sibling 1 and sibling 2. And then inside template file of parent component, I'll copy this row, first row, and paste it below this line number 23. And here I'll update the heading example of 3 sibling components. Okay, and after this div, I'll add one more div with new row. And here I'll again take call 6 and then call 5. And inside this, I'll add one vertical line with padding 0. And then inside this first call 6, I'll add the selector of sibling 1 component. And inside this call 5 div, I'll add the selector of sibling 2 component. Now let me open the browser. And here you can see the sibling 1 components rendered in the first column and sibling 2 components rendered in the second column. And by doing this, sibling 1 and sibling 2 are sibling components as well as children of the parent component. So now let's try to share data between sibling 1 and sibling 2 through the parent component. And as we have already learned, we can share data from child component to its parent using the @output decorator and an event emitter. So first we will send data from sibling 1 to sibling 2. For that, let me open the sibling 1 component template file and class file. And inside sibling 1 class file, let's create an output property. And remember, @input and @output properties are always created inside the child component, not in the parent component. Here you can see we have already shared data between parent and child, but we didn't add any input and output decorator inside parent component. We have added the property decorators inside child component class file only. Here you can see. So it means the input and output property decorators are always created inside the child component. So inside this sibling one component, let me create one output property called sibling one event equals to new event emitter, import from Angular/core of type any. We need to import this output as well from Angular/core. And now to send data through an event, we need to add a button inside sibling one components template file. So let me copy the child component template file and let me paste it inside the sibling one component. And now I'll update the text like heading sibling one component. And then for now, I don't need this. And I need a button. So I'll change the button name to submit. And when submit button is clicked, this will trigger the click event. Okay. And here I'll add one input box and I'll provide the ID to this input box like sibling one. And now when the submit button is clicked, it will call the onSubmit function. So here let me change the function name to onSubmit and which will get the value from this input box. So I'll pass the parameter id.value and id is sibling one. It means we can type any data inside this input box and we will retrieve it using id.value. Okay. So next, inside TypeScript file, I'll define this onSubmit function, which takes a parameter data of type any. And inside this onSubmit function, I'll use the output property to emit the data. Sibling one event dot emit, and inside this emit, we need to pass the data. Okay. So from this sibling one component, we are sending data to parent component through an event. So inside parent component template file, we need to capture the event triggered by sibling one component. And to do this, we will use event binding. So let me copy this output property and paste it inside the sibling one component select. And we need to bind this sibling one event to a local function of parent component. So let's say receive event one. And inside round bracket, we need to pass $event. And this function will be called when the event is triggered. Now let's define this receive event one function inside the parent component class file with parameter data of type any. And inside this function, we need to assign this data to a local variable. So let's create a local variable sibling one data of type string or any. And inside this function, I'll assign this data to the sibling one data variable. And after that, I log this sibling one data inside console.log and I'll test inside console we are receiving data correctly or not. So let me clear the console and here if I type test message and if I click on the submit button, we can see the same message stored in the sibling one data variable. So this means we have successfully sent data from sibling one component to the parent component. Now next, we will send this data from the parent component to the another sibling 2 component using @input decorator. And since sibling 2 component is the another child of parent component, we will create an input property inside the sibling 2 component and then send data from parent component using property binding. So now let me open the sibling 2 component class file as well as the template file. And inside class file, first I'll create the input property @input round bracket, and we need to import this input decorator from angular/code. And the input property name is sibling2 property of type string equals to empty string. Now let's bind this sibling2 property to the template file of the sibling2 components. Before that, let me copy paste the structure of template component from sibling1 template file to the sibling2 template file. Here, let me update the title. This is sibling2 component, and here I'll comment out this div and uncomment this div, because inside this h4 tag we need to bind this sibling2 property. Okay, so what we did, we have created an input property inside class file of sibling2 component, and same property we have bound inside the template file of same sibling2 component. Now let me copy this sibling2 property and go back to the parent component template file, and we will bind the sibling2 property inside the sibling2 component selector using property binding. And we will assign the value of sibling2 property to the local variable in the parent component, and which already stores the data received from sibling1 component called sibling1 data variable. So let me copy this and assign it to the value of this sibling2 property. So this means we are assigning the data from sibling1 to sibling2 inside the parent component. And since we have already bound this sibling2 property inside this sibling2 component template file, any message sent from sibling1 component will be displayed inside the sibling2 component. So let's see the result in the browser. I'll send some test data from this sibling1 component. Hello, sibling1. And now I'll click on submit button. And as you can see here, inside sibling2 component, we are receiving the same data. So far, we have achieved the sibling component communication by first sending data from the sibling1 component to the parent using @output decorator, and then from the parent component to the sibling2 component using the @input decorator. Now let's repeat the same process to send data from the sibling2 component to the sibling1 component. So first, we will send data from sibling2 component to parent component using @output decorator. So to start, I'll create here output property called sibling2 event equals to new event emitter of type any, and we need to import this output decorator. O must be capital. Okay, so this output property will allow sibling2 component to emit an event and send data to the parent component. So next, inside template file of the same sibling2 component, I'll uncomment this div, and here let me update the ID sibling2. Here I'll change the button name to send, and the function will be on send. And here we need to pass the sibling2 dot value as a parameter to this function. Now let's define the same function inside the TS file with parameter data of type any, and inside this function we need to emit the data. So sibling2 event dot emit data. So this function will be triggered when the send button is clicked, and it will use the event emitter to emit the data entered in the input box. And now next step is to capture the event emitted by the sibling2 component inside the parent component template file. And to do this, I'll bind the sibling2 event inside the sibling2 component selector using event binding. And I'll assign this event with local function in the parent component called receive event 2. And inside parenthesis, I need to pass the $event. Now let's define the same function inside the class file of parent component. Here I'll pass parameter same data of type any And I'll create one more local variable with name sibling2 data. And now I'll pass this data to sibling2 data variable. Okay. So now the parent component has received data from the sibling1 and sibling2 components. Let's send this sibling2 data to the sibling1 component. So for that, inside sibling1 component, we need to create an input property inside the class file. So here, let me create an input property at the rate input space sibling1 property of type string equals to empty string. Let me import this input property. And now we need to bind this sibling1 property to the template file of sibling1 component using string interpolation. So here I'll paste the sibling1 property. Now finally inside the parent component template file, I'll bind the sibling1 property inside sibling1 selector using property binding. And I'll assign its value to the parent component's local variable called sibling2 data, which holds the data from sibling2 component. So let me paste this property here. And with this, we have set up the communication between the sibling1 and sibling2 components. Now let's test this third scenario end to end. First, I'll send from sibling1 component. Let's say greeting from sibling1, and I'll click on the submit button. We are receiving the data inside sibling2 component. Now let me send the different data from sibling2 component like greeting from sibling2, and now I'll click on the send button and we are receiving the same data inside sibling1 component. So it means we have successfully sent data from both sibling1 and sibling2 components and received them in the other sibling component. And this demonstrates a successful implementation of inter-component communication. So with this, we have covered the third approach to sharing data between sibling components. Now, let's move on to the another approach to sharing data between components. Let me go back to the PPT. And the fourth approach is sharing data from parent to child via @viewChild decorator. So in this section, we will explore how to update a child component data from a parent component using the @viewChild decorator. And we have two options to update the child component data from the parent component, such as @input decorator or a viewChild decorator. But it's important to know the difference between them. The @input decorator allows you to pass data from the parent component to the child component. On the other hand, the viewChild decorator enables you to update a child component's data directly from the parent component. And we have already covered the @input decorator. Now let's focus on using the @viewChild decorator. So what is viewChild? ViewChild is again a decorator in Angular that allows a parent component to access and manipulate a child component properties and methods. Or in other words, it is a property decorator that is used to get a reference to a child component or an element within a parent component. Now let's go back to Visual Studio Code Editor and try to understand how the ViewChild decorator works. And to demonstrate this, I'll add the reusable component inside the parent component. So let me copy paste the same div and I'll just reduce this margin to 2. It's also 2. And now I'll paste this div here with margin 2. And I'll update the heading. This is the example of fourth scenario. Parent to child using ViewChild. Okay. Now after this div, I'll take one more div with row margin 2, and inside this, I'll add the reusable component selector, app reusable. And then I need to import the reusable component inside imports array of the parent component class file. Reusable component. Okay. Now let me open the reusable component. class file as well as the HTML file. Okay. Now, to access the reusable component inside the parent component class file, we need to add a template reference variable to the reusable component selector. So with the help of hash symbol, we can add a template reference variable. So I'll write reusable. Now, with the help of this template reference variable, we can access this template inside the class file. So inside parent component class file, here I'll import the viewChild decorator from Angular/core package. And now I'll use this to access the HTML element of the same component. So let me write @viewChild, and inside round bracket, we need to provide the template reference variable, that is reusable, inside single quotes. Then create a local variable reusable component of type reusable component. Okay. So here I have created a local variable called reusable comp of type reusable component. And I have already imported this view child. Still I am getting error. Okay. Here we must be capital. Okay. Now, with the help of this reusable comp variable, we can access this HTML element. It means we can access the reusable component using this local variable reusable comp. And to load the viewChild related data in the browser, we should use the ngAfterViewInit lifecycle hook. So let me implement this hook first. Implements after view init. And then we need to define this hook, ngAfterViewInit. So why we need this hook in order to render this viewChild related data? Because this ngAfterViewInit is called once the entire application is initialized in the browser. Okay, so inside this ngAfterViewInit, we can update the reusable components property. So let me access the reusable component using local variable reusable comp dot. As you can see here, we can now access the child property as well as on-click method of the reusable component from the parent component. And if you go inside the reusable component class file, you can see one child property and one on-click method. So it means from parent component using viewChild decorator, we can access all the properties and methods of child component. So as of now, let me access the child property, and I want to update this property with message greeting from parent component. Okay, so only this code we need to add inside the parent component class file, and inside reusable component we don't need to make any changes because we have accessed it from the parent component and modified the existing property. Therefore, no additional coding is required inside the child component. Now let's open the browser, and we are getting an error, incomplete block view child. If you meant to write at the rate character, you should use okay. Inside the HTML file, we cannot write this at the rate symbol directly. Okay, now save the changes, and we can see the alert box with updated message greeting from parent component. Let me comment out this message, and you can see the previous message, hello all, welcome to FAD learning, which we have added inside this reusable component. But I can update this message from the parent component using viewChild decorator greeting from the parent component. Okay, so how the viewChild decorator works in Angular? The parent component uses the viewChild decorator to access the child component. And this decorator takes the child component's template reference variable as an argument, allowing the parent to reference and interact with the child component. And this template reference variable we have added to this child component selector. And then parent component can access the child component properties and methods using the viewChild property. And last, parent component can share data with the child component by updating its properties or calling its methods. Therefore, When to use ViewChild decorator in Angular? You can use ViewChild decorator in two scenarios. First, to access the child component data inside the parent component, and second, to access the template element within the same component class file. Okay. And what is the difference between @viewchild and @input decorator? Both are the property decorators, but the viewchild decorator allows a parent component to access and update a child component's properties or method. In contrast, the @input decorator enables a parent component pass data to the child component. So to share data from parent component to child component, we can use @input decorator. And to update the child component data from the parent component, we can use viewchild decorator. Now last, let's discuss how to share data between unrelated components. This means sharing data between components that don't have a parent-child relationship. And as we have covered earlier in this series, the solution is to use shared service. This allows us to share data between unrelated components using a common service. And to do this, first we need to create a service that holds a shared data. Then we need to inject the service into the components that need to share data through their constructor. And then component can access and update the shared data through the service. And I'm not going to cover the example of service here because we have already covered this in our previous topics. So with this, we have covered the component communication in Angular with practical examples. So in our Angular 19 series, so far we have covered nearly all the essential concepts. Now we will dive into the world of storage in Angular, covering three important topics: session storage, local storage, and cookies. So let's start with session storage. Session storage in Angular is a way to store data temporarily for the duration of a browser session. And it allows you to store key value pairs that can be accessed and manipulated throughout the application. This means session storage in Angular is like a temporary memory for your application. It stores small bits of data like a username or a setting only while you are using the application. When you close the browser, the data disappears. So the key feature of session storage in Angular are temporary storage, means data stored in session storage is deleted when the browser tab or window is closed. Next, key value pairs. Session storage stores data as a key value pairs, making it easy to access and manipulate. And last, accessible throughout the application, which means data can be accessed from any component or service in the Angular application. Now let's talk on when to use session storage. We can use session storage for temporary data storage that doesn't need to be persisted across browser sessions. Second, form data. Storing form data to retain user input even if they navigate away from the page. And we can also use session storage for storing navigation history within a single tab. Next, to use session storage in Angular, we use the session storage object, and this object has four simple methods. First method is setItem, session storage.setItem. This method stores a value. Second method is getItem, session storage.getItem. This method is used to retrieve a stored value. Third method is remove item. Session storage dot remove item. It deletes a stored value. And last, clear. Session storage dot clear. It deletes all stored values. So these methods make it easy to work with session storage in your Angular application. Now let's switch to Visual Studio Code Editor and try out all four methods. And in our Angular 19 project, I have created new component called storage and added a root for it inside routes.ts file. And also I have added the link to the navbar inside app.component.html file. So if I open the browser and when I click on storage in the navbar, I can navigate to the storage component. So let's start coding in the storage component HTML file and TS file. Let me close this router.ts file as well as the app component.html file. And inside the template file of storage component, I'll start by adding the basic HTML structure. Div with container dot text center, and inside this div, I'll add one row with class margin 4, and inside this, I'll add one more div with call 3. And now I'll create 4 buttons, each representing one of the session storage method. So here I'll add first button with class btn info, and the button name is set session. And also I'll add a click event to this button and assign the set session method. Now I'll repeat this call 3 div 3 more times for the remaining methods. Close this terminal and let me update the button names. This button is for get session with method get session. Third button is for remove session with method remove session. And last button is for clear the session with method clear session. And also I'll add one heading here inside h4. I'll add session storage with class text info. Now next, let's switch to the TypeScript file and define these 4 methods like set session and then get session, then remove session, and last clear session. Now, inside each function, we need to call the respective method. And as we discussed earlier, to use session storage in Angular, we need to use the session storage object. The session storage dot, once I press dot, here you can find the set item method, and which accept 2 parameters, key and value, which is of type string. So I'll pass key as a name, comma. For this name key, I'll pass the value session. And similarly, we can pass the multiple key value pairs using the set item methods. For example, I'll add another pair with key pass and the value session123. So in this way, you can store as many key value pairs as you need. Now let's move on to the get session method. And here we can retrieve the stored value using the get item method of session storage. For example, session storage dot get item, which accept 1 parameter key, which is of type string. Therefore, I'll pass the name inside this round bracket with quotes. And to display this value in the browser, I'll create new variable called session value of type string equals to empty string. And now I'll store the retrieved value in the session value variable. And to display the retrieved value in the browser, I'll bind the session value variable inside the template file. Like here, I'll use if control flow statement @if, and inside round brackets, I'll pass the variable session value. And inside this if block, I'll write session value. Using string interpolation, I'll bind the variable name session value. Alt Shift F, format the document. And now I'll switch to the class file, and inside remove session method, again I'll use the session storage object dot remove item method, and this method also expect one argument key which is of type string. So here I'll pass another key called pass as a parameter to this remove item method. And finally, inside clear session method, I'll use the clear method of session storage object, session storage dot clear and round brackets. And this method will remove all the key value pairs that are currently stored in the session. And after calling this clear method, I'll assign an empty value to the session value variable to reset it. So far, we have added 4 buttons inside the template file and added one if block to see the session value in the browser. And inside TS file, we have defined all four methods. Now let me open the browser and test all four methods. And to do this, we need to open the developer tool and navigate to the application tab. And here under the storage section, you will find the session storage. Inside this, we need to click on this localhost 4200 and you will see the table with two columns, key and value. And this is where our session values will be stored. So now I'll click on the set session button, and as you can see, the two key value pairs have been stored in the table. First name with value session and second pass with value session 123. Now, if I click the get session button, we can retrieve the value of name which is displayed in the browser through the session value variable. Next, if I click the remove session button, we can delete the past session from this table. Here you can see now we have only one session in the table. And finally, when I click the clear session, we can completely clear the session by removing all the keys and values from the table. I'll reset the session on click of set session and I can clear the session on click of clear session button. However, if I open another browser and run the same application on localhost 4200, and here also if I check the application tab inside developer tool, I won't see the sessions. So first let me click on set session and let me split the browser, and now you can see here. Let me clear the session from this browser as well. And now you can see both tables are empty. But in this first browser, if I set the session on click of the set session button, but inside the second browser, I won't see the sessions we set from the other browser. So this indicates that session storage only stores information for that particular browser. Once you leave the browser, the sessions get deleted. So using session storage object, we can store sensitive information like login details, which gets deleted when you close your browser. But if you want to keep the stored information even after closing the browser, then instead of session storage, you can use local storage. Local storage allows you to store data that persists even after the browser is closed. So now let's go back to the presentation and learn more about local storage. Local storage in Angular is a way to store data locally on the client side, even after the browser is closed or the user navigates away from the application. Like session storage, local storage also allows you to store key value pairs that can be easily accessed and manipulated throughout the application. So the key feature of local storage include persistent storage or permanent storage. Data stored in local storage remains available even after the browser is closed. And we use local storage for three main purposes. First, storing persistent data that remains available across browser sessions. Second, saving user preferences. And third, caching frequently accessed data to speed up the application performance. And to use local storage in Angular, we can work with the local storage object, which is the part of browser's web storage API. And similar to session storage, local storage provides four methods to manage data. First method is local storage.setItem. It stores a value in local storage using a key value pair. Second, local storage.getItem. It retrieves stored data using the corresponding key. Next method is local storage.remove item. It removes stored data using the corresponding key. And last, local storage.clear. It clears all data from local storage, removing all key value pairs. So let's quickly try this as well. And inside template file, let me add a horizontal line using the HR tag. And then I'll copy paste the same code and I'll update the button name and function name. So instead of session storage, I'll write local storage, and here also instead of session, I'll write local. And this time I'll use green color for text as well as button. Success. Here, instead of session value, I'll write local value, and I need to declare this local value variable inside the TS file. Now, inside TypeScript file, first I'll create the variable called local value and initialize it with empty string. Next, I'll copy paste the same four methods and update their names to reflect the change from session storage to local storage. L should be capital. And this time, instead of using session storage object, I'll use local storage object. And to clearly see the difference between session storage and local storage, I'll use different key value pairs. So the first key will be username with value local, and second key will be password with value local 123. And inside this get local method, let me update the key name, as well as I'll update the key name inside remove local method. Okay, so we did the same thing for local storage as well. We have added four separate buttons for local storage and defined respective methods inside TS file. And inside this clear local method, I need to clear the value of local value variable. Now let's test this local storage in the browser. And similar to the session storage, we can find local storage in the application tab under the storage section. And when I click on this localhost 4200, you can find the same table with two columns, key and value. When I click the set local button, the two key value pairs are added to the table. First key username with value local and second key password with value local 123. Now, when I click the get local button, display the local username value inside the session storage space. I forgot to update this inside the local storage. So here, instead of session value, I need to write local value. Now, if I click on get local button, you can see the respective value displayed in the browser. And on click of the remove local button, it deletes the password key value pair from the table. And when I click the clear local button, the table becomes empty. However, if I reset the values from this browser by clicking the set local button, and now if I open the another browser here, let me go inside local storage, and here you can see the data is stored in both browsers. Let me change the order, username password and username password. And if I click on remove local button from any browser, it deletes the password data from both browsers. And if I click on clear local button, it clears the local storage in both browsers. So this demonstrates that local storage data is stored on the computer and persists even after closing and reopening the browser. And in contrast, if I go inside the session storage data is specific to a single browser session and is not shared across multiple browsers. As you can see, when I reset and clear the sessions, the changes only affected to the current browser and are not reflected in the other browser. So there are two types of storage in Angular, session storage and local storage. Session storage used for session storage, where data is stored temporarily and deleted when the browser is closed. Whereas local storage used for local storage, where data is stored permanently and retained even after the browser is closed. So the main difference between session storage and local storage lies in how long the data is stored. But note that local storage only stores data on the client side, that is in the user's browser. However, if you need to communicate with the server, you will need to use cookies. So now let's move on to understanding cookies. In Angular, cookies are small pieces of data that are stored on the client side and sent to the server with each HTTP request. So here, cookies have three key features. Small data storage. We can store a small amount of data like up to 4 KB. Second key feature is client side storage, means in the user's browser. And third feature is sent with HTTP request. We can send data to the server with each HTTP request. So when to use cookies in Angular? Cookies are idle for storing authentication tokens or session IDs to verify user identity. And we can use cookies to store user preferences like language settings or theme choices to personalize their experience. Also, cookies can be used to track user behaviors or analytics, helping you to understand how users interact with your application. And to work with cookies in Angular, we can use a library like ngx cookie service, and we can easily install it using npm command. After installation, we will have three main methods to manage cookies in Angular using the cookie service provided by the ngx cookie library. So the first method is .set method, which sets a new cookie with specified name and value. Next, we can use the .get method to retrieve the value of cookie with the specified name. And third method is .delete method. It deletes the cookie with specified name. So these three methods provide a simple way to work with cookies in your Angular application. So let's go back to Visual Studio Code Editor and we will try to implement these three methods of cookies. So to work with cookies in Angular, we need to install the cookie service using the command npm install ngx hyphen cookie hyphen service. So here, before I hit enter, let me open package.json file, and here I'll find ngx cookies. You can see no result with this name. Now I hit enter, and after running this command, we can verify that the ngx cookie service package has been added to our project in the package.json file. Now next, to use the cookie service in the storage component, we need to create an instance of cookie service by adding it to the component constructor through dependency injection. So here I'll write private cookie cookie service, in which we need to import from ngx cookie service package. Okay. Now we have the cookie service instance. So we can use this local variable cookie to access the set, get, and delete cookie methods. So first let's update the template file. And again, I'll add one horizontal line and I'll copy paste this local storage row under the cookie. So here instead of local storage, I'll write cookie. And since cookies only require three methods, so I'll remove one div and I'll update the method name with set cookie, get cookie, and delete cookie. And the button names for these methods, set cookie, get cookie, and delete cookie. And I'll change the variable name for cookie is cookie value. Same I'll update here and here. And this time instead of success, I'll use the different color warning. Same I'll paste for buttons. Let me test this in browser. Okay. Before that, we need to define the methods inside TypeScript file. So let me quickly define three methods inside the TS file with name, set cookie, get cookie, and delete cookie. And also I need to declare the variable for cookie with name cookie value. Now save the changes. And if I open the browser, we can see three buttons under cookies. Now, inside these three methods, instead of using local storage methods, we need to use the cookie service that we injected into the constructor. So here I'll use cookie dot set method, and inside parenthesis we need to pass the name and value. So I'll pass token1 as a name and I'll pass 1, 2, 3, 4, 5 is a value for this token name. Similarly, I'll set another cookie named token2 with value xyz. Now inside get method, I can retrieve the value of this token1 or token2 cookie. So I'll write cookie.get and inside parenthesis, I'll pass the cookie name token1. And now inside delete method, I'll delete the token1 cookie. So cookie dot delete, and inside parenthesis I'll pass same token name token1. And after this delete method, I'll assign empty string to the cookie value variable. Okay. Now save the changes and let's test all three methods in the browser similar to how we tested session storage and local storage. So to view the output, we need to go inside the application tab again and we need to click on cookies under this storage. Here you can see. So let me click on this localhost 4200. Here you can see the table with multiple columns, name, value, domain, path, expiry, etc. So let's start by clicking the set cookie button. I need to refresh the cookie. And now we can see the token name and value listed in the table. And here we can see the domain name localhost. And additionally, we can set the expiry date for the cookie by adding comma and specifying the number of days. For example, here I'll add 1 means the cookie will expire in 1 day. So I have added 1 day expiry to the first cookie. Save the changes and we need to refresh the cookie. And here you can see the expiry date is added to this first cookie. Now let me click on the get cookie method. And again, I forgot something about get cookie. Okay, here we need to store the cookie inside cookie value variable. Now I'll click on the get cookie method and here we can see the value of token1. Now finally, let's click on the delete cookie button. Then I need to refresh the cookie. And after refreshing the cookie, we can see the token1 cookie has been deleted from this table. But if you want to delete all cookies at once, we can use delete all method. So here I'll comment out this delete method and instead of delete, I'll use delete all method. And for delete all method, we don't need to pass any parameter. Now save the changes and let me reset all the cookie. And now if I click on the delete cookie button and if I refresh the cookie, you can see both cookies has been deleted. And in Angular, if I run the same project in another browser, I can still see same changes in the cookies similar to local storage. So let me go inside application and under this cookie, right now the table is empty because from the other browser, I cleared the cookie. So now I'll set the cookie on click of the set cookie button, then I'll refresh the cookie. Now if I open the another browser, here I need to refresh the cookie and we can see the same cookies in the other browser as well because cookies are domain specific, not browser specific. Therefore, both local storage and cookies are used to store data on the client side. However, they serve different purposes. Local storage is suitable for storing larger amount of data that don't need to send to the server. On the other hand, cookies are better suitable for storing smaller amount of data that needs to be sent with each HTTP request. So I hope this explanation has helped you to understand the concept of session storage, local storage, and cookies in Angular. Now let's quickly summarize the differences between session storage, local storage, and cookies. First, let's discuss duration. Session storage stores data temporarily for the browser session. Local storage stores data permanently or persistently even after the browser is closed. On the other hand, cookies can be either persistent or session based storage. Next, from the security perspective, session storage data is deleted when the browser tab or window is closed. Local storage data is not deleted automatically. In contrast, cookies are sent to the server with each request. Moving on to the storage limits, session storage and local storage have a higher storage limit of around 5 MB. In comparison, cookies are limited to 4 KB. Lastly, regarding accessibility, session storage and local storage are accessible only from the client side. In contrast, cookies can be accessed from both client side as well as server side. So we can utilize these storage options such as Session storage is ideal for storing sensitive information such as login details, which gets deleted when the browser is closed. Next, local storage is suitable for storing data like shopping cart items on the client side, which remains even after the browser is closed. And last, cookies are helpful for websites to recall user preferences, such as login information or shopping cart contents, providing a seamless user experience. So now you have learned about these concepts and we have already practiced CRUD operation using JSON server. So I would like you to apply your knowledge by creating your own CRUD operation from scratch. For storage, use either local storage or cookies and implement create, read, update, and delete operations on top of stored data. So finally, we have come to the end of this tutorial. I hope you found this video informative and now feel more confident about working with Angular. Additionally, to help you further, I have pushed this complete Angular 19 tutorial source code on GitHub and included the link in the description below. But if you still have questions, feel free to leave a comment and keep practicing. Thank you for watching this video until the end. I appreciate your time and support. We will meet again in the next video. Until then, keep visiting and keep learning. Thank you. Bye bye.